Well, it's 5 after, Emily. I think we're ready to get started. We have 126 on there.
Sounds great to me. Let's get going.
Okay, all right, we'll call this the official start time. And just go ahead and get going. Want to thank everybody that is currently on and are continuing to sign in. We're hoping to have a couple hundred, which is great. It's about where we've always been, considering Nevada and Utah. So we want to welcome you to the 25th annual 2021 virtual users group. This is our 25th and hopefully our last virtual users group. Hopefully that will be the case, although there are pluses and minuses to this format, and we're all very used to meeting like this now. But personally, I kind of hope that we'll be meeting traditionally next year. So if you've signed up and seen our invitation, you should have gotten the agenda from us, and you can see the outlay of the day as we start to go through these presentations. We have some great material that we hope you will find not only interesting, but also valuable in your profession and in your ability to be more profitable in your businesses. There are a few things that we need to go over, just some housekeeping items as we start out here, just to make sure that everybody's on the same playing field. First of all, logins. So everybody that is attending should have their own login, and we would hope that every attendee would have used their own login to get onto the meeting. We do this because we need to make sure that we keep track of who is getting their PDHs and who to send those to for continuing ed. And also, we are going to be doing lots of polls, basically a poll after every presentation, and you want to be a part of those polls because that is how you are going to win prizes. And we're going to give away hundreds of dollars today. Every time we do a giveaway, it'll be a $50 gift card. And we're going to draw the winners of those gift cards from the poll questions. And so you need to have your own login, and you need to take advantage of those polls. And they're super easy questions, no problem. So make sure you answer so you can potentially win. Next thing, breaks. You'll notice if you can see the agenda there that we're not going to have any breaks. And so we did that on purpose. We know that with Zoom, people take breaks whenever they want, and so we're just going to cruise through this. However, though, through the ebb and flow of the different presentations and so forth, I'm sure there will be some break time. We just didn't want to lengthen out the day and all these meetings. It's already going to be pretty long, and so that's why that is the case. We do have a lunch break though, so we do have a short lunch break, so you can schedule that and just be expecting that in the middle of the day there. All right, questions. Typically, we're going to reserve question and answers for the end of each presentation. That we want to have a Q&A session, live Q&A session at the end of each presentation. However, we would suggest that during the presentation, if you have questions, that you type those into the chat window, and we'll collate those questions, and at the end of the presentations, we'll go through those, and that way we can make sure that if there's redundant questions or something like that, then we can act appropriately. And if time allows, these questions can become a discussion, and we can unmute users or attendees. We can unmute them, and obviously you can have some real-time dialogue. So the key here is there will be Q&A, and use that chat window to put those questions in. Don't mean to state the obvious here, but you can chat with others as well. Just make sure that you keep your public notes appropriate, and just be aware that sometimes everybody might be able to see those. Okay, next presentations. So we'll be making the presentations, all the ones that are going to be performed today. We'll be making those available to all the attendees to watch later. So we're recording this whole thing, and so you can get on later, and you can, and we'll be emailing that link out, and you'll be able to watch these presentations again if you would like to. Drawings. So I mentioned this already, but like I say, we're going to be doing lots of drawings. There are, the $50 gift cards. We're going to do hats. And then at the end, we're going to have the grand prize giveaway. And you'll see some pictures of that here. But it's a restored theodolite. It's kind of a cool model. It was a dumpy level that you could make a theodolite. And so it's kind of this, and it's been restored by our chief technician, Marty Crook. And so it's beautiful, and it's something that you could definitely and would want to display. It comes with a tripod and the case and everything. So we'll be showing you that. That's the grand prize giveaway. And we've already talked about the poll questions and how those giveaways are going to go. Make sure that you answer. Okay, we already talked about continuing ed. The continuing ed certificates, we're hoping to get those out before the end of the week, but it might be a week before you see those. So if you haven't seen them in 10 days, let us know, and we'll make sure that we get you your certificate if you somehow slip through the cracks. Yeah, give us some time there, but hopefully you'll be seeing them here real soon, and you'll be able to have your continuing ed there. Just a couple other notes. Interestingly, through just serendipity and chance, we're doing this presentation during National Survey Week. And not only that, but today is Global Surveyors Day. And so I feel like every day ought to be Surveyors Day personally, but today it is officially Global Surveyors Day. And so there's some activities and so forth and ways that you can be involved in National Survey Week and Global Surveyors Day, and try to make our industry a little bit more, put our industry out there a little bit more for the general public. And we'll be posting some links as well on that in our meeting email. All right, as part of the Campbell companies, whenever we do a meeting, we always do a safety share at the beginning of every meeting. And I'd like to just share a quick story. It's a story about the tiny mobile robot. What I'll do here is I'll share this screen. And hopefully this will work. Might have to be made the presenter though.
I just made you co-host.
I hope you guys can see that okay. This is an article about the tiny mobile robot, TinySurveyor, and how it saved a life. And basically, this is actually one of the real benefits of the TMR robot, was what we call it, the TMR. And in this particular article, you can see here that as opposed to the surveyor standing in the middle of the road, the TMR was in the middle of the road doing its job, painting, pre-marking lines and so forth on the road, and was hit by a car going, I think it says there, going to 40 miles an hour. And so, can you not see this?
No, we're not seeing the image,
bottom
Troy.
corner is showing that article, but it's not showing the whole screen as that article, Troy.
How about now?
There you go. Now we got it.
Perfect.
So safety is a top priority for Monsen as well as all the Campbell companies and for all of our customers. And so every opportunity that we have to try to make our environment a little bit safer, we're going to try to take advantage of that. And the TMR is a great example of how we can make that happen. All right, let's go ahead and move on. Go ahead and stop sharing there.
Troy, are you ready for me to share the TMR video?
Yes, I think,
Okay.
oh, well, one moment.
Great.
So yeah, let me just go ahead and just introduce this really quick, or maybe you were going to do this, Emily, but this video that we're going to show is made by one of the users of the TMR called the Austin Road and Bridge Company. And they were one of the first adopters of the TMR technology. And this video is kind of just an actual real world application of how they've been able to use that technology. And then we'll go ahead and we'll go into Chad's bio and presentation after that. Okay, Emily?
Sounds great.
Austin Bridge and Road continues to use breakthrough innovation and
Let me try that again. One moment.
technology.
Nope. All right, hold on. Let's try this again.
Austin Bridge and Road continues to use breakthrough innovation and technology, combined with its long history of operational excellence in asphalt paving. The Austin Bridge and Road Survey Department uses its RDM1 mobile scanner before construction begins on mill and overlay projects. They then generate line work from the scan data and upload it into Austin Bridge and Road's latest field technology, the Tiny Mobile Robot, or TMR. Based on advanced robotic software and artificial intelligence, this tiny, reliable outdoor robot performs high-precision marking and stakeout. Once the roadway has been milled and overlaid with new asphalt, the TMR marks the exact location for striping in a fraction of the time it takes using traditional methods. How efficient is this robot? Conventionally, a 3-person crew would mark out 30 feet per minute, while in the same time, our robotic friend marks out 275 feet, and with fewer people. Said another way, what takes 3 people nearly 3 hours to lay out 1 mile is now done in 20 minutes by the TMR and 1 person, freeing up personnel to add value in other areas of our operation. Committed to safety, we benefit from the TMR's semi-autonomous capabilities when marking lines adjacent to live traffic and removing employee owners from these high-risk work environments. Building on our core values, safety, integrity, service, and employee ownership, Austin Bridge and Road continues to drive innovation and excellence, keeping us miles ahead.
Okay, thanks for that, Emily. Way to figure that out. All right, let's go ahead and move on. Our next presenter, Chad Hill, with Provo City, has volunteered to present for us. Let me just tell you a little bit about Chad. Chad is a PLS with 15 years of surveying, drafting, design experience. He has worked in a variety of private, public, oil and gas positions. Currently, he is working as the city surveyor for Provo. Chad is currently a board member of the UCLS, and is president of the Timpanogos chapter. He also has served as a member of the Utah Valley University Geomatics Advisory Board. Chad and his wife, Jamie, have 5 wonderful kids. He enjoys being outdoors with his family and friends and is always up for a Jeep ride, especially if there's a chance to get muddy and or stuck. And Chad is using his background imagery, so he is outside. And so he's following true to his theme there.
Right.
So let's go ahead and turn it over to you, Chad. Thank you for being here, and tell us a little bit about what you've been doing with the TinySurveyor.
You bet. Can you see my presentation, Troy?
Yes, sir.
Okay. You kind of stole a little bit of my thunder with the video that you already showed, but I'm going to go back a little bit. It was, I don't know, it was probably about a year, maybe a year and a half ago. Troy invited several of us to come up and do a quick demo of the TMR on a job site out by the old Monsen building downtown, and we went and we were watching it do a topo of a site, and we were demoing it and doing different things with it. And I remember talking to Andy Hubbard from Great Basin, and I told Andy to go ahead and buy that and tell me what he thought. And he told me that I was going to be the first one to get it, and I told him he was up in the night. And as things would happen, I applied for a grant. I received a grant, and we received enough money to purchase the teeny mobile robot, and we picked it up about a year ago, and we've been using it all kinds of different ways. I'm going to go through some of the different ways that we've been using it, some of the pluses that we've found with it, some of the little hacks that we've used to make sure that it's working properly. And I know Jens is on here as well, or Jens is on here as well from Europe. And so if I speak anything or say anything wrong, go ahead and just correct me at the end, or we'll go from there. Let's see, I'll click on this. All right, so this is our TMR. What's cool is they come with the serial numbers. They actually come with a name. Ours is named Sylvester, so we properly put a sticker on him to represent one of my favorite movies, Rambo. And so he goes out, and we turn him loose on all of our projects. As far as striping goes, that's the #1 priority that we've been using him for. We use ours with an R10. It can be coupled with anything newer than that, but as Troy mentioned in the safety thought right before this, you can control this from a safe distance. This was one of my big pushes when I applied for my grant, that this was going to provide a safer way to stripe roads. Provo City, we do all of our own road striping and marking. And traditionally in the past, it would be our crew going out, and we would mark where we want the tabs with the GPS. And so you had a guy with his head down, then you had a guy kneeling down. Oftentimes we were doing this outside of traffic control, and so it was pretty dangerous to do that. So this has provided a very safe opportunity for us to do the same work more efficiently and faster, as it showed in the video before. It uses state plane, so we get a tablet. You get a tablet with the TMR. The tablet's really it's pretty idiot proof. It has only the program on there to run the TMR, and so you download a Dxf file onto the tablet. And then as soon as you're logged in, you can upload an image behind there, and you can make sure you've got the right image, your right location, and you select each one of the lines, individual lines on the Dxf, to make sure that you're painting it where you want it to, or marking it where you want it to. There's some different options that you can do. You can adjust the speeds and the distances of how you want to paint the striping, or whatever you wanted to do. This is a kind of an aerial view of a project that we were doing last year. We did a mill project. We milled this road on 920 South in Provo, and after we milled it, we were going to go back in and put all the striping in after the fill was done on that area. So this is what our plans look like. to do that. And one of the things that I'll go through this in a little bit. One of the hacks that we figured out is when we're doing our design work, we'll make sure our lines are the color that we want to paint them on the road on our DXF. So if we're going to be painting white lines, they obviously show up dark here, but they are white lines. So we'll show our white lines and our yellow lines. And then when we export our DXF of these polylines, they're the right color. And that's one of the hacks that we figured out, is that way when we pull it into our tablet, they're actually the correct color of what we're selecting. And so when we select on that line, we know we're selecting a yellow or a median line or a white line or a bike line or whatever we're wanting to paint. And so we'll select that line in the DXF, and then basically you select the line, you select the direction you want the line to start from your location, and then you hit go. And this is a quick video. This is our own hack video of how we did it. I don't have any fancy music with this. This is us flying this with our drone. This is our crew out on the same road. I'm going to hit play on this and I'll kind of talk along. This is the second day after we had received this, after we received Sylvester. Ryan had already left for the day, and we had loaded our first DXF on here, and we hit go. You can kind of see that I've already painted it once. And then I'm just going back and I'm just checking making sure the reliability of where we were painting it. As I'm going down through here, this is just painting a center line of it. One of the things that we've done since this was our first day, we actually changed the paint color now. So every time we paint a different line, if we're painting a white line or a yellow line, we'll actually change the paint color on the canister in the back of Sylvester. And it helps when we're striping it, in case of our tabs come up, that we do have a yellow line or a white line painted. One of the great things about this is you can see I've got this adjusted to being about 10 feet on the spacing of the paint marks of this. We found that 10 feet is about the most optimal one. It uses the longevity of a paint can will last 2 or 3 miles off of us painting lines back and forth. Also, when you're doing a 10-foot, it picks up all the on the radius on your tangents and everything. When you hit that radius point and you go around the radius, it gives you enough points on there to make sure that you're hitting that whole radius, and then you can follow it. As you can see right here, it's actually started to veer off to mark our turn pocket. And so I had selected the inside yellow line on this, and so it's veering off. Obviously, I'm going into live traffic right now. This is, again, a learning curve. We're trying to figure this all out, and we had to keep 2 lanes of traffic open, and this was the only way we could do it. So we actually did stop traffic behind me. You can't see at this point. And so we'll get this turn pocket painted. I'm just about coming up to the intersection right here. It'll get to the intersection, it'll stop, and then I'll jump over and I'll paint the other portion of the turn pocket. Again, this is where, in the way we do it now, we would normally be painting this. This would be a yellow line. Then I would jump over, I'd switch the can, I'd dump a white can in, and then we would paint the other portion of the turn pocket. And you can see a little bit of the striping from the original road, and you'll see I'll tie right into that. We will either fly these roads with a drone and pre-mark and map all of the striping in the beginning, or we will before they mill it, we will go out with the GPS and just mark all the points on the road so that we can recreate the striping. A little bit of a learning curve. It does go both directions, and so it's like a big remote control car. You have a tablet, and this is me again. This is day 2, me trying to figure this out, and I'm going to pick the next line that I want to paint, and then it will. There's my phone bugging me. It will paint this next line, and again, one of the nice things about this that we have learned is we can follow the paver really close with this. And so now we can stay within traffic control. the tires that are on there, they're basically bike tires. It's pretty light. It doesn't affect any of the paving. And so if the asphalt is too hot to actually walk on, we found that Sylvester can drive across that, paint it. They can finish paving or finish rolling. And then we can come back after it cools off enough, and we can put our tabs down where we've already painted the marks. And it doesn't put us into a precarious situation with rollers or pavers or anything like that. And so now I'm painting the turn pocket right here. It's coming back, and it'll get to the point, our 100-foot setback of where our turn pocket is. It'll stop. And then if it showed it, it would show me going back to the next line after our turn pocket opening and tie back into where that line veered off. So this has just a few more seconds on here, and it'll finish the turn pocket. And so one of the things that we've learned is it's really cool. We can do all this design in the office with our in our CAD drawing, and then we can take this DXF, and then we can make sure it's as accurate as possible before we get out in the field. And then there is options to adjust this in the field. You can do offsets off of your line. And so if you need to move a line over a foot or 2 feet or 6 inches, you can offset that line inside of the tablet. And so it does give you some functionality to do that as well. I'll go ahead, and this pretty much finishes up the video right here. I'll go on to the next one. This is the same road, just a different section of it. After we finished it, you can see that it has a reverse curve in there, and we were able to hit all those points on the tangents, the PCs, the PTs, and on the radius on there. And it made it, I would say 50% faster on at least hitting all these radius points, if not faster than that, doing this whole road. And we painted this whole road. We painted 4 blocks with 1 can of paint. So this is one of your normal, just fluorescent pink cans of paint. We used 1 can of paint to paint this whole thing. So it's very user-friendly as far as the paint goes. This is another couple projects that we do. If you can see on the picture on the right, this is where we've actually switched over and we started using yellow paint. And so this is near the end of the season where we decided we wanted to try something new, and we started switching colors of paint as far as that goes. Some of the tips and tricks that we've learned through this, like I said, you can connect your R10 to it or newer. I connect mine through Wi-Fi, and so I'll go through on my iPad. I'll connect on through a Wi-Fi connection and fire everything up and get it all connected. One of the tips with that is there's a lot of different settings going through the Wi-Fi connection to do that. I've now, once I got it all set up and running, I went through and took screenshots of all of my settings to make sure that everything was checked off and buttons were in the correct location, so that way if something changed next time, which it often does when you go in that Wi-Fi connection, to make sure that you get that one checkbox set so it will run properly. Or you can do, as Mike has recommended to me, connect it through your TSC7, and then it eliminates all of that jumping through the hoops to connect through the Wi-Fi. So we do that because at the time we got this, we didn't have a TSC7, and so we learned it the hard way to go through the Wi-Fi connection. It works great. You just have to make sure that you have a SIM card in your receiver, and after that, it's monkey see, monkey do. You control it from a safe distance. One of the things that we did add to ours, you can kind of see on the picture right next to Sylvester, to Rambo, there's a little bracket there. We have bolted on a bracket, and we actually added an ATV flag, just a normal ATV sand safety flag you can buy from any store. We've added that to Sylvester to provide a little bit more visibility when he is driving down the road and we're not right next to him. It's been very useful and helpful as far as that goes. With the Dxf files, I've talked a little bit about this. We'll do it all in the DWG before we export it. We have nice clean polylines. We'll get them to where we want them to start them and stop them at our stop bars, at our intersections. We'll cut them off exactly where we need to. And then we'll make sure that if we have, I try not to make them too long. I usually will only go about 400 feet. If I had a longer road than that, I will actually break those poly lines up. It just makes it a little bit simpler, so that one, Sylvester doesn't get too far away from where we're working, and two, it makes it so it's not as long as a file or as long as a line for him to follow the whole way. It will go further than that. We've kind of just kept it about 400 feet is just what we've learned. And one of the tricks is I'll only have one export job in there at a time. You can have multiple jobs in there, but if I'm doing a section here and then over 3 blocks and doing another section, I'll usually only do 1 block at a time. It keeps it from wanting to try to jump from zooming in and out on one area at a time. And then, like I mentioned, we adjust the lines and the color of the striping in the DXF, and that's been very helpful when you're out in the field trying to figure out which line you want to paint. You will select that. Point files are pretty cool. We've done that. I've done a parking lot with point files. The one thing to remember is it does paint them in numerical order. So if you start at point number 1, it will go from point 1, 2, 3, so on and so forth. So if they're not right in order, it'll jump from 1, go to the other side of the parking lot, go to 2, come back to 3. And so you have to be very careful and make sure when you are doing your point file numbering in your drawing that you number that numerically on how you want to paint it. So you have to do a little bit of cognitive thinking to make sure that you're going to be in the right place at the right time as you paint that. Some of these things I already talked about. We change the paint colors when we're striping. We now keep a little Allen wrench to change the paint cans, because even though if they are the same color of paint, sometimes the paint can will sit in there a little bit differently, and there is a little bracket on the back that we can adjust up and down. Make sure you give yourself just a little bit of slop in there because it is very touchy. If it goes over a bump, it'll bump that paint can, and it'll start painting that paint can on a little bump. So it is okay to give that just a little bit of a rattle in there. And we've also started to clean out the bottom of where the paint comes out, the bottom of the paint can holder. We clean that out daily. It does get a little bit of side spray on there, and it can build up. And if it builds up too much, the paint just won't even come out the bottom. We've also taken, I didn't put this hack on there, but we've also taken a piece of duct tape and wrapped it around the sides of where the paint comes out to avoid any side spray, painting extra paint out onto the tires and such, just to keep it a little bit cleaner. With the variable speeds, we've done some trials on going a little bit faster, a little bit slower. We'll try to keep ours running about 3 to 3.5 feet per second. This is what speed you saw it in that video. This is a good walking speed. If you were painting or tabbing a road, you could set it at 3. You could set it at 3 to 3.5 feet per second, and you could walk and keep up with it and tab right behind it. That's about the speed we like to keep it at. You can go faster than that. I have cranked it all the way up one time to see what it would do, and it's fast. You're literally sprinting to keep up with him. It's not worth it. Just keep that toned down a little bit. And 3 to 3.5 is it's still moving pretty quick. We've also learned, like I said, the line spacing on the center lines. We try to keep it about 10 feet. We have widened that out if we need to. You can adjust this on the fly within the tablet. And so you can stop the line and you can adjust that to a 2-foot spacing, a solid line. You can do all the way out to 50 or 100 feet, depending on how you wanted to do that. And then you can also adjust the length of the paint line as well. I usually keep mine at about 2 to 3 tenths, and at the speed we're at, it kind of stretches it out to about 4 or 5 inches, maybe 6 inches at the most, depending on what speed you're at. Some other things we've learned: keep some basic maintenance of it. Watch the tire pressure. We had one tire get a little low, and we were having a little bit. Sylvester was having to work to keep himself straight on his line. So make sure you just watch the simple tire pressure. They're bike tires. It's not that hard to air them up and keep them going. One of the other basic things is done. I've set up a test area back in our backyard at Provo City. I have a test area where before I'll go out on a job, I have 4 or 5 little test obstacles, I call them, that I'll run Sylvester through. It's they're pretty simple. They're just lines. So I'll paint a line up, I'll paint a line back, I'll paint a circle, and then I'll go over to another section, paint another line, paint it back, paint another circle at the end. And so it looks kind of like crop circles with pink paint out in my back parking lot when I'm doing my testing with that. But it makes it so that I know everything's all set up and running properly with this before I head out in the field. And the ultimate thing at the end of the day is follow basic survey practices with this. I mean, you are running a GPS on a robot that's driving. You have to realize that it is a GPS. We have to follow GPS standards. I mean, you still have your tolerances you have to do. You can't drive this under trees. You can't drive it under buildings. So you have to kind of plan ahead a little bit. And it will stop if you get to a point where you lose enough satellites that it wants. It will stop dead in its tracks. And you have to make sure that you have good satellite viewing and make sure that you can follow the normal survey practices and go back and make sure everything looks good. And if something doesn't seem right, then take a deep breath, come back, figure out, make sure all your settings are correct. We had a setting that got, we charged our battery, the main battery one time, and we had the HI got changed inside of Sylvester, and it threw everything off by just changing the HI. I wouldn't have thought that would have messed it all up, because all of our Dxf files, we don't have elevations to them, but just that one day that the HI was off, it did not like that. So follow basic survey practices, make sure all your settings are correct inside of the tablet. And I've been more than happy and excited with this. I've showed several videos with Ryan and Mike over the years, over the year and a half that we've had. Actually, it's been just over a year now since we've had Sylvester, and we've upped our productivity by at least 50% in the road. One of the big pushes I had with my grant was to try to get workers out of the road, and we've actually had, and it sounds silly, but we've actually had more workers on the project with Sylvester. And this is because we can paint more lines faster, and we paint them all within traffic control at this point now. And so if we leave our traffic control up, we'll run Sylvester out there faster than we could have beforehand, and we'll have the road tabbed and ready to paint in half of the amount of time than we did before by working with just a 2-man crew inside of the same traffic control. And so we're upping our productivity, we're upping our safety, and we're making it possible with this TMR. So that's pretty much what I have, Troy. I can open up to any questions that anybody has, or if anybody has any comments, concerns, or rude remarks, I'm happy to help answer any with whatever time I've got left.
Thanks, Chad. That was awesome. That was great. All right, we do have a quick poll that's going to come up before we go into some of the questions and answers. TMR number 2. If you guys can all take a quick moment and answer that. And should be pretty easy to answer that question, I would think. All right, so let's go ahead. And Emily and Mikey, do you have some questions for Chad that we can funnel to him, or should we go use another method?
We've been monitoring the chat, and there is one question that Mike wants to share.
Okay, yes, we had a couple different people asking questions about using the TinySurveyor.
Can barely hear Mike.
Can you hear me now?
Yes.
Okay, good. All right, yeah, we had a couple people ask if you could use the tiny mobile robot with a robotic total station.
You're faint again. You must, whatever you were doing.
I heard his question. He asked if can you use the TMR with a robotic total station. I've never tried that. I think it is possible to do it. I know that you're going to have. You might have to do a dual connection from what I understand because it is based off of a state plane setting.
Hey, Chad.
So, yeah.
Chad, can I go ahead and jump in here?
You bet.
Okay, so yes, you can use a robotic total station and you don't need to use state plane coordinates in that situation. You can actually set the projection on the tablet to none and then a units. So there's 3 different options for none in the tablet: meters, US feet, international feet. And so then there's no, transformation that you need to make, from the GPS coordinate that the GPS sensor is getting into like a mapping projection for that tablet. So the only thing you miss in that situation is the base map. Now you can still set up the total station on state plane and then you would have the base map, but you can use a totally arbitrary, coordinate origin with the robotic total station. It's the same exact idea. So Chad got into this a little bit when he was talking about the Wi-Fi connection to the R10. So what he's doing when he does that is he's configuring a NEMA message. And so that's just a position message. It's just a GGA message. It's basically just like latitude, longitude, height. And it's the exact same idea with the total station. You send over northern, eastern elevation in a similar fashion. You just configure that NEMA output. And then, so the way the big difference is instead of having the GPS sensor cabled to the TinySurveyor with the robotic instrument, you're going to have the data collector cabled to the TinySurveyor, or in some situations I've seen some Bluetooth adapters, but that's with a different manufacturer of total stations. So with ours, it's always cabled.
Yeah, and like I said, I've never tried it. I know, Mike, you and I have discussed this, but it would be pretty cool if you did run one with that. I mean, you could be getting that same tolerance you'd be getting pretty much with your robotic total station. So.
Yeah, Mike has actually sold a few of these that are using robots all the time. And obviously with the robot, you can move indoors and do some other things that we can't do with GPS and get the very same precisions. And then you have a prism on top of the robot that's following it around. And so yes, absolutely. Okay, any other questions?
We have one more.
Go ahead, Emily.
You go ahead, Mike. You're fine.
Well, I was just Ryan just mentioned that some people were asking about pricing. And so just like ballpark for just the TinySurveyor. So if you're using existing survey equipment, to pair with the TinySurveyor robot, you're looking around 34,000 for pricing, and that's including training, support, and all of that. So.
And the tablet comes with the tablet, the
right.
TMR. Yep.
That's like everything you need, but again, not including like a GPS sensor or a total station or anything like that. That's assuming you guys would be providing that.
Yeah, and Mike has gotten it to work with all kinds of different receivers and robots. I mean, Topcon,
yes,
Leica, Trimble, SPS. Yeah, it's
because it all goes back to just being able to send that message with the position info, and that's more or less manufacturer agnostic. Some of the details are a little different, but
yeah. Good. Any other questions? So are we ready to move on?
I think Emily did have one other question. I don't know if it was the same question or not.
Yeah, so one more question came in from Brandon Knight. I thought it was a good question that we could address to the entirety of the audience. He asked, what is involved in converting a project coordinate system in a state plane to use the TMR? And I felt like this was relevant, like I said, across the board, and a lot of people would relate to this question.
We do all of our, I might not be the best one to answer this. We do all of our road rehab that we use this in. We do all of our surveying in state plane grid. So we just leave it all in state plane grid when we start it. So you'd have to tie it back into something state plane. You'd have to tie it back into a section corner somewhere, and you'd have to tie whatever local system you have to come back into a state plane grid system. But see, I'm a little bit, I'm probably not the right person to ask for that, because we leave all of our projects, we start them, build them, and end them all in state plane grid, because they're on such a small base. And so we don't do a local site with each one of ours. So someone else might be able to answer that a little bit better, but I'm definitely not the right guy.
So yeah, I can provide some more insight. So this is something that happens all the time. It's one of the main training aspects with the TinySurveyor, is figuring this transformation out. And so as long as the GPS control for your project calibration is, of quality, then you can easily reproject back into a state plane, because that's a known transformation from your accurate lat long to your state plane coordinates. And so that's a pretty simple process in TBC, something I train people on all the time. There's other software that is capable, but being a Trimble dealer, we typically will use the Trimble software. So it's really pretty straightforward. Something like ArcMap is actually capable of doing it as well. And then also kind of the most requested and most actively worked on feature enhancement for this product is the support of local coordinates and project calibrations. And so we've actually got a beta version of the app out right now. And we've got a couple customers starting to test out this workflow. It's not 100% dialed in yet, so we're not necessarily advertising it like from a sales perspective, but it is coming. And definitely, we're between us and the manufacturer, we're doing everything we can to get that workflow supported.
And I would kind of jump on board with you on that, Mike, that there has been some other little things that we've requested or we've found that would be handy to have. We have been in contact with Mike and with Ryan and with the manufacturer directly to try to change some of the software, upgrade some of the software to get some of these little functions in to make this a better product. And so it's been, like I said, in the year that I've owned this product, it's been phenomenal. It's exceeded the expectations that I've had. And again, I'm grateful for the grant that I received from Provo City to pick this up for the survey department and to run it. And so again, that's all I have, Troy. If there's nothing else, then thank you.
Thanks, Chad. We also do have Jens on the line, and maybe Pally as well, from TMR. Is there anything that you guys wanted to add?
First of all, I'm Jens Christensen from Time Over Robots, the CEO, and I think it was a great presentation by Chad. It was really so great to hear his use of the robot, to get this feedback, both the great and the small things getting back to us. We are listening very much to the end users. We're always ready to adapt things, improve things, ensure that it's as easy as possible to use for the end customer, like Chad here. So I'm also glad to hear his feedback, because it seems like we hit some of the things that really fits into his use. Some of the things that he also mentioned is that we got tires that is modified bike tires, and you could say, why that? That's because that's a robust type of tires, a robust type of wheels, but it's extremely light. So the weight of the robot is about, I think it's 35 pounds or something like that. So it's very easy to carry around, which has also been a very important design criteria for us. But great feedback from Chad, and we are listening very much to what you as end user are having, our visions, ideas, and we'll adapt to that as quick as possible. So I have not much to add. I think Mike McCarrick showed to be an expert on the robot and answered the questions that came up extremely precise and accurate. So it shows that you're sure to get local support from a very, very competent person in Mike McCarrick. So thank you very much for that.
Thanks, Jens. Appreciate that. Once again, thank you, Chad. All right, guys, let's go ahead and move on to our next presentation. Mr. Sean Fernandez is.
Hey, do you want to find out who won the giveaway from the poll that we collected?
Yes, we did collect a poll. Go ahead.
All right, let me share my screen again. My controls always get in the way. Well, here's the winner, Travis Train. You're the lucky winner of a $50 Visa gift card. If you can private message me in the chat where you'd like me to mail this, that would be awesome.
Nice job, Travis. Even though you just won, you still have to listen to the rest of these sessions. So that's our rule. Or we don't send you the gift card. Just kidding. We'll send you that gift card. So anyway, all right, good. Good job. Congratulations, Travis. Okay, let's go ahead and move on to Sean's presentation. Sean always presents at our users group, and Sean is our administrator for the Utah Turn VRS network, which we all love and have used for a long time. Sean and I were talking about this the other day, and we figured it was 15 or 16 years ago that we initially launched this. It's crazy that it's been that long, but let me just read a little bit about Sean. Sean Fernandez began surveying in the spring of 1989 using a wild T16 theodolite, a plumb bob, and a still tape to lay out projects for UDOT. While working for UDOT, he realized how much he loved working outside, exploring the natural beauty of Utah through surveying. This newfound passion led him to pursue education in surveying, drafting, and geomatics from the programs at Utah Valley, Salt Lake Community, and Utah Valley University. So he started when it was just a community college. He completed his degree, and in 1993 was licensed, and in 1990, I'm sorry, completed his degree in 93 and was licensed in 94. Since then, has gained valuable experience through several surveying positions. Sean especially involved in promoting the field of surveying through his many local, state, and federal leadership roles, including being a professional land surveyor, staffing the Monument Replacement and Restoration Committee, and serving as State of Utah Geodetic Advisor for the NGS. He also manages as I mentioned, the Utah Turn GPS network. Sean is honored to be serving as the current state chair-elect for the Utah Council of Land Surveyors, participating as a member of the Utah Valley University Surveying and Mapping Advisory Board, and looks forward to continuing to promote this valuable work of surveyors. So thanks again, Sean, for being there. Are you there?
I'm here. Can you hear me okay?
Yes, sir.
Okay.
And I can see your presentation there.
You can see the presentation. Okay. All right, well, let's jump right into it. As Troy mentioned, my name is Sean Fernandez. I've been presenting at this conference for several years. And over the years, I've moved from UDOT as a state employee to the Automated Geographic Reference Center. And this year, we actually had a name change for our department. We're now the UGRC, the Utah Geospatial Resource Center. That just took effect after this last legislative session. So a lot of you probably know us as the State of Utah GIS Department, but they pulled a surveyor in to help promote accuracy and precision in the data. So that's one of my main goals. And if you look at this slide, it says the cadastral survey team is gaining more respect and being recognized for our work and support on the PLSS and the GPS network. So it started out that it was just me as a surveyor there trying to promote a few different things. And now we have a whole team of us that work on PLSS and the GPS network. So we've come a long way. We're gaining more respect, and we've got some momentum right now, and a lot of that is due to the GPS network. In our last meeting, I always do this, get to know Sean a little bit. This is me, this is what I do. I think in the last presentation I gave, I announced that I was gonna be a grandpa, but I am a grandpa, so that's pretty cool. Also do a little bit of archery hunting and a lot of fishing. So last weekend we went out and caught some big fish out in the Reno area, and that was a lot of fun. So we try to get out as much as possible and do fun things. The first thing I wanted to mention about the GPS network is this really is not possible without the many partners we have. So This is to say thank you to all the partners. You can see that we have several of them listed, and we have several new partners that are being listed. And without you, this project would would not happen. And the range of partners vary. That we have some that have their own base stations on their own buildings that we connect to. We have some that offer just a site for us to place one of our stations. We have vendors that are always promoting the service. There's just a whole host of people out there trying to make this happen and keep the costs down as low as possible so that everyone can enjoy what we've created here. It's funny, a lot of times we'll have station outages, and in fact we had one not too long ago up in Haley, Idaho, and usually I'll send out an email to say, hey, so-and-so, we've got a station outage, can you help me get it back online? And that usually goes out to the IT department. Well, some IT departments don't realize the importance of these stations and what they're actually used for. So I got an email kicked back to me saying, can you remind me why we do this? And this was an IT guy, and he didn't really understand the impacts that it has to keep that station running. And so I proceeded to explain to him how important that service is to the local surveyors in that area. And he finally got it. He's like, okay, that helps me to understand what's going on. It's not just a little yellow or gray box sitting in my IT closet. There's actually meaning to it. So if anybody needs a reminder, please give me a call and I'll try to explain what it is we're trying to do. But I just wanted to say thank you all. The last time I spoke, I talked a little bit about how we're trying to build a website to display the site logs for each one of the stations. We now have that built, and we're getting more and more information. The link that you can get to those site logs is located here at gis.utah.gov/turn. And when you get to that page, you can see there's a hot link there that says GPS network. When you select that hot link, it pulls you up to this GPS station information page. And you can see we have tabs along the top for each one of the stations. And as you select one of those points, this is an example of one that has been selected on Grantsville. You can see a photo of the station itself and also the antenna, and it has some information about the station. So we're still trying to fill in the blanks on this site. So we need photos. If you are a station manager, we would love to have photos sent in on each one of these stations of the receiver itself and the antenna. So don't hesitate to email those to me, and we can start to complete this site a little bit more. Troy, quick question. I don't know if you're still on, but are we going to handle questions at the end, or do you want to have questions during the presentation?
Yeah, that's the plan, is to handle them at the end of your presentation, Sean.
Okay, sounds good. Thank you. Last year at this same conference, this was the map shown for the network. This was our coverage area. You can see it was pretty vast. We cover all of Utah down into the Las Vegas area, stretching up into Idaho, southern Idaho, and then the network out in the Reno area. We've done a little bit since then, and this is the new map, and I hope that's displaying. But it's showing that we've extended now up into the Wyoming area. We've expanded some additional stations in Idaho. We have put some additional stations down in the Las Vegas area, and we're trying to upgrade some stations out in Reno. We're going to talk about each one of those areas as we move through the presentation. So this is supposed to have a map behind it, and it's not coming in. It may be a large map and not drawing, but one of the questions is what satellites can you use with Turn and Nevada GPS, depending on where you are. This slide shows you a snapshot of the Trimble pivot software, and it's showing you that you can get full GNSS only from the Turn network right now using those mount points that are listed below in red. There's the GNSS VRS CMRX and the GNSS VRS RTCM32. And if you look, it shows with those red arrows each column of what satellites are solved and available in the solution from the TERN network. You can see that we have GPS, GLONASS, Galileo, and Beidou. Beidou is showing that they're tracking 1 or 2 Beidou satellites, but nothing's being solved yet, and we're going to talk more about Beidou. But just know that the GNSS coverage is always expanding, and that it is available, and that at any given time right now, you're seeing usually 20 to 23 satellites, which has improved a lot since the beginning. So getting into modernization, we'll get into Beidou and how that's going to impact your solution and the service itself. But right now, you get reliable results from GPS, GLONASS, and Galileo. Beidou has not been reliable, but we are getting there. Last year at my presentation, I went through each of the constellations to give an update where it is. I'm not going to do that this year, but just note that Beidou is actually coming online. So Beidou 1 and Beidou 2 has been around, but if you look in red there, it says that BDS 3 or Beidou 3 satellites have been launched. Beidou 3 is expected to be fully functional by the end of 2020. Well, it is fully functional, but we're taking measures to utilize that solution. So these are the measures. So we were planning to do an upgrade to the Pivot software, going from version 4.3 to 4.5 on February 11th, I believe it was. But we got a phone call the day before we were ready to do the upgrade from Trimble saying, slow down, don't move forward. Apparently somebody else was a guinea pig this time, and they got burned. They had some processing issues where by processing the Beidou satellites in their solution, it caused their system to crash because their server was not bolstered up enough to handle the processing load. So I'm glad they told us beforehand, because we would have done the upgrade and then had a complete failure. So we're now planning to move forward with this upgrade. We're going to bolster up the servers. There have been things that Trimble has done to improve the processing, and we're going to talk about that in 1 second. So this is directly from the Trimble Pivot version 4.5 release notes. It says in June of 2020, the final satellite has been launched to complete the orbital constellation of Beidou. The latest Beidou satellite generation, Beidou 3, offers additional signal and significantly enhances the Beidou constellation. Beidou 3 satellite numbers start with the satellite PRN 17. With the introduction of Beidou 3, up to 20 additional satellites can be tracked in Asia, 12 additional satellites in Europe, and 8 additional satellites in North and South America. So I think that answers a big question that a lot of people have had, is how many satellites are we going to see when Beidou 3 comes online? And it looks like it's going to be 8 satellites that we'll consistently be able to use. And then the next area that I have outlined in red, processing the additional Beidou 3 information can be enabled in the properties of the RTX processor by setting the enable Beidou 3 processing option to yes. This automatically changes to using the new processing technology. So Trimble enhanced the processing technology in the new version of 4.5. And it says the memory usage of the server running the Trimble Pivot platform will increase to approximately 200 megabytes of RAM per station. Doesn't sound like a lot, but when you're running 106 different stations, it's gonna take a little bit to process that. So we are looking at bolstering up our server, maybe even running 2 servers, and getting ready for this enhancement. So hopefully when that happens, you'll have additional birds in the sky. 22 is pretty good right now, but it'd be nice to have a lot more out there. Okay. So I wanted to go through each area of the network. 2020 turn GPS GNSS coverage. You can see that we had fairly decent coverage last year with full GNSS. We've now enhanced a few stations. I think we've added an additional 6 stations that are full GNSS, so it's always expanding the coverage area. This is what it looks like now in Utah in 2021. You can see you have additional stations and a much larger coverage area in Utah for full GNSS. This slide was at our last conference. I showed the active GNSS receivers, those that were potential GNSS receivers and those that were non-GNSS receivers. Notice over on the column of non-GNSS receivers, I've now highlighted 6 stations in red that are full GNSS. And we've also now included new locations, and we're going to get into some of these new locations here in a second, where we've expanded the network. So as I mentioned before, this is the new footprint of the network. You can see we expand clear out into Wyoming now. We have additional stations in Idaho, and it's getting larger. We are starting to densify in a few areas in Utah and trying to just enhance the service everywhere. We are trying to get rid of some of the older legacy receivers, and over time we're going to be able to do that. One thing we talked about last year is how we were going to process new locations for all the stations, and that those stations that were out as much as 2.5 centimeters would be readjusted, and new coordinates would be placed into the system on those stations. We didn't do that. We wanted to do it, but we had a lot of things going on with COVID. We decided not to do it. We would wait and do another processing when we had some of the Wyoming stations and Idaho stations added, and process them all together. So expect that you'll see an email in the near future stating when that adjustment will happen and when those stations will be updated. There will be a full list of what stations will be updated, how much they've moved from the current location to the new location. If there are issues, we'll let you know that information well in advance. If there are issues with some of your projects, just let us know, and we won't make those adjustments if it's going to impact your projects. But if we don't hear anything, we will move forward at that point. This is what the network looked like in 2020 for the Nevada GPS, the GNSS coverage. We just don't have the module to run the RTX net processor for that network right now. But we are trying to at least enhance the solution by putting some redundant stations in. Of the 2 that are circled there, the one that's in the works right now is the one to the right. I think I had more information about that right here. So we're working out the details to put in a new station out by Silver Springs Airport. And then another station that has had issues is the Fernley station. They were running an old 5700 out there. We replaced it yesterday with the Net R3, and it's now back online, and you should have a full network. I've heard complaints that there are some issues with people using CMRX VRS up in the northern part of this network. Hopefully this change will enhance that problem. But if people would test that and get back to me and let me know if they're still seeing that problem, that would definitely help. We're still considering a network merge in the future. We do have now another station that's been installed in Elko. So we're working on it. When I took my trip out there last week to go fishing, I noticed there were several mines in the area. I haven't had a chance to talk to those people, but I'd like any help I can get. Those that are in that area, if they would introduce me, and we can start working on getting connected to some of those existing stations, or start looking at locations that we can place some of our stations. That would be helpful. We're still talking about the datum of NAT 8394 HARN and some of the issues that we have with that. And some of the challenges that we're faced with is the Washoe County coordinate frame is currently in that. And it's difficult because I'm unable to adjust those coordinates using Opus projects. And over time, we know that stations do move a little bit, and so it's been difficult to get updated coordinates. With it being in that older coordinate frame, it's just not a library that's possible to use in Opus projects. And then when we start adding new stations in, it's been difficult to process the coordinates for those locations. So we had a great meeting with the Gnss Lahontan chapter. We met on February 4th to discuss the Nevada GPS reference frame. We want to attempt broadcasting both NAT 83 2011 and NAT 83 94 HARN on individual mount points using the Trimble transformation generator. So what it would look like to you as a user is from your list of mount points that are available, we would just have an additional one that said VRS RTCM 32 underscore NAT 83 2011 and VRS underscore RTCM 32 NAT 83 94 HARN. So we're trying to work out the kinks and figure out how the Trimble transformation generator works. I just installed that recently. We do have the licensing available for the Nevada network, and I'm in the process of purchasing that for the Utah network as well. So this is what it looks like. As you can see, this is my license. It is now in place. It's now just a matter of getting it configured. It's a little difficult. There are a lot of manuals and the pivot help that are available, but I've never set one of these up. So I'm working with Trimble support right now to try and get this set up. But as you can see on the right-hand side, the parameters are something that's probably familiar to a lot of surveyors, looking at the semi-major, semi-minor axis and the rotations and the things that are necessary to create a transformation. All the parameters are right here, and it's just trying to figure out if the parameters are changed here, whether we're going to see the same results. So what would end up happening is we would reprocess coordinates for the base network, which would now be in NAT 83 2011, and then we would create transformation parameters for the older network and key those in and have those broadcast out through a new mount point. At least that's the plan. So we will keep you up to speed on when that happens. I'm working with some members of NALS right now, but we'll let you know what happens. The reason why we are wanting to install that transformation generator on the Utah network is because it looks like it's going to be a possible solution for the NGS 2024 adjustment if it actually happens. Another reason why is Dominion Energy has a special transformation that they want broadcasted right now. We can create that for them if we purchase that. I've now just received the final approval to make that purchase, and Dominion Energy, who is one of our largest customers, is helping us make that purchase. In my last presentation, we talked about the Wind Rivers Reservation in Wyoming and how they have some stations up there and some money to put towards this. They have 3 stations that we've just recently added. You have the Wind Rivers Fort Washakie in Wyoming, Wind River Lander, Wyoming, and Wind River Riverton, Wyoming. Those are all 3 part of the network now, and things are rapidly happening up in Wyoming. I was contacted by Ben Johnson from the Bureau of Land Management in Wyoming, and he's interested in partnering with Turn GPS to expand and enhance the GPS network coverage for the national cores as well as the VRS and the real-time solution. So he operates currently 3 stations, and he's wanting to move some stations around so that they can get better coverage in Wyoming, and he's requested our help up there. There's again not a lot of skin in the game for us, but it'll do a lot for them up there. So we're going to help them expand into Wyoming and see how far we can carry that. So we connected up the ones in Wind River. We've also connected up Jackson Hole. We have one connected now in Cheyenne, Casper, and Sheridan. Ben Johnson has also offered to move a couple of existing stations around and connect 2 others that are not along that main corridor over in Cheyenne, and those are shown here. So this will be the network in the next couple of months out in Wyoming, if you have any interest. And anybody that has a turn account or a Nevada GPS account can utilize that out in this area. This is a special project that we've been working on. UDOT, the Traffic Operations Center at UDOT is working on an autonomous vehicle project. They're looking at possibly using the GPS network corrections to help with the implementation of the UDOT V2X, the vehicle to everything communication environment, using an N-trip connection to a sensor at intersections to communicate positioning for driverless vehicles using an RTCM protocol. So they gave me a call and asked me if we could start doing some testing. They have 132 intersections they want to start with. They're saying that it'd rapidly move up to 200 intersections and eventually possibly 2,000 intersections. So this is something we're looking into. We're looking at licensing and some of the impacts to our current network. We'll make sure that on any of these test projects, it does not impact the current users, but just know if we can get something like this to happen, that there will be additional funds that would come to us where we could enhance our stations and do some other things. And last year I spoke about this urban air mobility with drones. Everything stopped due to COVID, but we have our first meeting getting back to that on Thursday. So again, hopefully this is one of those projects that it will not impact us, our current users, but hopefully it'll bring some additional funds in the future to enhance our service. On a quick note, I think I've got a couple of minutes. I was just going to mention that we have the PLSS app. I think I spoke last time. Right now we have a current PLSS web app for people that want to get corner information anywhere in the state of Utah. We're looking at revising that. We're looking at making something that's more user-friendly from a desktop standpoint as well as mobile. And we now have a version of that that's in the test phase. I don't know why that's not coming up, but let's see. Okay, that was my last slide and it doesn't look like it's gonna show up, but we're in the test phase of that and it is working. It's working both mobile and on the desktop. I'm hoping for a release in midsummer, maybe fall, but just note that it's gonna be a great app and you're gonna have access to a lot of data. And the data is enhanced continually through the GPS network. So we ask that people continue to provide that data to us. It makes everything good in the surveying community. And with that, that's all I have. So Troy, we want to go into some questions?
Yeah, thank you, Sean. That was excellent. Very exciting developments, especially with the expansion with the BDO, other GNSS functionality. Pretty awesome stuff. We started off with the Utah, and now it looks like we're covering the whole Intermountain West. So, all right, guys, you should see a poll question coming up there. Let's go ahead and get that question answered so you can be entered into the next drawing. And Mikey and Emily, is there any questions that we can field for Sean?
We do have a couple for him.
Yeah, actually, I have just one really good question.
Can never hear Mikey, by the way.
It's a soft voice. Sorry about that. Kit Cantrell asked, how many subscribers are there currently, and how has it helped mitigate the cost to UGRC?
Okay, Troy, I think I heard that question. It seems like as soon as you start talking, it goes into quiet mode. And I don't know if you have a setting or something, but you were asking how many users we currently have.
Mm-hmm.
Is that right, Troy?
Yeah,
is that what you're, okay.
Yeah, that's right, yep.
We have approximately 650 paying users. We have an additional couple hundred partner users, and those funds go to paying my salary. And I don't know, many of you have probably met Mike Hagan, who helps with the network. It goes to paying his salary, and it pays to enhance the solution by buying some equipment. We probably buy 6 to 8 receivers a year to cycle out the old ones, and we usually end up buying some additional modules for the solution. So yes, the more users we can get on, the better the solution is going to become. Hopefully that answered your question.
Next question.
That was the only one that we had for this presentation.
Nice. Well, I hope I've answered some of your questions through the presentation. If not, please feel free to contact me direct. A lot of you have my email or even my phone number, so feel free to contact me anytime.
All right, thanks, Sean. Really do appreciate that. We're going to be talking a little bit more about the VRS in a couple of subsequent presentations, but really the VRS is the backbone of all these presentations in terms of how guys are measuring today. And so it looks like it still continues to be an exciting future. Emily, would you like to announce the winner of our poll?
Yes, I will. The winner of the next poll is Kent Cantrell. Congratulations, Kent. You got yourself a $50 Visa gift card. If you could please message me in the chat where you'd like me to send that, that would be great.
All right, guys, keep on answering those poll questions. All right, let's go ahead and move on. We are running a little bit behind schedule, but not too bad. The next presentation I'm very excited for. We're going to be talking with Brad Mortensen and Riley Lindsay. Riley is with the DOT and Brad is with Meridian. And we're going to be talking about the new, it's called a lot of different things, but NAD 22 or the new North American Datum SCSC 22. And anyway, let me just go ahead and introduce Brad and Riley. Let them go ahead and get started with their presentation. First of all, Brad, I've actually known Brad for as long as I've been in the surveying industry. He was one of our first head of surveying in Reeve & Associates back in the mid 90s. Anyway, Brad still lives in Syracuse with his wife and 2 of their youngest kids of 9, youngest of 9 children. He has 11 grandsons and 3 granddaughters. Brad has a Bachelor's of Science in Civil Engineering from California State Polytechnic University in Pomona. In 1992, he's licensed as a professional in several Western states. He's experienced with all aspects of transportation and infrastructure design, ranging from geodetic control, mapping, road right-of-way design, and construction of freeways and state roads. Experienced in state, municipal, utility, and commercial retail capital improvement projects working with private entities, municipalities, and state and federal agencies throughout the Western United States. Currently works for Meridian Engineering as their quality assurance QC manager. He's active in the UCLS, UGIC, a bunch of other acronyms, and Western Regional Height Mod Consortium. For the past 5 years, he has been an instructor for Salt Lake Community College in the Geomatics program and currently teaches Control Surveys course, which that makes a ton of sense to me that he is teaching that course. He has been working with the Utah Stakeholders Committee for the past 3 years, coordinating with the development of the Utah State Plane Coordinate System. Also, Riley Lindsay was going to be co-presenting with Brad. Riley has over 15 years of experience in surveying in GIS, while currently is at UDOT, and while there he has worked as the survey manager for Region 4 and also worked as the region right-of-way and utility designer. His current role with the department is the statewide surveyor working with our central office in Salt Lake. He graduated from Salt Lake Community College in 2011 with his degree in surveying and geomatics and a GIS certificate as well. He is licensed land surveyor in the state of Utah. Guys, thank you so much for being with us. Riley, I can see you there. Brad, I assume you're on?
Yeah, I am. Do you see my screen yet?
Yes, sir, I do. I see your PowerPoint up there. We'll go ahead and turn the time over to you guys, and thank you for presenting with us today.
Perfect. Thank you, Troy. Can everybody hear me okay?
Yes, sir.
Okay, so the title of our presentation is, we're going to talk about the Utah State Plane Coordinate System of 2022, and hopefully we can answer, what it is good for. Again, like Troy said, my name's Riley Lindsay. I work with UDOT, and we also have Brad Mortensen, who really from the beginning has been the technical expert and lead on this project. So we're fortunate to have people like Brad that have the expertise and the good experience to kind of help us out with this. So with that said, next slide, please, Brad. So I think we all realize that sometimes change is important, but also change can have, a certain, it can make us uncomfortable. So the bear in this photo kind of shows that sometimes when change, we may get a little grumpy. So really the objective of our presentation is we want to kind of answer some of these questions. Questions like, why are we doing this now? I mean, NAT 83 has been out for coming on 40 years. Why change now? Whose bright idea is this? When is this happening? And what will this new system look like? How will this be done? And how and where will this affect my practice? Next slide, please. So let's first answer the question of why. So really, everything that we're doing is based on the NGS final policy and procedures. This is really their initiative. One aspect that I do want to point out, this to me is the most exciting part of this new state plane coordinate system. It was actually mentioned in Chad's presentation as part of a question with the grid to ground, but this state plane coordinate system is going to be projected at the topographic surface and not the ellipsoid. So if you don't remember anything of our presentation, to me that is the most exciting part. This will allow us to be able to use this state plane coordinate system for design purposes. I know from my UDOT perspective, we are really excited about that, being able to use those state plane coordinates instead of having to try and keep track of the project coordinates versus state plane coordinates. Other things to kind of point out, there's different layers that we have been working on. One, for example, is a statewide layer. We all know that Utah has quite the diversity in terrain. So this layer is more for GIS purposes. And then we've also created 11 zones. Those will replace the 3 zones that the NAT 83 currently has. And the reason for the 11 zones is just so that we can minimize the distortion, especially in the valley areas with the populated areas. And then there's another category of low distortion projections. This will, for example, up over Parley's Canyon is an area where we're working on a low distortion projection. Because all the distortion was kind of best case scenario in the valleys, there will be some need for low distortion projections overpasses. There are also special use zones. For example, there's a couple down in the Four Corners area. The Navajo Nation has a special use zone. The Glen Canyon recreational area has one. And then something just to note here, this system will kind of work on positive east longitude. So we're kind of used to the negative, 112s, 113s. We're going to now be reporting them positive, so they'll be in the 200. So next slide, please, Brad. So let's talk about who was involved in this. really the NGS kind of set the guidelines of who the stakeholders were. This includes the Department of Transportation. That's how I got involved. You know, AGRC. I guess they've changed their name now. I learned that today. Thank you, Sean. You know, and then the UCLS. One thing to point out here is that Utah really decided to kind of take a proactive approach to this initiative. The default from NGS for states that didn't want to be involved is that they would provide the designs as requests to the states, but really we kind of wanted to have a say in what these boundaries were. So we submitted proposals to NGS, and they've been great to work with us, give us pointers. And so next slide, please. So here's the list. Again, you know, I represent UDOT, Brad with UCLS, Sean Fernandez, who just presented to us, was involved in this, and a bunch of other people. It was really great to kind of have this group. Here's a picture of some meerkats. You notice one's kind of looking a completely different way, and that's sometimes what happens is you bring these groups together. Each person has a different perspective, and it was fun to really, you know, kind of hear those perspectives, and it really helped shape you know, where we're at today. Next slide. So we're going to answer the question when. So as we're charging forward, here's a picture of some wildebeest. So a group of wildebeest is called a confusion. So as we're charging ahead into the future, when is this going to happen? So we really wanted to get it out in front of this. So many of you may be thinking, because of the title, that this is going to be implemented in 2022. Well, that's not the case. I don't think the pandemic helped anything, but really the rollout is sometime in the 2024-2025 timeframe. And so this will give ample opportunity for vendors like Trimble to receive those designs, to implement it into their library, so that you as the users, you know, can have those pull down lists and really don't have to kind of put in the parameters yourself. So they didn't, however, push back any of the deadlines for the request. So you see March 31st, 2021. So we're coming up on a week of having our designs kind of submitted for approval. We've had the 11 zones set for several months now. We're now just kind of trying our hardest to work through some of the low distortion projections. And so, yeah, so we should have those submitted to NGS by then. So next slide. I think this is the next slide that I'll turn over the time to Brad. He really is the technical expert, and he'll kind of walk us through some of the fun stuff. So thank you.
So to answer the what, we're basically looking at the state plane coordinates in 2022, and we're using a lot of the same, we're going to be using a reference frame that's from the TRFs, the terrestrial reference frame of 2022, but the base on the same reference ellipsoid of the state plane coordinate system 83, which is the GRS 80. We'll also be using the same three conformal projection types from 83 and 27, which are the Lambert conformal conic, the transverse Mercator, and the oblique Mercator. So the design parameters that NGS has developed are that they're going to specify a distortion design criterion for each projection, whether it's 100 parts per million or 300 parts per million or 50 parts per million, whatever it might be. And in order to specify that criterion, it has to meet the following, has to satisfy the following, where 90% of the population would fall within that criterion, 75% of all cities and towns would fall within that criterion, and 50% of the entire zone area. And some of the limitations for the design that NGS is going to do will be that they will only design to a minimum design criterion of plus or minus 50 parts per million. but in some cases it might be less, but that's only due to the size of the zones. The low distortion projections, which are less than 50 parts per million, must be designed by the state, basically. And so, as Riley mentioned, we're looking at different zone layers, and we kind of like layers around here in Utah. So the way that NGS set it up is that there's 3 layers. You can use 1 layer, or you can have 0, 1, or 2 multiple zone layers can also exist. So the one single layer is the layer that covers the whole state. But then you can have a second layer or a third layer. Only one of those layers can be a complete state coverage, and only one layer can be a partial state coverage. And basically they set this up because, and a lot of it came from the requests and recommendations that we sent back to NGS when they were initially setting this up, is that we need more layers because in a mountainous states, we're not going to be able to get everything to the coverage that we want, like a state like Kansas will be able to do. And so at that stage, the Utah stakeholders have chosen to use a 3-layer system. So just to summarize the different state plane coordinate system of 2022, it's going to be a state plane coordinate system, part of the new datum, the 2022 datum, which will replace the state plane coordinate system in 83. It will use same ellipsoid and projections, but it'll differ in other ways. The minimum distortion at the topographic surface and not at the ellipsoid surface is the important difference that we are looking at. NGS will design statewide, but up to 3 zone layers are allowed, and they also will allow use of special use zone layers, which are special cases that cover multiple states. So let's talk a little bit about distortion. What is distortion? Well, here we have a parade of elephants, a group of elephants. Many times it's called a parade. And what is distortion? It's defined in cartographic distortion is an unavoidable misrepresentation of one or more metric properties of a map, such as area, direction, distance, shape, or scale. And so for large scale mapping, the discrepancies on the optimally selected projections and their parameters might be minimal. Well, here's another parade of elephants, but this time we see their projection on the sand. And that's what we're looking at, is there's going to be some distortion. And again, there are 4 different basic characteristics of a map that are distorted, depending on the map projections used. These are, again, direction, shape, and area. But we're using conformal map projections. And to become a conformal map, it follows this definition. A map projection is conformal when at any point the scale is the same in every direction. Therefore, meridians and parallels intersect at right angles, and the shapes of very small areas and angles with very short sides are preserved. The size of most areas, however, is distorted. And you guys probably are familiar with this display, so I'm not going to take a long time to explain it. But basically, this is the ellipsoid, the geoid, and U. And it all comes down to this formula at the bottom where the ellipsoid height is equal to the orthometric height plus the geoid height. And of course, in most of Utah, in all of Utah, the geoid height is a negative value. So let's look at map projections. Basically, they're a mathematical function typically. Here we have the ellipsoid surface. We're going to create this flat surface by projecting it using this projection axis. And a scale factor KO, which is the scale factor at the projection axis. So what we end up with is that there's one point on this projection that the grid distance is equal to the ellipsoid distance. But as we move farther out from the projection axis, you can see that the grid distance becomes greater than the ellipsoid distance. Well, you can also move that grid projection up or down depending on the scale factor. And that'll change the grid distance. And in many cases, like for example, the secant method at the bottom, you can see there's 2 points where the ellipsoid distance is equal to the grid distance. But there's points where it's going to be larger or smaller depending on where you are on the projection. One interesting thing that you can see from this this display is that there's 2 things that are going to affect the distortion between the ellipsoid distance and the grid distance. One of those is the distance you move away from the projection axis, which is caused by the Earth turning away from the projection due to the curvature of the Earth. And the other difference is based on the height above or below the ellipsoid. Those are the 2 things that are going to affect the distortion of the distance. And here we have a chart showing the horizontal distortion due to Earth curvature. So we can see that when the maximum projection of the zone is like 71 miles wide, you get a plus or minus 20 parts per million distortion, which is about 11 feet per mile. Okay, you can see different distortions depending on the size of the projection. And then the horizontal distortion due to the height above the ellipsoid, if the ground is 400 feet plus or minus above the ellipsoid, you're looking at 19 parts per million, which is about 10 feet per mile. Okay. So how is this going to be done? Basically, there's 3 different methods that you can use to minimize the linear distortion. The first one is to scale existing projections from the state plane coordinate to ground, which we use a lot in this state. That's the modified state plane coordinate, basically. The second is to scale ellipsoids to ground and use those for custom projections. That's not used very often. And then the third one is a design custom projection at ground, which is the low distortion projection. They all do the same thing. They're used to project a developable surface at the topographic surface, but not all of them perform the same. Certain methods are better at minimizing the distortion. So we're not going to talk about the second one that much, the scaling the reference ellipsoid. We'll talk a little bit more about the low distortion projections, which is number 1 on this picture. But as far as the modified state plane coordinates go, which is number 3 here, you can see that there's some problems with it. The first problem is that the coordinates are very similar to state plane coordinates and can lead to confusion. You might think that you're measuring at ground, but you're actually looking at state plane coordinates, and you'll have some distortion. And it can be pretty good size distortions depending on how high above the ellipsoid you are. But that can be eliminated by translating the coordinates. More difficult, the modified state plane coordinate system is also more difficult to implement, often results in a messy projection definition. It can reduce problem by careful use of the scaling parameters, basically. So if you're careful with how you scale the projection, you can reduce that problem, but it does not reduce the convergence angles. And a lot of times we don't even look at the convergence angles, but when you're looking at a projection that covers from east side of the state to the west side of the state, you got to look at some convergence angles, because you're going to have quite a bit of convergence based on where you're at in the state. Most important, this usually does not minimize the distortion over a larger an area as other method, as large an area as other methods. So let's look at some of the differences between the state plane versus the LDPs, the low distortion projections. Again, we talked about some of the disadvantages of the modified state plane. It's not fully compatible with software. It's easy to confuse coordinates with true state plane. It does not reduce convergence angles. It requires new coordinate systems for every project, and it does not optimally minimize distortion. The advantages of a low distortion projection are that it is compatible with a wide range of software packages. It reduces the number of local systems. You can use one low distortion projection for many projects across the counties or the state. And it satisfies the needs of engineering, surveying, and GIS. Optimally minimizes distortion over largest areas possible. And the three types of map projections in the state plane coordinate system will be the transverse Mercator, the Lambert conformal Conic, and the oblique Mercator, as we mentioned earlier. And they all have nearly the same ingredients. They all have a geodetic origin, which is the latitude and longitude, a grid origin, which is the faults northing and easting. They have a scale at the origin. It's its size compared to the Earth ellipsoid. And then the oblique Mercator only has a skew azimuth, which is the rotation of the cylindrical developable surface. Here's just some ways that we can see this. You can see this is the transverse Mercator, where you take a cone or a cylinder and you wrap it around the Earth, and then you can cut that cylinder and unfold it, and that creates your plane, basically. That's the projection of it. And it has a latitude of grid origin, a central meridian, a false northing, a false easting, and a central meridian scale. Here's the Lambert conformal Conic projection, where you take a cone and you lay it down over the Earth's surface, and you cut it and open it up, and that creates your flat plane. And typically in the past, we've used a two parallel system here in Utah, but the state plane coordinate system of 2022 is going to be limited to a one parallel version. It's actually the same type of thing. It's just a little easier to work. And it has a latitude of grid origin, which is the standard central parallel. It has a central meridian, a false northing, a false easting, and a standard parallel scale. And then this is the oblique Mercator projection. Again, this is just a cylinder on the Earth, but instead of having it running north and south, we're going to skew it at an angle. And so it has a latitude of local grid origin, a longitude of local grid origin, a false northing, a false easting, a skew axis scale, and a skew axis azimuth. And it's all defined, the implementation of this is all defined at a local central origin. And the coordinates are rectified so that north is up, basically. So here's two projects in 2017 and 2022. Actually, this is just the one project, but it's referencing a project from 2017 of where UDOT has used this. And Riley, did you want to say anything about this?
No, just that really that we're just going to try and use these and kind of implement them over the next couple of years as pilot projects, just so that when they do come out, that we can have full implementation into our system. That's really all I wanted to say.
Okay, and here you can see these two. This is on the left is the notes from a control sheet, a UDOT control sheet for a project, and it's just specifying the same parameters that we talked about. The central latitude and longitude, the false northing and easting, and a scale factor. Okay, and it's all based on the geodetic datum of NAT 83 with the vertical datum NAVD 88. And if you can see on the right-hand side, this is just how it works inside of in MicroStation, the Geographic Coordinate System properties. And it's all based on the GRS 1980. Okay. So again, let's look at this map projections one more time, but this time let's throw in the topographic surface and see what we see with this. So when we project our grid distance and our ellipsoid distance, we can see that the grid distance is approximately equal to the ground distance over a finite distance. And you can see that there's 2 points on this display that show that it's equal, but there's a lot of area in between that the topographic surface is not equal to the grid distance. So one thing we can do is we can take this projection axis, we can tilt it over, we can move it over so that we have many points where the ground distance is equal to the grid distance. But the one problem with that is that the ellipsoid height is going to be different over the whole thing. But this is the only way to reduce the variation in distortion due to the change in the elevation differences. But for large areas, there's not going to be there's no single defining ellipsoid height. And then again, when you look at even larger areas, no matter whether you're taking into account the topographic surface or not, there's no single defining ellipsoid height for scaling the project over large areas. So just to summarize the low distortion projections, it optimally minimizes distortion over design area. It's minimized when developable surfaces at ground, and no single design height for large areas. For areas of sloping topography, you offset the projection axis from the area centroid. Use existing standard projections. You reference generic datum, not specific realizations, so it'd be NAT 83. And the documentation or the metadata is essential. But we kind of talked back and forth a little bit about minimizing the distortion and LDPs. There is a difference, and NGS has kind of defined it, but they haven't really said it real well. So I'm going to bring that up a little bit here. So in their design criterion, you can see that they're going to be designing everything above 50 parts per million. That's just a minimized distortion projection. What they're saying is a low distortion projection is anything less than 50 parts per million. Okay. So let's look and see what that really means by looking at some current projects versus the old, versus the proposed projections. So here we have the UTM Zone 12 North and the proposed 2022 projection for the statewide layer. You can see on the left-hand side that most of the state is running anywhere from negative 400 parts per million to 800 parts per million. Whereas on the right, we can see that everything, that 99% of the population, 96% of the cities, and 86% of the entire zone is going to be within 300 parts per million. And that's about 1.58 feet per mile. Okay, so that's a big improvement just in that one case over the state. And you can see that in the color codes, basically. Again, that's based on the criterion is fitting within those 90% of the population, 75% of all cities and towns, and 50% of the entire zone area. So here we have if we would take the existing 83 central zone, this is what it looks like in 83. Again, most of it is up there between negative 200 and negative 400 parts per million. But using the proposed projection systems, we bring that down to about 100 parts per million for 99% of the population, 81% of all cities and towns, and 60% of of the entire zone area. However, we've worked it out with NGS to do even better than this. This is what they would have done if we didn't go through and work with them and define the 11 zones throughout the state. This is just with the 3 zones that we currently have. So what we will really come up with, or before we get into that, let's look at that a little bit. And maybe this is just a little bit to see how this differs from the method we're using with modified state planes. So this is the typical secant section looking at 83. And again, this is how it looks when you're looking at a cross section. And this is what Washington County would look like based on the NAD 83 projection. And you can see that most of the county is anywhere from negative 80 parts per million to negative 300 parts per million or more. But if we take that, and this is what a modified state plane coordinate does, we take that cone and we scale it to ground, we get this situation where we're moving it up to match the ground. And this is what it looks like if we scale that to ground. For example, we're doing a project in Leeds, and you can see that it covers Leeds very well. We're within plus or minus 20 parts per million, which is around 1/10 of a foot per mile. But it only covers a small area of the whole county. You can see that. Whereas if the new distortion, we take that scaled to ground cone and we tilt it, we move the central parallel and match the topographic surface better, and we get this. And here you can see that most of the populated area of the county of Washington is covered in plus or minus 20 parts per million. Much better than the modified state plane coordinate system. So we can use this projection for most of the county, whereas in the past we'd have to use a different projection for and to get the same results for Leeds than we would for St. George. So where is this going to happen? Again, we have the first layer, which is the statewide layer. And again, that's everything, the 99% of the population and the cities and towns, and the 86% of the entire zone area are going to fall within 300, plus or minus 300 parts per million distortion. This is our 11 layer, 11 zone layer, which has 11 zones that cover multiple counties. And you can see that this is bringing it down to plus or minus 40 parts per million distortion for 98% of the population, 88% of all cities and towns, and 58% of the area of the combined zones. So that's 2/10 per mile. That's a big improvement from what we've had in the past, and a big improvement from what we would do if we just did the 3 zones that we currently have. But in addition, we're doing a third layer, which will include LDP zones. And the Glen Canyon National Recreation Area is one of those LDP zones. And basically those we're looking at accomplishing close to 20 parts per million for these LDP zones. And so here's an example why we would need that. Here you can look at Washington County. You can see it covers most of the county, but when you look at the Highway 59 running up along Apple Valley towards the Hilldale, that's not covered very well. And so what we would look at is a low distortion projection that would cover it better. Okay, and you see that even hits Highway 9 going from Virgin up through Rockville also. So we're currently working on the third layer, which is partial coverage of LDP zones along the federal and state routes. And basically, you can see these red boxes. These are some of the routes that we've identified that we're working on to improve the distortion. All these lines are showing all the different highways and state routes and the federal highways. And the green is in the 20 parts per million. And when you get into the reds, that's you're looking at 25 and above 30 parts per million. The dark red is above 30 parts per million. So we're looking to create these LDP zones so that they will all fall closer to 20 parts per million. So that we're looking at a tenth of a foot per mile, basically, is what we're trying to design these to pretty much eliminate most of the distortion you're going to have with just the mapping product. And we're estimating that we're going to have 50 to 60 LDP zones. And that's basically it. If there's any questions.
Thanks, Brad. All right, guys, hopefully everybody was able to assimilate that information. To me, that's one of the most exciting things I've seen. Throughout my experience in surveying, this has been probably, besides just making the equipment work, this has been probably the #1 question as to how to get coordinate systems to be cohesive, but yet also allow us to do what we need to do as surveyors in terms of following in the footsteps of the surveyor before us. So hopefully, I mean, just to see those low distortion projections, the thought that just kept going through my mind was you guys have tricked this out. I mean, to see those LDPs and those short corridors, I mean, you've considered all the different scenarios that we have in the state, and there's going to be low distortion projections available that we can use, and just would be much more cohesive coordinate system that we can start to tie these surveys together. So hopefully there's some questions for Brad and Riley. Before we get into those, we do have another poll here. So this is a real time. That's pretty cool. I think the interesting question that keeps coming to my mind is how to kind of have your cake and eat it too, to be able to do topographic surveys and even boundary type surveys using the low distortion projections, but yet also be able to calibrate to previously held basis of bearings and other, local control to be able to find other evidence that is relative to that. And based on our conversations with Trimble and the fact that this is being quarterbacked by the NGS, these coordinate systems, I'm speculating here a bit, but my guess is that they will all be implemented into the software. And so it's just going to be a matter of hitting that drop-down coordinate system library and then selecting that zone and then going back and forth. If you needed to calibrate, you can do that, but then you can also reapply that zone and then be in that coordinate system for any other submittal that you need to do. So
yeah, they should have most of the projections defined by the end of this year. And that I know that Michael Dennis wants to get those out to the vendors as soon as he can so that they can start looking at it. So probably in the next year, the vendors will be looking at these things so they can get them into their libraries.
Yeah. So for the end user, it's actually going to be very easy to apply these. And my guess is if history holds, it won't be too long before we will be required to submit surveys on specific coordinate systems, because this will dramatically impact the way we record land documents, and it will hopefully help with all the overlaps and gaps that we currently are fighting with in all the recorders' offices across the state. So Emily, is there any other questions that we can give to?
There was one in the chat that was asking if there's been any other pushback like from surveyors or on the political side that you've heard of?
No, we really haven't heard any pushback. All the counties are very excited about it. We've gotten a lot of exciting reactions from it when we presented it at the UCLS. The GIS groups are excited about it, because it covered the 3 different layers cover both mapping for GIS, they cover planning for the state and counties, and they cover engineering and surveying needs also when you get down into the 11 zones and the LDP zones for the roads. UDOT is very excited about it.
There was also one other question that came in that said, how will elevations and heights be compensated for? Will there be a series of benchmarks or some kind of modified geoids?
There in the datum for 2022, there will be a different geoid that they'll be using, yes. And that's based on gravimetric data. They're flying the continental United States right now with a special setup in their airplane to measure all the gravity measures along the place, just like a photogrammetric project, but it's gravimetric. And so the geoid will be a lot different. Will be the GPS, I believe, this is my personal opinion, it'll be much better vertically than it is now, so that you won't have a problem with it.
That would probably be in conjunction with the advent of the new vertical datum, though.
That's right.
And then I have one more question. It says, how do you get coordinates that are over the line boundary into another zone?
It's just the same way that you do now. I mean, the coordinates will be available past the boundaries. The boundaries are just a typical area that you want to, that's designated for it. But you many times, like for example, right now, we'll use the central zone coordinates in some of the northern zone areas. Like for example, up in the Summit County, they use the central coordinates, but when it's actually in the northern zone area. I don't know if I answered that question very well. I'm sorry.
Well, at the end of the day, you will have that coordinate zone option to be selected. And so if you have a survey that goes over the borders, you can select either or and submit coordinates in either of the zones. And then you could also even create some kind of a combo, but that would be definitely taking it to a much more advanced level. But that's typically what people do, is they pull the trigger on a zone that they're operating in, and they go with that zone, even though there is, and with the low distortion projections, what Brad's been describing, this will be much less of a problem than with the current state plate coordinate systems. So
one thing I want to just mention, so as part of this, as Brad showed, we have those raster images of the distortion. So I imagine we'll have some type of an interactive map that as you're planning your survey, you can go in there and see where we've kind of defined the boundaries, but those rasters will extend outside of that. So you can say, oh, it extends 2 miles into this. Oh, our distortion still is good that covers this project. So you can just kind of pick and choose which system you want to use based on that raster information.
And we're talking about that interactive map, and we're talking, it might end up being on the UGRC website, so that you'll be able to go on to that interactive map and see which distortion would work best for you in your project area.
Very cool. A lot more cohesion in all the hundreds of surveys that happen, to be able to have a cohesive system that you can just pull the trigger on what the coordinate system is that you're using, and you would have consistent coordinates with other surveys in that area. That's what this is accomplishing here. And not only do you have cohesion, but you have low distortion. And so it's precise and ground. And those things are turned on for you. And so there's some pretty awesome automation there.
Hey, Troy, this is Sean. Can I make a quick plug here? We're working with the NGS right now to do a GPS on benchmarks push for this year to try and enhance the geoid model. So we have 2 representatives from NGS that want to get together in some kind of a webinar, probably in May. So you'll see some emails go out from the UCLS about that, but I think they're wanting to improve kind of a hybrid version, the gravity model that Brad was talking about, along with GPS on benchmarks. So that's the update, but you'll see something come out in May.
Okay, any other questions?
You don't have anything further in the chats.
All right, let's go ahead and announce our poll winner.
Whoop, whoop. Next poll winner is Steve Porter. You have won yourself a $50 gift card. If you'll send me your delivery address, I'll get that going right out to you.
Yeah, Emily, I could probably deliver that to Steve. It's high time for me to come visit the city over there. So if you want to do that, I can do that.
All right, perfect. I'll make a note.
Steve, you always thought you would never win anything, and today it happened, my friend. So good job. All right, let's go ahead and move into the next presentation. We are running about 20 minutes over schedule here, and so because Mikey, Melancon, and myself are going to be doing this next one, we'll probably trim this one down a little bit. If I'm the presenter here. All right, let's see here. For some reason, my PowerPoint is not working. Let's see here. Bear with me here, guys. Just 1 second while I get this going. Oh, if that's because it's over here. Hmm. That's weird. Hmm. Yeah, I don't know if he has it. I think he does have pretty much. Sorry, guys. As per normal on these things, we're having a little bit of a technical glitch. Okay, let's see if we can get this one to go. Huh, wow. Emily, are you going to make Mikey the presenter here then?
Yep, he's set up as co-host.
So go ahead and share that screen, Mikey. There you go. There you go. Now you should be able to go into your PowerPoint. There you go. And now you should be able to launch the slideshow. You might need to launch it before you shared it, or if you can go back to the actual software. Actually, that would probably work. Can you can see the PowerPoint there and just unlaunched, I assume, Emily?
Yep.
That'll be fine. All right, guys, our next presentation that we're going to go through here is just a quick RTX presentation. Let's scroll down there. You're going to have to run this or put it over here.
Yeah.
All right. There we go. All right. So the purpose of this this presentation today, and maybe I should say really quick, everybody on the call probably has met me or knows me. I'm going on my 22nd year here at Monsen Engineering and have been training and selling Trimble geospatial for that amount of time. And before that, I was a land surveyor. Actually just recently have gone back to school. I'll be graduated with my MBA here in a couple of months. And that's been interesting. And then I have an undergraduate degree from Weber State. And then Mikey is ex-military. Mikey, would you like to share anything about yourself before we go on this?
No, excited to be here. Excited to present.
Okay.
Been surveying for 12 years. I've been working at Monsen now for a year and a half in tech support. So.
Okay, awesome. Thank you. Mike's been awesome. Great addition to our team. Okay, so the purpose of this presentation, everybody, is to talk about RTX. RTX as a new technology and as a new ability to be able to use our survey equipment, and it's a very exciting technique and procedure that we can use, especially with the new advents with the software and the technology itself. So what we're going to try to do is we're going to try to show some different solution types as part of a field demo. And the idea here is that we want to try to differentiate between RTX and VRS, because that's where we get a lot of our questions when it comes to RTX, because RTX has actually been around for a while. But the question is, how can I use RTX, and what are the barriers, and how does it compare with a VRS solution? One of our main goals here is to show you that VRS will always have a role in terms of its precision capabilities, and also just how it is managed and how it is constantly improved upon. So RTX is not as good as VRS in a lot of regards, but it is pretty amazing what it can do. And that's the object of this presentation, is to show you what it can do and how the software works with it. So we're going to do an emulator demo to show you how that functionality works and how you can, fluctuate between state plane and site calibrations, and an explanation of how the Access software is actually doing what it's doing. Then we're going to analyze some differences between the different solution types, RTX versus VRS. How repeatable is one versus the other? And then some workflow variations to accomplish the various tasks that we have. And then hopefully we'll have enough time to take a quick look at TBC, because Trimble Business Center has also improved, like Trimble Access, in conjunction with using RTX solutions. So a quick recap of where we come from in terms of positioning with GPS. So if you've been using GPS for the last 10 or 15 years, probably everybody has had the opportunity to set up an RTK base station. So RTK base stations was one of the first ways that we were able to create real-time corrections out in the field. The purpose of the base station is to be set up over a known position, see the same satellites as the rover, and because the rover can hear where the base is and sees the same satellites at the same time, we can create that correction message and correct the rover's position relative to the base. So we're going to be talking a lot about corrections in this presentation, because that's really what the RTX is another correction source. So where we started off with was these base stations, and they're very accurate. They're very precise. The accuracy can vary depending on how you set up your base station, but it's still commonly used today. But the RTK base station, one of the downsides is, first of all, this potential to be inaccurate if depending on your procedure, but also it really increases the cost, because now you have to buy really 2 receivers versus 1. You have to buy the base and the rover. Then with the advent of the VRS network, like I mentioned earlier, like 15 or 16 years ago, we got a new correction source. Now, as opposed to a mobile base station, we used a network of reference stations that Sean has shown you lots of maps of. Now we have 106, I think is what he said, reference stations in our network. And those VRS networks are working in conjunction with local cell phone towers and really the internet to provide a network correction source for our rovers. This was awesome because it was automatically accurate because of that management of the VRS network, and we didn't have to buy a base. And so the cost of getting into the equipment just reduced by about half. And we were on the internet. And so once we're on the internet, that also opens up a lot of doors for just being able to communicate better with the office, be able to stream data back and forth. There's a lot of huge benefits there. So now let's talk about RTX. So with RTX, as opposed to the mobile base station and the VRS, the RTX is a real-time satellite-based correction source. So we're going to talk about this RTX satellite. This is a geostationary satellite, stays in the same place in the sky. And because of the geostationary nature of this satellite, it can act as our base in space. There are 2 ways that we can receive this correction source. First of all, we can receive it beamed from the satellite itself, or we can also receive it through internet protocols and through cellular connections as well. So the most common, we're pretty sure, is going to be satellite-based corrections, just because one of the main benefits of the RTX is that you can be out in the middle of nowhere, no cell phone service, no local base to put up, no mobile base, and to be able to just receive that correction beamed from a satellite is pretty awesome. To be able to have that kind of freedom in terms of where you can take your rover. This is a map of the center point RTX coverage. There are a few different levels of RTX capability. The one that we're the most interested in as surveyors is center point, because that's the most accurate. So there you can see the accuracy levels of center point, 2 centimeters on the horizontal and 5 centimeters on the vertical. You have 2 different types of, they're called convergences, but I like to refer to them as initialization types, because initialization is the term that we've always used when our rovers resolve and we're on the centimeter level, right? And so we have RTX fast and RTX standard. You can see that in the continental US, we're covered with the RTX fast solution type. And so we're seeing initializations less than a minute, which is about what we're used to when it comes to initialization times. That's almost seamless. So it's automatic almost. And you can notice that if you go too far north, that you will start to lose that RTX satellite because of the northern latitudes. However, if you have a cellular or IP streamed RTX solution, you can actually still use RTX even in those northern climes. So it is really available globally. To be able to make this work, Trimble had to facilitate not only the RTX satellite in space, but also numerous ground tracking stations. These ground tracking reference stations track all the different satellites in space, all the different satellite constellations, and they are critical to creating the solutions that we're getting from the RTX satellite. It's this ground system working in conjunction with the RTX satellite that makes this all possible. But it also goes into the reason why there's a different datum involved. And that datum is ITRF 2014. So why ITRF 2014? There's lots of reasons, but the global nature of this correction source and how it is created is a big part of the reason why ITRF 2014 is part of the reference frame that is natural to the RTX correction. So in other words, if you receive a correction from RTX, you're going to be on ITRF 2014. Your lats and longs will no longer be NAD 83. And this is where usually people leave the room and will decide that they won't be using RTX because there's a pretty substantial shift in the origin between NAD 83 and ITRF to the tune of about 2+ meters. And once again, if you're using RTX, this shift is automatic. And so an RTX rover versus a VRS rover out in the field is going to be different in their lats and longs by that 2+ meters. And so that was always a major barrier, like I mentioned, to using the RTX, because trying to account for that shift in a meaningful way and in an easy and convenient way has always created a lot of real question marks in people's minds. The ITRF is pretty awesome though, what it does. The fact that it's more modern, it's more accurate, it's more efficient, and it also takes into account tectonic plate movement. And so as we move through time, using this different correction source in conjunction with the new low distortion transformations and projections that we talked about just barely, we're going to be able to maintain a high level of accuracy and precision from one survey versus another. All right, so what are the ramifications of ITRF 2014 and traditional surveying? Guys, it's all in the collector. So with the advent of Trimble Access version 2010 and later, there are some high accuracy time-dependent models that have been implemented into the software. So basically, how it works is if you're using the RTX satellite as your correction source, by simply turning on NAD 83 in your coordinate system settings, that high precision time dependent model will automatically be employed. And even though, and therefore the epoch, which is taking into account the tectonic plate movement that we just barely mentioned, even though you're measuring on ITRF 2014 from the RTX satellite, the corresponding NAD 83 position will be calculated. and it's amazingly robust and automatic. So in the past, because like I said, RTX has been around for a while. In the past, there were some pretty cool techniques that Access employed to, to account for this translation of that 2+ meters. But now it's very much more automatic just by picking Ad 83 2011. All right, so going to the field demo, I apologize for these pictures. If I was a better IT guy, I probably would have taken screenshots on the data collectors themselves. And so I do apologize for being able to. I just wanted to show you, though, that if you look at this screen capture here, this little satellite here on the top, that's the RTX solution. You can see my mouse in there. Oh, yeah, right, here we go. If we can use the you can see the RTX satellite there. And then next to that, you see the precisions, and the precisions are about 400ths by 700ths using that RTX solution. All right, so I just wanted to show you what a couple of those screenshots look like. This is the RTX. This is what the RTX solution would look like out in the field. The equipment that I'm using is a R12i and Trimble Access version 2020, actually. All right, so here's another screenshot. You can see that I'm still getting an RTX solution. I'm actually using some tilt, and you can see that the precisions are not too bad, pretty typical for GPS measurements. A little bit noisy on the vertical component maybe, but not too bad for, especially for horizontal work. It would probably be okay to be able to measure with these solutions. Here's a picture of some typical canopies that I was dealing with on this test. One is a deciduous trees in winter, so not much of an obstruction there. You guys are probably thinking, oh shoot, my 15-year-old receiver could have taken a shot there, and that's probably true. But then I also took some shots underneath a pretty typical pine tree, and that definitely did have an impact on satellite availability in general. So I just wanted you guys to know that I was trying to simulate a real world environment out there. So this RTX versus VRS simulation and demo, what I did is I took 4 total shots on 6 points. 2 shots were with RTX and 2 shots were with VRS. And we want to take a look at how those compared. So on the shot underneath the pine tree, this is RTX again. You can still see the satellite there. You can see that my vertical precisions have diminished there a little bit because of that pine tree. And but still pretty typical with what we would see with a GPS measurement there. Okay, now going into some VRS measurements, you can see that my solution type has changed. I have the internet here, and my solution precisions are a little bit better, especially on the vertical component using the VRS. And then this is just an example of staking out a point that I had shot with the VRS from previous, and just you can see the kind of precisions that I'm getting out there. This is kind of out in the open, so you would expect that the precisions would be pretty decent. All right, so let's go ahead and go into the emulator. I just want to show you guys what this looks like in the data collector. I want to examine some point pairs, look at these points in RTX versus VRS, take a look at some typical workflows, how we would use the RTX to get the kind of coordinates that we want, whether we're calibrating or not. And then also the VRS. Now this is going to be, you're going to have to make me the presenter again, Emily, because I need to get this emulator going. You could probably share. Oh, but here I need to stop share here. And then,
There you go, Troy. You're a co-host now.
Okay, everybody should see my emulator now, right? Okay, beautiful. All right, so what I have here is I got two jobs. These are jobs in Access. One is on no projection, no data, and one is on state plane. And so these are jobs, this is the exact job from the collector out in the field. And so I just took that .job file from the collector and brought it right here into my emulator. And so you'll be able to see exactly what this looks like. So I'm going to open this up. So this is the state plane job. If I take a look at my properties on this state plane job, you'll see that state plane is picked here. And if I look at my library, this is pretty standard selection options for state plane. But here's the big difference. This displacement model is being applied. And so once again, to use RTX, this is all we have to do. Just pick NAD 83. So if I escape out of there, let's take a look at some of my coordinate pairs. So if I zoom in here, we'll zoom in on some of the noisier points under the conifer here. You can see that we're getting pretty close, and these points are all kind of on top of each other, even though half of them were shot with VRS and half of them were shot with RTX. And so you can see that they're all within just a few hundredths of each other here. So if we take a look at my point manager, basically points 100 through 105 and then 200 through 205 are all shot with RTX. And then 300s, the 300s and the 400s were shot with VRS. So if I was to inverse from point number 105 to point number 305, I would be inversing from an RTX measurement to a VRS measurement in the same job. And so let's go ahead and do that. Compute an inverse. We'll go from 105 to 305. And so this is under the pine tree. And so it's kind of a noisy measurement in terms of just our, GPS measurements. But you can see that even though one was shot with RTX and one was shot with VRS, we're right on top of each other. Most people would say that was within kind of survey tolerances, depending on what you're doing. I know 600s might be a little bit noisy on the vertical component, but definitely on the same coordinate system. And so this is the real aha moment. I'm hoping that you're thinking that, okay, I could use that. So now if we go back to this other job here, my no projection, no datum job, you could see that on this one, I have a standard local site. And if we take a look at our parameters here, this would be something that we would have calibrated to 5,000, 10,000. We have a ground scale factor in there, pretty typical for this area. We've calibrated to some basis of bearing. We have a rotation in there, and we still use RTX. And so as far as the northians and eastians are concerned, you can use RTX. Northians and eastians are no problem. You can go ahead and calibrate away and be on the coordinate system that you want for the type of work that you're doing. However, in this job, if we inverse between, once again, that RTX measurement and the VRS measurement, now we see the 2 meters. All right. And so that's one thing that we'd probably avoid, is using 2 different correction sources in a job where we're not using state plane. That would be the only time that you would really fall down if you were using these techniques. But check this out. So if we escape out of here, I'm in my no projection, no datum job. All I have to do is change this to state plane. All we have to do is change this to state plane. So I'm going to go ahead and pick my state plane zone, accept, and we'll go ahead and open that back up. Now, if I take a look at that same 2 points, just by going to state plane, I'm back to being right on top of each other. And so what I'm trying to show you here that is you can really have your cake and eat it too with RTX. You can still, you can calibrate to a coordinate system. You can use state plane. At the end of the day, if what you need are NAD83 lats and longs, just change the coordinate system to state plane. Export your points, and then you can go right back to your projected or to your calibrated site. And so I'll go ahead and demo that really quick. I'm going to go back in here, and I'm going to change this back to no projection, no data. Turn on my geoid model. And then I'm just going to go back in and reapply that site calibration. So I got my 2 points, so just go ahead and reapply that. And now I'm back on my project grid. And so now if I do my inverse once again between VRS and RTX, I'm different again. But hopefully that makes sense. Hopefully that is something that will take away a little bit of the mystery of using RTX. Just real briefly in TBC, let's see, I have to share this. Stop share on the emulator, share TBC. All right, that's working. So I just wanted to show you really quick in any job in TBC. This is version 5.4. There's been some cool tools that have been implemented. First of all, if you were to import any raw data file that was collected out in the field, you're going to get an option to process with RTX. And then also in the coordinate system management tools, you are in the settings, you have some RTX post-processing options. And you can select the different datums that are already part of TBC. So you can transform back and forth from one datum versus another, like they have NAD83 2011 here. And so a lot of the same tools that we have in Trimble Access, we have in TBC as well. Now that is in the intermediate version, I will mention that. And so in intermediate, that's where some of these tools are that I'm showing you now. All right, let's go ahead and stop that share. Let's go back to the PowerPoint. You're going to have to make Mikey the presenter again.
Will do. He is set as a co-host.
Okay. Come on, I cannot advance. Let's go ahead and share a little bit different option here. All right, I just wanted to show you this screen right here. Hopefully you guys can see that okay. This is an example of RTX versus VRS. I feel like this is the real important thing. You can see repeatability here. So in RTX versus VRS repeatability, if I just get this out of the way here. On the horizontal component, I have outlined in red when we've exceeded 0.05 of a foot. So on the northern component, we exceeded that on a few of these measurements. On the easting, we only exceeded it by on one of or two rather of the 6 different measurements that were being analyzed here. But on the vertical component is really where you can see RTX kind of falling short compared to VRS. In other words, if we do a VRS comparison, we have much better repeatability across the board, both horizontally and vertically. And so now when you look at these numbers, they are definitely less precise than VRS, and we are, pulling no punches when it comes to that. That we want everybody to be fully aware of that. But I also want you to be aware of what the technology can do and how you can turn it on in the system. And now I'm going to turn it over to Mikey, and he's going to show you how to how you buy it and how you get it turned on in your system. Little musical chairs here.
All right, hello everybody. So I will be talking today really about how to purchase the equipment, how to apply it in your web user interface, also the other 3 different methods of applying RTX, as well as creating a survey style. We'll try and be quick. I know we're running about 20 minutes over, so I'll try and speed through this for you guys. All right. Hopefully everybody can hear me as well. I know y'all haven't been able to hear me in the other room, so if you have any problems, let us know. First, we're going to talk about compatible GPS receivers, and really what I want to point out is the receivers that are not compatible. Unfortunately, if you are using R8s or R6s, those are not compatible receivers for RTX, but anything newer than an R8 or R6, so you can use R10s, R10 Model 2s, R12s. You can also use Spectra receivers. These are the ones we support. We have put it on an SP80 as well as an SP85. There are 5 different correction services available. Well, 6 if you consider Exfil Premium as well. The one that we are really focusing on today is the Centerpoint RTX, and this is the sub 2 centimeter accurate, 5 centimeter on your vertical accuracy as well. And we'll go through how to apply one of these center point corrections into your receivers. Okay. So the 4 methods for activating your RTX subscriptions are over the air, passcode entry, QR scan code, which is something that I can't ever see you using, but there is an option for that, as well as applying a license file to your receiver. On this screen, this is actually the correction service that we use for the R12i for the demo. The information that you're going to be sent will be this QR code in the top right corner. You'll also receive this subscription activation passcode, and that is the one piece of information that you can use to activate in multiple ways. All right, here we have a brief description of all 4 methods of applying your RTX code. Over the air is simply over either the same L-beam satellite connection that you would use to survey, or the same internet or IP protocol that you would be using to survey. QR scan code, once again, we won't really go into it. Some receivers do have the ability to take pictures and apply those QR codes. We have not had to use that up to this point. All right, license files are receiver dependent. So if you were to use, say, Spectra equipment, it would not only send that passcode, but also a license file where you can attach that information to an SD card or a USB drive and apply it directly to the receiver. The one method we're going to really focus on today is the passcode entry. You will actually use, for the passcode entry, you'll use the unit's web user interface. I know I've worked with a lot of customers, a lot of you guys that are here today on updating firmware in the web user interface or doing different things, but today we'll show you where to apply an RTX code, and this could be a simple 3-day code or a 1-year code as well. At the top, you have the IP address. We're actually recording this and going to send it out. So for time's sake, I'm not going to read off everything. Username for all receivers is admin, and password all lowercase. On to our next slide. So here in our web user interface, there are 15 menu options on the right side of your screen. The only one we're really going to worry about today would be your receiver status. In the receiver status, you have such information as your current position, your activity. You can change the identity of your receiver itself and rename it. We've had to do stuff, do that before to apply certain updates, but today we'll worry about receiver options. In the receiver options tab, you have the ability to input an option code down at the bottom of your screen. Once you have installed this option code, you'll then show in your correction services a subscribe, center point, RTX fast, or whichever level of RTX correction you get. You will see that information under your correction services, as well as an expiration date for that. All right. Next, we'll talk about creating the survey style and how easy it is. There really is only 2 options for doing so. All right, so as you can see here, we have the 2 different format or broadcast formats. We have RTX over the internet or RTX over L-band satellites. First, we'll talk about RTX over the internet because it is very similar to how you're working today with the VRS. As long as you have the RTX correction programmed into your receiver and a Wi-Fi or cellular connection, you are able to use a very fast correction service. Now, I say fast because this one will initialize much faster than RTX over L-band satellites. I believe when we did the test, it was under a minute, 30 seconds or so for us to get initialized with RTX over the internet. The correction over L-band satellites, the one benefit to using that is that it can literally be used anywhere without Wi-Fi or cellular connection. The one fallback I would say compared to RTX over the internet is initialization times. First time we set this one up, I believe it took it was about 8.5 minutes for us to get initialized. But after that 8.5 minutes, it did speed up the next couple of times we were able to connect to it. You'll also notice when you do your broadcast format over the internet that the setup is very similar. You will also select a mount point and it'll just simply be RTX over IP, and that'll allow you to get that correction as long as you have an internet connection. I'm going to kind of foot stomp what Troy said as well about this not replacing anything. I just think it's another great tool to add to your arsenal. I know we've used it a lot in our rental section, done a lot of trainings with it, and it is a very valuable tool that you could add to your arsenal. Hopefully I was quick enough. So without further ado, we'll kind of conclude this presentation. I'll turn it back over to Troy and we'll answer any questions anybody has.
That's high-tech transition right there. All right, Emily.
I have one question and one comment.
Okay.
One is about the RTX corrections. Do they compensate for continental drift?
Yes. Yeah, that's part of the HTTP transformation parameters that are now a part of these new software realizations in Trimble Access and Trimble Business Center.
Okay, and a comment that came in said that if you load a state plane project from TBC and you want to use RTX, you need to choose the state plane in the TSC7 and save it again.
That probably came from a user that's tried this. So in other words, what's happening is when it gets uploaded from TBC, it must be coming across as a local site. And I'd be interested to play with that a little bit. We just have to make sure that the HTTP parameters are employed in the coordinate system settings, which I think is what they were describing there, where they're actually deselecting the local site that came from TBC, even though it's the same stuff, and returning it on in Access. There must be something there that's triggering that HTTP transformation parameter. So that's probably an accurate statement.
Okay, and then one more question just came in. It said, would measuring observed control points improve repeatability between VRS and RTX?
Always. Yeah, whenever we have longer measurements or multiple measurements on the same point, we're going to improve our confidence level, whether we're using VRS or RTX or any other measurement method, especially if we're taking those different solutions, everything being equal, and we can calculate an average position. There's some pretty cool algorithms in Trimble Access that is pretty awesome at doing that. So using duplicate points. All right.
And that's all I've got.
I did want to mention, did you mention the cost?
I did not.
So just, I'm surprised that nobody asked this question, and I just want to be totally transparent here. It's $2,000 a year for RTX, which is actually pretty comparable with a lot of VRS networks across the country. We get a great bargain in Utah with our $600. And so, so with those the equipment mix that Mikey was talking about, like if it's an R10 or above, an R2, some of the Spectra receivers, and then Trimble Access version 2010 and above, theoretically with what would now be a $2,600 a year, you could get VRS and RTX and be able to have those kind of functionalities. It doesn't take setting up base stations and opacizing base stations and or dealing with radio link issues out in the field to compensate for the kind of cost improvements that we can get by using RTX. We do have to have these balls in place though. And so I can't stress that enough.
One more comment did just come in. It says L-band works great in open areas, but plan a little longer for initialization when walking near or under tree canopies. It was great to do work in canyon areas where cell service was unstable.
Yeah.
Yeah.
Yep.
That's well put.
I think that also came from another user, and that sounds about what we've seen. When I used RTX fast out in the middle of nowhere, it was initialized as fast as any initialization or any typical initialization for me. But if you have obstructions, you have obstructions, and so that will definitely impact your solution strength. Any other questions? Okay, let's go ahead and I think we put our poll up there. Emily, do you have a winner for this last poll?
I have a winner. I have David Mortensen. Another $50 Visa gift card for him. David.
Dave is going to win one.
Oh, good. I'm glad. If you will message me where you'd like me to send the card, I'll put it in the mail.
All right, that Dave's actually Brad's brother, and so there must have been some collusion there.
Well, you did say you wanted him to win, so I put that on you.
All right, guys, we are running about a half an hour behind schedule here. We might cut into our lunch break a little bit. Let's go ahead and move forward though, and move on to Mr. Trent Keenan with Mentoring Mondays. Let me just tell you a little bit about Trent. Trent Keenan career started when he was 19 and now spans over 25 years, including 10 years in the public sector working for large utility companies and 15 years in the private sector, with 12 of the 15 years being the president and founder of Diamondback Land Surveying. He has served through all office positions for both the Southern Chapter and State Association of NALS, receiving the Meritorious Service Award for NALS in 2013 and was honored as the NALS Surveyor of the Year. As past president of NALS 2015 and current editor of the Nevada Traverse publication, he's also current WestFed director from NALS and current director on the Nevada Land Surveyors Education Foundation Board. He's the current director of the Southern Nevada chapter of NALS, moderator, facilitator, founder of Mentoring Mondays. This is a very impressive surveyor, my friends. He is currently licensed in 5 Western states. He's also certified federal land surveyor and Nevada water rights surveyor. He has been an active board member in NAL since 2007 and a regular member since 1997. So Trent, I wish we could applaud at bringing you in here. But welcome and thank you for presenting today.
Thank you, sir. I gave you the short version. You don't have to go through that whole long thing.
It's too good.
I appreciate it. Thank you. I did do a PowerPoint. Let's see if I can share. I don't know if I can share it yet. Nope. Oh, you got to stop sharing first, Troy.
Oh, I think that's
or Mike. Oh, I was able to do it.
You should have stopped now.
Yep, I was able to do it. And here we go. So what the heck is Mentoring Mondays? The next slide just has our little intro video. So I just caution your computer speakers real quick, but let me try to play this or not. Cannot play media. Well, let's go find it. 1 second. Go ahead and play the video. It's all those the technicalities. There we go. So that's the intro video that we had put together kind of to go along with our website. Gosh darn it. You think you're all ready to go until you have to start switching screens. There we go. I'll leave it there and I just won't go to presenter mode because I keep messing it up. So Mentoring Mondays, basically it started on a road trip up to Reno. And I had just recently built a augmented reality sandbox for our Southern chapter here in Las Vegas. And I had built a second one for the Lahontan chapter up in Reno. And so on my trip driving up to Reno, I had started searching for podcasts because I had a 13-hour drive up and back, and started listening to some podcasts, came across Surveyor Says, came across the Geoholics, and really kind of started listening to all of them. And just kind of realized that at 43 and 25 years in the profession, I wasn't the kid that I still thought I was in the profession, even though, you know, at 43, when we go to these surveyors meetings, I'm still kind of the youngest one in the room. So it just kind of gave me an idea of what we could do to kind of bring the nation together in a mentoring aspect. And I had done something locally here in Las Vegas back in 2006, 2007, when the exams were on that April and October schedule. I would run 16-week study group sessions leading into that exam. And so when I started listening to the podcast, fast forward to April, or fast forward to May, I had done a session on marketing and promoting the profession with Kent and the Geoholics boys. And it kind of, fast forwarded, spearheaded what I thought would work. We had the Tri-Skate conference in August. All the conference had to go virtual last year. Ran through the virtual seminar conference last year. And again, it just kind of solidified that the acceptance of Zoom, the lockdown, the digital aspect of this, we could really kind of platform something together that would work and bring the country together in one premise of what I had done back in 2006 and 2007 with the study group. So, and while doing that over the summer, I had started this research project, and some of you here within NOWS or, maybe members of NOWS got the edition that I was published in December. And during that research project, I just kind of started seeing the trend of, we all heard the average age of surveyor is 61. And so I started to do this research project, and every bar graph I ever put together is in a downward trend. And so after the research project, after the conference, it just kind of helped me put this whole thing together. One of the Zoom seminars or one of the breakout sessions during the conference, I had kind of just thrown out the idea that I wanted to start this Zoom thing. And Rob McMillan, who's actually CLSA state president this year, he's the one that threw out the idea of the name, and that called it, when I said I want to create this weekly thing, he called it Mentoring Mondays. And so that just kind of stuck. So created this virtual platform similar to what we're doing here today. The premise behind it was, the Facebook groups, they all, somebody asks a question and they all kind of get beat up for asking a silly question or a stupid question. The keyboard cowboys, as I say, just kind of get beat up. So created this platform allowing them to kind of come in, ask questions, have an open forum, and really get some good feedback and answers rather than getting beat up on a keyboard. So the only upward trend out of all of this data that I found is these are provided by NCES, and this was the average age to become a licensed surveyor, and that continues to tick up. You'll see it's probably about 38 and a quarter when you get an average age of a licensed surveyor now, finally, which again, in these downward trends, it's tough to continue on. So part of the Mentoring Mondays is finding a way to educate the existing workforce that we have, help get licensed, get people licensed who are in the existing workforce, and hopefully fill some of these gaps that you're seeing. So part of the premise was here in Nevada, we could possibly lose 120 surveyors over the age of 61 within the next 10 years, which is about 42% of our state licensees. But by comparison, we've only licensed 32 in the last 10 years here in Nevada. So there's going to be a huge gap, and we need to find a way to fill that gap with the existing workforce and or continue the marketing and branding of the profession as much as we can to bring in that younger generation. So another thing that we're really, really big on is get kids into survey. So one of the things that I've done as part of Mentoring Mondays, if you do sign up and participate and become a presenter, I pay to get your character created for Get Kids into Survey, which goes back to the very first one, kind of our arsenal of presenters so far. Last night, we just finished week 25. And so as part of being a presenter, I get these characters created, encourage you to kind of become a Get Kids into Survey brand ambassador and help promote the profession any way we can to kind of fill the gap. So again, anybody who's presenting today, would love to have you on Mentoring Mondays. Kind of the premise is it's about 45 to 60 minutes of presentation and then about 30 minutes of Q&A. We try to keep them about an hour and a half, although the last couple of weeks we've pushed almost an hour and 45 and 2 hours. So there's not a lot of structure to it. It's really open forum, real kind of free flowing, and we just kind of let the topic run the night. And one of the other things I just recently did is I went kind of go back to my original plan, and that is I'm going to have an open forum every week rather than a speaker. I'm going to have it as a open forum for anybody studying to take the exam. And that first Monday of every month will just be kind of open topic and allow anybody who's sitting for an exam, who's got some issues, needs help to get pass that question, that last question on the exam, they can join in on Mondays. So you can jump on any social media. There's all of the links to the social media is my email if you want to jump in, participate, and or my cell phone number. So I know you were kind of running behind, so I just thought I'd keep it short. And got questions, definitely email me. I'll throw the website in the chat. You can register for any of the meetings coming up right on the front page of the website. So with that, I will turn it over to Mr. Kent and let him take over. Oh, and it looks like maybe you can do that, Emily.
I will make Kent a co-host.
Look at that background.
All right, Kent, you should be all good to go.
All right, let me see if I can figure this out.
It was tough. And I do Zoom every week, and that was still tough.
Are we good?
Nope, not yet.
Really?
Share screen and then click on where your PowerPoint is.
All right, looks like that was fast, Trent. Thank you for cruising through that. We're doing a poll now.
Yep, she's got the poll up. Yeah, I know you were kind of
I appreciate that.
pressed for time, and everybody wants to at least eat their sandwich without being on camera.
I do want to tell everybody about Kent. Kent's up next, I assume, right?
Yep.
So Kent is going to be presenting on Geoholics, which is a podcast. Kent, his passion besides podcasting and the Chicago Cubs is creating a solid and sustainable foundation for the surveying profession that future generations can build on for years to come. He's been working as a land surveyor for over 30 years and believes in collaborating with the various geomatics professions and governing bodies to collectively enhance their respective occupations. Kent enjoys golfing, fishing, craft beer, good food, and traveling with his amazing wife. He also knows E.Q. Kimball and is a future curling Olympic gold medal winner. I don't understand that last part there, Kent. If you can shed some light on that.
Yeah, I'm an aspiring Olympic curler. How's that?
Well, I'll be looking forward to seeing you, my friend.
All right. Now, is it working right now?
I see you, yes, and I can hear you good, and I see what it looks like the beginning of a PowerPoint.
All right, let's see what happens here. I got a little video here. So like Trent said, you might want to turn your volume down or whatever. So real quick, let's see what happens. Okay, all right. Good morning, everybody. Good afternoon for some of you, I would imagine, and happy Global Surveyors Day. I don't know if that's been mentioned yet or not today, but before I forget, I just want to make sure that I thank Monsen Engineering for including the Geoholics in today's event. It's really my pleasure to be here. And thanks Trent for the plug for the Geoholics. And Trent mentioned that, you know, anybody who's a guest on his show, he creates has a cartoon character done for them. So you can see my background, that's the three of us Geoholics. So thanks Trent for that as well. Again, my name is Kent Groh. I'm a registered surveyor. I've been working in the survey industry for just about 30 years. I'm going to spend my time today telling you about a podcast of all things, as was mentioned. This is a podcast that myself, my co-host Ryan Kelly, and Jake Ivey, better known as Producer Jake, embarked on about 2 years ago. And to be perfectly honest, if you would have told me then that we'd be where we are today with this podcast endeavor, I probably would have said you're crazy. So let's get in this. Next slide here is going to be pretty quick as well. I did want to provide some podcast statistics I thought everybody might find interesting, I should say. So there are currently over 2 million podcasts worldwide with over 47 million available episodes. And that's pretty recent as of last month, as a matter of fact. 75% of the US population is familiar with the term podcasting. 55% of the US population has listened to a podcast. 17 million people in the US are avid podcast fans. I'm definitely one of those 17 million people. 51% of podcast listeners are male, and age of monthly podcast listeners in the US, as you can see, 12 to 34, that's 48% of the listenership. 35 to 54, 32%, and 55 plus is 20%. So this is a huge, huge media platform, let's say. So the evolution of the Geoholics podcast, as I mentioned, we started this idea, or I should say we started with an idea about 2 years ago. I can't believe 2 years already, it's crazy. So thanks to producer Jake, it became a reality with episode 1, and that was on August 24th of 2019. Our first guest was Abraham Lincoln. We wanted to set the bar really high. And you're probably thinking, how could it be Abraham Lincoln? Well, you'll have to listen and find out. We really had no idea what we were doing at the time, and that's the honest to God truth. And since then, you know, we've literally had geomatics professionals on from around the globe, in addition to, you know, we've had Olympic gold medal winners on, professional athletes, and even recording artists. You know, we try to, you know, like once a month, get away from, you know, just strictly geomatics, which could be boring. So, you know, we try to expand our horizons just a little bit and get some other folks on. Our goal was and continues to be to add value and make friends. It's really that simple. And we say it all the time. If we can accomplish that with each and every episode, that we've done our job, and hopefully people will continue to come back and listen to us. So as of today, and this again is mind blowing, we've released 75 episodes and have amassed over 32,000 downloads from literally all corners of the world. Some other geomatics podcasts that you might also want to consider. Of course, I'm partial, so I put the Geoholics at the top of the list, but some others I want to make sure I mention as well. Tim Birch is the host of the NSPS Surveyor Says podcast that Trent also mentioned. Matthew Bird is the host of a podcast called Apex Mindset. XYHT Magazine has a podcast called Measure This. Shane, Neely, and Connor Brown host the Shane and Connor Show, and I believe they're associated with TXPLS. The Indiana Young Surveyors Network and Nolan Mark host Roundtable Tuesday. Advanced and NCES podcast series is another one to consider. Peter Cox is the host of Defining Boundaries. Marion Ellis is the host of Surveyor Hub. And there's also several weekly Zoom and Facebook Live events, such as, you know, Trent Keenan's Mentoring Mondays. Ways to listen to the podcast. Lots of ways to listen to podcasts. You can go to individual websites such as thegeoholics.com, of course, Spotify, Apple Podcasts, Podbean, Stitcher, Pandora, iHeartRadio, Google Podcasts. And of course, now there's Clubhouse, and a lot of podcasts have YouTube channels. The Geoholics do, of course. So if you could check out our YouTube channel and subscribe, that would be greatly appreciated. This is the important stuff right here. We couldn't do what we do without our friends of the program, and these are basically our annual sponsors. So as you can see, Monsen Engineering is one of our friends of the program. So thank you again to them for their support. Others I want to mention, of course, AGS, Advanced Geodetic Surveys, Aerotech Mapping, Cyanic Automation, Cobb Fenley, Bad Elf, Diamondback Land Surveying, Get Kids into Survey, Parkland Community College, Mentoring Mondays, Safety Apparel, Land Surveyors United, Tiger Supplies, and again, Monsen Engineering. What's next for the Geoholics? First of all, we just signed a lease last week on some dedicated studio space, and I'm gonna toot Trent Keenan's horn a little bit more here. He has been a supporter of the Geoholics podcast from day one, and he actually, let's call it, he secured the naming rights of the podcast, or of our studio. So it will be the Diamondback Land Surveying Studio. So I'm super excited about that. We get into it next week. That's gonna be huge for us, because right now we're like breaking down our gear and setting it up every time. It's a bit of an inconvenience, but we make it work. So once we get into this new dedicated space, it's gonna be pretty amazing. We actually started live streaming our podcast recordings on the Clubhouse app, if you're familiar with that. If not, it's an audio only, I guess, platform called Clubhouse, and it's only for iOS. So it does create some limitations, but if you're on the Clubhouse app, search for myself or the Geoholics and you'll find us. I just created an event for this evening, as a matter of fact, because we record our episodes on Tuesday evenings. So this evening's episode will be recorded live also, or live streaming, I should say, on the Clubhouse app. Post-COVID, we're looking forward to some live appearances. You know, there's a number of state conferences and things like that. Before COVID, you know, we had plans to, you know, attend these conferences and actually, you know, have like live appearances in our Friends of the Program's booths. So we would be recording, you know, from the booth actually and doing some interviews from there, generating some excitement. The Geoholics Open, we're considering a golf outing. Actually, we're going to have a golf outing by the end of the year, and it's going to be the Geoholics Open, which should be a lot of fun. Continue to focus on mass marketing and branding. And, you know, please be sure to like and follow the Geoholics on Facebook and LinkedIn and Instagram. And like I mentioned, please subscribe to our YouTube channel. And last but not least, email us at info@thegeoholics.com if you have any content ideas or suggestions for guests, or if you yourself would like to be a guest on a future show, we would love to hear from you. We're always looking for new and fresh content. And I can tell you this, anybody who's ever been on the show, by the end of the show, they're like, oh my gosh, that was so much fun. You know, when can we do it again? It's addicting in a weird kind of way. So that's about all I have for the Geoholics podcast. If anybody has any questions. Again, I know I blasted through that pretty quickly. I'm from Chicago. I talk really fast.
Thanks a lot, Kent. Hopefully you guys can hear me okay. That's fantastic, man. I really appreciate you coming on and talking about Geoholics. And I was pretty shocked. I mean, I'm a podcast fanatic, and still those statistics were baffling to me.
Yeah,
how many there are.
Yep.
So I think that before we move on, I think we already have a winner. I was being told that we need to announce from the last poll. Is that correct, Emily?
That is right. I have Scott Derby, another $50 gift card winner. And I was told that Ryan Atkinson will be happy to deliver that to you.
Okay, and then any questions for Kent or for Trent before we move on to our lunch break?
I didn't see anything come in, so they must have done an excellent job.
Or they didn't listen to us.
Or they're already at lunch.
That's right, exactly.
All right. Yeah.
Well, everybody, we are a little bit over time, and so we're just going to alter the agenda here just a little bit. It's currently about coming up on 12:30. We're going to reconvene 10 minutes to 1. So it's going to be about a 23-minute or so lunch break. And unless I'm forgetting about something, I think we can go ahead and proceed along those lines.
Sounds great.
Thanks, everybody.
Thank you.
Thank you.
Thank you for being here.
Thanks, Trent.
All right, everybody. Looks like we still have 142 participants on our line here. So we're coming back from lunch. Thank you for sticking with us. Emily, if you can hear me, do you want to do a poll and gift giveaway, or are we good on proceeding to our next presenter?
Let's forge ahead, and then we can do another giveaway at the end of this presentation.
Okay, sounds good. All right, our next person up is Mr. Ben Slater. Ben, are you on the line?
I am, Troy. Thanks.
I see you there. Let me just give you a little intro here. So Ben Slater, who you can see before you there. In 2002, while attending Utah State, I meaning Ben, started working for Jones & Associates Consulting Engineering as an intern. Upon graduation in 2005, he started with Jones & Associates full-time as a field technician, inspector, and surveyor. He has progressed in his surveying career at Jones & Associates and has become a licensed surveyor in 2014. Thanks a lot for being with us, Ben. Ben was one of the first recipients of an R12I in the state and has been using it now for a few months. And so we thought it would be good to just hear from an end user on that technology and just how it's impacted their ability to build a survey. So I'll go ahead and turn it over to you, Ben.
Thanks, Troy. You can see my screen, right?
Yes, sir, we can.
Thank you. Okay, so yes, this is a picture of the day that we received the new equipment, which I was very grateful for at the time. Couple months back, probably November, I think is when we got it. So I'm just going to share a little bit of real world experience that I've had with the R12i, and I'll just get started on that. All right, second. Okay, so just a little background on where I'm coming from. You can see off to the left there, this is where I started with the level rod and tape. Many of you have probably been there, going out and surveying with that. And I still spend some time with that level, and I really actually enjoy using that quite a bit. Then we dove into the GPS thing, and we got the R8 with the TSE3, and I was feeling pretty good, and still is great equipment. And until this just November, when we were able to receive that R12i and the TSC7. And so far, I can say I've really enjoyed it, thoroughly enjoyed the experience I've had with that. I'm mostly just using, well, I'm only using the VRS at this point as well. I'll mention that. So this is what I'm going to kind of focus on and talk about today. And I'll try to be fairly quick. I know we're behind schedule, so I'll try to kind of just run through the things that I enjoy, maybe a couple things that have some limitations still, but mostly the things that I enjoy about the R12i. As you can see, the tilt technology that is in the R12i, have less worry about obstructions and losing satellites, and less user error, holding still, and I'll kind of get into that a little bit further, and the speed of my workflow. So tilt technology, it's been pretty amazing for me. As you can see, on the two canals on either side, I was able to go out and survey this canal. The one on the left, I actually surveyed a while back with the R8, and I was in the middle of the canal. I was with my waders, just going down through this canal, kind of taking some cross sections of the canal. And on the right, as right after I got the R12i, and I was doing a survey on that one on the right, and I was able to, I just had my muck boots on, and I'd get into the canal a little bit, but I could just tilt the rod over into the bank and get the toe of that bank and get a good shot on it, and also stay out of the brush as well. And so I use the tilt quite a bit. I could kind of find where I could stand in the canal where I wasn't overflowing my muck boots and getting my feet all wet. But it came in handy. I probably should have taken my waders, but I didn't have them, and it just made it that much easier that I could just do it without the waders. And so it came in handy a lot there. I know a lot of times I'm shooting the fence line, and I like getting right up next to the fence and right underneath the fence, and I'll just shove it right underneath the fence and get that straight line underneath it, instead of being a little ways away from it where I had to stand a little bit away from the fence and hold that rod straight up and down. And that's helped me out a lot. There was an experience I was up surveying Pleasant View City, and they needed a shot on a PRV. So we pulled the manhole cover off the PRV for water line, and the PRV was just over a little ways from the hole, the manhole, and I was able to just stick the rod right down there and get right on top of the PRV itself, so I could get an elevation right on that water line and where the PRV was, and that's super handy. I didn't have to get down in there and measure, do a couple measurements to get to that PRV itself, which was critical at the time of what I needed, and it was great to get right on top of that. Another thing, you can see the picture in the middle. That's not me. I actually just grabbed that from the internet. But I've had this experience where I've had to get a shot where a car's parked, or I've had a dump truck sitting on top of a point I needed to get, or a loader. All three of those things I've had, and I was able to do exactly what you see there, and I was able to get the point that I needed. And that came in super handy. I didn't have to go track down the guy that was in the truck or the loader, and I was able to get that shot. One thing that I had as well, one experience was I was up surveying a pretty busy road, and I was trying to get cross sections along the road, more topo shots, and I was able to stay out of the travel lanes a little bit better with the tilt technology. I was able to get on the white line or the edge of oil and kind of stand off to the side a little bit and not worry so much about where the cars were. And that was handy for me. Also, you see the bottom picture there, the guy right here. That I've actually done that quite often, where I'm trying to get a flow line of a storm drain coming out of an outfall pipe or something, and I got to get a good flow line on it, and you can't really do it just being straight up and down. And it's just great to just shove the rod down in there and get on the flow line and measure that point, and that's come in handy for me. Something I'd love to try out, I haven't tried out yet, is the continuous topo on this one, because I think it'd be a lot more accurate, a lot more precise, and just having just holding it or putting it on the back of a four-wheeler or a backpack or something, where I could run up and down a trail or a road or whatever and run that continuous topo. I think with the tilt technology, it'd just take care of the imperfections that you'd have with it. The other great thing is stakeout. I haven't done a ton yet, but I've done a little bit of stakeout, and I love being able to come up to a point and not having to look at the bottom of my rod, get it on a point, plumb it all up, get my bubble all right, and take a look at it and go, okay, I need to go, half a foot this way, half a foot that way, and then move. Right now, I can just stick the point down in there. I'm looking at my screen. I get the screen all set and where I need to go, and just move it a little bit, and it's really quick. It's helped the speed of staking out immensely. Let me go down to obstructions, less obstructions that I've found. The picture in the middle I want to talk about just a little bit. So this was a construction job. We were running a new drain line next to a new retaining wall. And I had to stake this out after the retaining wall was put in, obviously. And I was using the R8 at this time. And if you can kind of see real close down here, there's a stake. That was my stake that I gave an offset for this manhole. And I could not get that for the life of me. That I couldn't get, initialization was lost all the time. I couldn't get satellites down there with the R8 just because of minor trees on the left. But that wall was killing me. And I know now with the time I've spent with the R12i that would be no problem. I'd actually probably be able to get right up in here, get these shots. I was able to get that after I occupied it for a while. It took quite some time to get that point, but I know I'd be able to get that. Fairly confident in it with the way I've been using it the last few months, that I would be able to get anything up along that retaining wall. Over here on the left, actually I do a lot of as-built topo shots or for GIS type things. And this is a new sewer line and a land drain line going in. And I shoot the tops of the Ys to kind of give us a location on where the lateral is coming into the main. And some of the trenches get pretty deep and pretty steep. This one has been no problem for me. I know back with the R8, I would have had issues getting down in there. I would have lost my base station. I would have lost my initialization. Satellites would have been low. But with the R12i, no problems with that one. And I'll come back to that one in a bit. The other one, if you see where, getting building corners, it's way easy. Super easy with the R12i. About where the cone's sitting, I've occupied that real quick, easy, took the shot, was able to get the shot, no problems. The other ones, like as you can see there, with the tilt function as well, you can get out underneath the eave of that Bowery and get the shot without any problems there. This shot right here, I actually had some issues, I'll explain later, but was also able to get some shots even with overhang of a building, and then also with that big pine tree that's right there. I was able to get this point. I was shooting concrete for as-builts and measurements for paying the contractor. But I was able to shoot this point down here, this point right here, and this point back here. But when I went back in here underneath that pine tree, I couldn't get the 2 last points. But I was able to do some measurements and I was able to get those no problem. But that was one of the limitations I'll talk about. But I was able to get pretty close where I know with old equipment I wouldn't have been able to do. So that was helpful. All right, so the next part that I'm going to talk about is less user error. So sometimes with those as-built drawings or surveys that I do for pipes going in, I'll survey this. This is a water line loop going underneath for a storm drain line coming in. And sometimes in the past I've handed, well, I still do, I'll hand the rod down with the receiver on top and hold the data collector and ask the guy in the trench to get the shot for me. And I kind of have to train them a little bit and tell them to make sure they look at the bubble, make sure they're inside that bubble and see if they can get that shot. Now it's way easier. I can just throw it in there and just say, okay, put it on top of that point, that point, and that point, and that point, and they'll get those shots, no problem. And it's without really any error on those. Also, with it, if you see kind of where he's standing, if you can't really get up on top of the pipe behind him, you stick the pipe, the rod up on top and you can't see the bubble at all. And back when I had the old equipment, I'd have to try to stand up on the pipe or try to get into a place where I could see that bubble or just guess and hope I'm straight up and down. But now I can just get on top of it without even being able to see the bubble and be able to shoot that shot. I also put a picture of me because I'm probably the biggest error in most things. So there's a picture of me when I was surveying that canal with my waders on and had the R8 and the TSE3 and shooting that canal. But I know that even even me, I create my own error when I'm walking along and I don't get things straight up and down. My bubble's off a little bit, or I move, and I have excess movement, and I can't store that point, and I have to get back out of it and reshoot that point, and there's no longer that error because I don't have to worry about looking at that bubble every shot. I can look at the screen, I can look at my precisions that are going on in the screen and go right up to the point, get the point stored without even really looking at the bubble. Now I know originally when Troy brought it out and the equipment out and was getting us all set up, and he was kind of showing the tilt function, the tilt feature, and said, well, you probably won't have to look at the bubble very much. And I didn't believe him. I'm like, I'll still probably look at the bubble. But it took me about 2 or 3 shots to realize, no, I really don't need to look at that bubble. And it was my workflow time, the speed of workflow is just increased tremendously. It's amazing how much time it took to kind of look down at that bubble and realize how, that I got to be straight up and down for this shot to get a good shot. And I don't really have to do that anymore. All right, next one. So speed of workflow is my next real big thing with the R12i. If you can see these shots, they're kind of screenshots from an AutoCAD job I'm doing. Part of it's, I've showed you some pictures of where I was out measuring the concrete that was replaced. This was a water line that was replaced up in Job Corps in Weber, or South Weber. And so they had to replace a bunch of concrete, and our measurements weren't coming out right with the contractor measuring and what we felt was measured in the field. And so we're like, well, let's just all get together and we'll go out there and shoot everything. I'll shoot every little spot where it jogs in and jogs out, and we'll shoot the concrete that was replaced so that we can pay them accordingly. So if you see the points in here, you'll see that there was about 1,000 points I took that day, and it took us about 3 hours to shoot all of that, walking through and shooting every little spot where it went in and out. And with 1,000 points, I would have been at least another couple hours with the old machine. I know that on a good day, I was usually putting in 100 to 150 points an hour, if it's real easy going. And so to get about 1,000 points in 3 hours was impressive for me. I liked it, and I was able to get on to other things and not spend the whole day doing those measurements. So that really helped out my workflow. The other thing is that just something that I didn't really realize is I was spending a lot of time with the R8 searching for satellites or losing initialization. I'd tilt the rod at all, or put it down a little bit to get underneath something or whatever, and it would start searching for satellites again and lose the initialization. And I just really, I haven't lost that. I haven't lost initialization. I think one time that I lost, and I'll explain that, but it's just way faster to be able to work through this because it's not trying to search for these satellites all the time, and I feel the precision is just right on with where I was at before anyways, or better. Powering up the equipment is faster for me. It seems to log on quicker. The TSC7 is great for that. The R12i is just hooked up immediately. I used to have to occupy a point for about 6 seconds. Now I'm down to about 2 seconds with the same precisions, and I don't have to look at that bubble. So I just get up to a point and push the measure button, and it's measuring and going. So that moves me through a lot faster. Also, just another thing is just the ease of, I know I'm not talking about the TSC7, but I'll give a little plug for it, that it's way nice to work with. And I can just email myself my points right after I'm done with the job and come back into the office and get it going in AutoCAD and everything else. And it's super fast and super easy. So I'll get into some limitations here real quick. Not a lot of limitations that I've run into so far. Again, I've only had it for a couple months, but I think Troy was talking about this a little bit with the pine trees, that he was still having a little bit of issues underneath those. And that's kind of my experience as well, that I have a harder time with that thick tree cover. I think if I was a little bit more patient and sat on a point for maybe a little bit longer, maybe I could get those points a little bit better. But overall, trees have not been a problem for me. I've been able to walk right up to trees and shoot them, you know, that without the leaves, especially without the leaves on right now, I can go right up to a point and shoot it, or tree and shoot it. Whereas before I'd have to get an offset to that tree and shoot a point and have an offset, and that's how I would locate it. Now I can go right up to it and shoot it. The other one is back to this building and the tree. I had the issue with a couple of points there that I just was not able to get. This trench that you see here, I'm able to shoot just fine, but I was in a trench that was probably 12 to 15 feet deep, and it was narrow, really narrow. And I lost service, and I couldn't get the point. And I actually had to get up on top of the bank, or actually out a little ways. I went to where they had a lateral and got out a little ways out of the trench, and I was able to get service, but it took me a few minutes. It took a few minutes to finally sink back into where I was at, see me. The satellites came back in, and I was able to go back down the trench after I got satellites. I was able to go back down and I got them. I was able to get those points anyway. So I can see, well, if you've got a really tight area, you might not be able to get it as well, or get the precisions you maybe need, or even be able to collect that point. But really, those have been my limitations so far. I'll see a little bit more as leaves get on the trees. I'm excited to see if I can still see through the trees, because they claim they can. I've watched some YouTube videos that show that they can, but I'm excited. I'm glad I have the equipment. It's made my life that much easier. I thought maybe I'd go back and use the R8 sometimes in certain circumstances, and as soon as I started using this, I turned that R8 over to our GIS department and said, you guys just use it, whatever you need, it's yours, or I've got another inspector in the office that takes it out sometimes as well. But I don't think I'll ever go back to the R8. I am on the R12i bandwagon, and I'm excited for it. So that's all I have. Sorry, I was kind of rushing. I know we're behind. I'm trying to get through it quick, but that's about all I have. If there's questions, wherever you need to go, Troy.
Thanks for that, Ben. No, that was great. I appreciate you picking up the speed there, and appreciate your real world experience there with using that unit. We're super excited about them, and they're doing stuff that receivers have never done before. So we're super excited about the technology there. Thank you so much, though, for presenting today. All right, let's go ahead and do our poll question on the R12i. Emily, if you can hear me. This is a question directly related to what you could use with that tilt technology. Okay, I think we've given them enough time to answer there, Em.
Just a little longer there. We can move on while they're still answering, and then.
Yeah, that's a good idea. Let's go ahead and move on to the Point Man subsurface utility locating system with Ben Scogan. Ben, are you on the line with us?
Sure am. Can you hear me?
Yeah. Let's go ahead and let me introduce you really quick, and then we'll get our winner of the last poll, and then we'll go ahead and turn it over to you. All right, so for Ben, let's see here. Ben is responsible for product planning and execution throughout the PointMan product lifecycle, including gathering and prioritizing product and customer requirement, defining the product vision, and working closely with engineering, sales, marketing, and support to ensure revenue and customer satisfaction goals are met. Ben is also responsible for ensuring that the PointMan product supports the company's overall strategy and goals. Ben has been with ProStar for over 5 years, but prior to his position as a product manager, he served in the United States Air Force as an A-10C Thunderbolt II avionics technician. Ben has a bachelor's degree in computer science and is a certified product manager and is currently working as a professional land surveyor's license in the state of Colorado. So Ben, thanks for being with us to talk to us about this cool new platform, PointMan. I'll go ahead. Oh, actually, Emily, do we have a winner real quick?
I have a winner. I have Gino Ferrero. If you can send me where you'd like me to send this $50 gift card for you, I'll do it today.
Cool. Gino's one of my favorite surveyors, Rock Springs, Wyoming, representing their JFC. Okay, Ben, it's all yours.
All right. Yeah, thanks, Troy. And let me pull up my screen here. Appreciate the introduction. Yeah, so my name is Ben Scogan. I'll just go into my slides here real quick. We'll be talking about PointMan today, and specifically subsurface utility engineering, locating subsurface utilities and mapping them in an accurate way. So part of the work that I've been doing for ProStar is working with Trimble over the last 2 years or so to make sure that not only are the GNSS receivers supported in our software, but also the correction services such as VRS Now, RTX, and so I've been working very closely with not only Trimble corporately, but the dealers. And so we've had conversations with Monsen and several others. And so what we'll be talking about today is how PointMan addresses the issue of subsurface utilities and kind of where we fit in that industry. So there's 35 million miles of underground pipelines and utilities in the US. And that's as of 2019. Of those 35 million miles, 2 million miles of roads. So it's underneath 2 million miles of roads for that much congestion. You can kind of get a picture for that. And as a result of not having, good records or maybe even readily available GPS units at the time when the majority of these utilities were installed across the country, poor records, the location of these utilities wasn't documented in the way that would be useful to us nowadays. And so that's part of the reason why there are over 500,000 line strikes every year in the US alone. That equates to about 1 every minute of every working day. So because this has become an issue, and recently the US government has begun the proceedings to introduce a stimulus package for infrastructure. And 100% of the construction projects in the US are required by law to identify the location of those underground assets before digging occurs. And $10 billion is spent annually to locate those utilities. Even though we spend $10 billion to locate utilities, we still end up spending or have an impact of about 30 billion a year from hitting those lines. That's not only cost monetary, but delays for time, insurance issues, injuries, God forbid. Just had one in Texas where the gas line got hit, and so this is a real issue. And as we continue to expand, we're going to need a good system and way of recording accurately where these positions are. And one of the first states to really initiate this was Colorado. January 15th, they changed their code at CDOT to mandate our software. And when I go through these slides, it'll start to make sense why they chose to do that. So at ProStar, we focus on DOT, 811, rail, the location services, construction, oil and gas, surveying. Really, it all ties in together. And that's how Colorado DOT is using the system as kind of a one-stop shop together in partnership with Colorado 811. This is just the first state to do this, and it's only been about 2 months, 2.5 months since that mandate went out. So a lot of other states are kind of watching this. It's pretty new, but so far it's going very well. And I'm happy to say that there's several hundred contractors collecting live accurate data into their point man system. So the issue is these old records. And part of the reason why SUE is so expensive is because they're starting with poor records. A lot of these were either paper records, didn't have a quality level because that standard wasn't out yet. They're just simply not accurate, and there's no confidence to a lot of that data. Even if a utility was installed, even if there was an as-built drawing prepared, the installation of that utility doesn't always match exactly due to unforeseen circumstances in the field, whether it's existing utilities that they may need to go around or what have you, utilities that just weren't in the record at all. And so Point Man is out to fix this by accurately mapping the underground. So current methods, we see a lot of, the locators going out and spraying paint on the ground. So the problem is that nothing is being recorded digitally when this happens. There's also not a second person there, like a surveyor, who is able to work with that locator to determine how accurate that should be. Even if a user is trained on those pipe locators, there can still be issues with sending a surveyor out a second time or on a second trip to survey those paint marks in. And it's quite obvious that it's not working very well because those line strikes are still happening. And so what Point Man is doing is, instead of having 2 trips where the locator goes out and then the surveyor comes out after them, because I think the main issue is for the majority, and I don't want to overgeneralize here, but contract utility locators don't necessarily understand coordinate systems, and surveyors don't necessarily understand or want to add utility designating into their workflow. So we have this bit of a disconnect here. So this is why we need verification, and verification comes in the form of test holing. So this brings in that level of confidence where the utility locator says this line is, they can verify it, but it also costs more money. It costs more time. It costs more people to be involved and more liabilities, more insurance goes up. And so we have this current system of bringing, the locator out on site to locate utilities. The marks get surveyed after the fact and then manually uploaded to a computer, where that data is then reviewed and then imported over to the backend GIS system. Because remember, during these projects, GIS and survey don't typically talk together, or at least they haven't in the past. And then that data needs to be disseminated and shared with the rest of the team, from the guy who's running the backhoe to the guy or the excavator to the subsurface utility engineer to the project manager to more surveyors to the engineer. I mean, it becomes a manual process, as you can see, and there's many stages along the way where you can get slowdowns in the process. So what Point Man does is combine the GPS and locator together with the mobile app to collect the data in the field and push it up real time to a cloud system in the office, which is that cloud system in picture number 2 is actually connected to your backend GIS. So if you have CAD, Esri, Bentley, Point Man actually connects to that in real time. And so when you collect data from the field, that review process can happen while the surveyor is out in the field, because the system has real-time notifications built in as well. So if something doesn't look right, someone in the office can send it back, say, hey, this depth was way off out of the rest of them, or maybe this one didn't have an amplifier hooked up. Those things can happen while the user's still in the field without having to make trips back and forth from the office. And then that data comes in and auto publishes back into the backend GIS system. This means that anybody that has a tablet that is logged into that project gets that data in real time as it's collected. That's coming off of your GPS, and we support the entire line of Trimble GNSS receivers. We also support all the major pipe locators on the market. So, and I'll explain how easy it is to actually collect the data. And this runs just on Android or iOS. We have Windows coming out later in the year, but the guy in the excavator has a tablet, and he's seeing this data come in real time as he's sitting in the seat before he breaks ground and digs. So this software is really designed to start from the initial field sketch stage, where instead of just sketching this in a sort of manual way, you're actually using the geospatial data pulled off the GPS and the pipe locator to create the field sketch, which that means you're starting with better data. You're starting with it in real time. Everybody across the whole, all the different teams on that project have access to this in real time. And so that's really the difference. And how PointMan actually works, there is a very simple workflow to do this. It's called one and done, one button data collection. So really all you need to do is pair the pipe locator in the GPS and then trigger a depth. When you trigger a depth on a pipe, it captures all of that information off the pipe locator. It also triggers a GPS measurement and sends all of that into that point and pins that on the map. As you can see, there's a water line here that was collected using a Trimble GPS and a Vivax pipe locator. So as I walked and I collected this line myself, I went through and just triggered depths along this line. And as I collected each point, it was already in the office. Someone was able to look at that as I was collecting. They could see exactly where I was, that I was getting the work done. And it was just a very smooth process. I collected an entire neighborhood of for sewer utility improvement district in probably an hour, just tracing everything that was out there. And so, as I mentioned, this is built for utilities. This is not a replacement for Trimble Access. This is specifically built and patented for subsurface utilities. It is the hybrid between GIS and survey, so that those teams talk together. And not only do they talk together in real time. You can pair your GPS and pipe locator simultaneously. If you don't use one of these items, it's fine. You can just use a GPS, for example, and tap to collect it on the map on the app if you don't need depths. You can just take surface shots. And it does support N-trip connections, Trimble corrections hub, geoid models, and you can reproject on the fly to different coordinate systems. So we support all the quite a few of the major geoid models, both for the US, Canada, and Australia now, that we just added. We stream one-call tickets live into PointMan. So you can actually request a new ticket just the way you normally do through email. And when you get that email back from the one-call center, it automatically puts that into PointMan as a ticket, showing on the map as a polygon with a color code based on priority and all of the attributes associated to that ticket. So you can actually work against that one-call ticket and then push it back to the 811 center right from PointMan. So that's a game changer right there. As I mentioned, it works with MicroStation, CAD, and Esri backends. So it's called an integration, and you can hook that up with PointMan Pro and get data streaming in live, consuming into PointMan. Legacy line work, if you need it as a reference in the field and you need to work with it and then push it back the other way once you make updates, you can do that. It's a real-time connection for field to office, but the mobile app does have the ability to go offline. So if you're going to work somewhere without cell service, you just tap the go offline button in the menu and everything you capture will be captured to that tablet. When you get back into the office, it's the button then says go online. So once you go online, there's no upload, it just automatically syncs with your system. This is a very easy to use app, very simple to train. For about 4 years of the 5 that I've been here, I've been doing field training sessions. Anyone from small contract locating companies all the way up to the Kiewits of the world on massive $5 or $6 billion projects, huge projects. I can train those users before lunch. They're up and running, they're comfortable, they understand it, and they're able to just pair their stuff via Bluetooth and just go to town collecting data. And when I say getting things set up, we also support site calibration. So you can actually collect your local grid coordinates and ground coordinates to match what your survey data collectors have. And we'll even take it a step further that we're working on a connection to Trimble Access right now to where PointMan can work seamlessly with it. This is also an easy deliverable. So 2 ways to do the deliverable. You can manually send it out, and I'll pull up the file types that we support here in a minute. Or you can set the auto export to go straight into your client's backend, or send it to them via an email automatically as features get added in a specific coordinate system with specific units of measure. All of that is supported in the system. So all you need to do this is a mobile device, a locate tool, optional, and a precision GPS. So we do support the Trimble Precision SDK, which means we support all of the native connection for all the GNSS receivers. That's the entire R series lineup, the SPS line, the Spectra Precision line, and the Catalyst DA1 and DA2. The locate tools, which I'll show here in a bit, we support right here, the radio detection, Vivax, and subsite. And soon we are adding the Vivax RTK Pro. As far as the GNSS receivers, you can see them here. There's a few extras in there besides Trimble that we support, but I wanted to just focus on Trimble. We do support quite a few other ones though. We support our own native built-in NTRIP corrections, and then VRS Now as well if you're subscribed to it through Trimble. You can run base and rover as well and just Bluetooth pair to the rover. So very simple there. If you set up your base like you normally used to in Access, I tell people just take your data collector off the pole, put PointMan with the tablet on the pole, and use your data collector to set up your base rover, and then just use PointMan to pair to the rover. And then you're offline getting those base rover corrections. Centerpoint RTX is also supported. So all of that is in there, and that includes, we've done extensive testing with the horizontal time-dependent positioning epoch datum shift, and that has been corrected as well. So you actually have the option to choose if you want to use the ITRF 2014 reference frame or not, and if you want to use the most current epoch or not. You can choose to do all of that in there. So as I mentioned, the manual export includes CSV, shapefile, KML, KMZ, and DWG formats. You also get the photos, and if you have forms in the system, which we do support PDF forms, you can export PDFs as well. Real-time integration, as far as Esri, Autodesk, and Bentley, we support WMS and WFS connections, OAuth 2, and token-based authentication, so you can actually log into your system from PointMan and stream that data in, whichever data sets that you want to use. So I kind of breezed through it a little bit since I know we've changed the schedule a little bit today, but I imagine there might be a couple questions, so we can open it up for that. Again, this is Android and iOS with the Windows platform being released later in the year, so expect it to run on your TSC7s, things like that. And then, yeah, so at the R12i we just went through with Ben. We support the tip and tilt functionality. So out of the box, it just works with a Bluetooth connection. So for your utility workflows and locating things, PointMan fits in that niche very well. Now for general, traditional Trimble Access survey, then you still want to use Access, but there are things that we've added to PointMan to make your utility data collection more accurate to match what you need it to be. So.
Thanks, Ben. Appreciate that. So you said it was Android compatible. And so theoretically, you could install that on like one of the new TSC5s Even though
Yes.
it had access on there, you could still install Point Man on that same collector.
You can, yeah. So you could switch between the two on a TSC5. So and if anybody has questions, my email is posted there at the bottom of the screen, and I'd be happy to do, like maybe an actual live demo over a webinar or anything like that if you want to see it collecting. I did a test this morning using RTX, so completely offline, and I was able to get about 500s by 900s using RTX right in Point Man with an R2. So worked very well. So yeah, I appreciate the chance to speak, and hopefully I can do some follow-ups with everybody.
And we did have one question come in through the chat. It says, does each individual in the office need their own license for the Point Man software?
So good question. So Point Man exists as two different levels, Point Man Plus and Point Man Pro. Point Man Plus is on my TDC 600 here. This is just the mobile device. It doesn't have a cloud. This is a per user purchase, and you can actually get it at Trimble dealers. For Point Man Pro, it's also a seat license, but it's a floating seat license, so you can reassign it to people, but only one person can concurrently be using it at one time. So that one is a more increased price point, but you get a lot of value in that Point Man Pro dashboard. I will say that there's a full seat and a viewing only seat, and the viewing only seat is substantially cheaper versus your field data collector or your office admin who's doing work, or your CAD tech who's moving data back and forth. So.
Okay, that makes sense.
So you can actually get Point Man on the Android and Apple stores for free. So if you want to download it today, feel free to look up Point Man, and you'll get a 15-day free full trial. We can always meet with you during that trial time and extend it out if you need more time to try it out.
Okay. Any other questions, Emily? Well, we got Ben going here.
That was all that came through.
Okay, that's some pretty exciting utility location capabilities. And so I appreciate you sharing that with us today, Ben.
Yeah, thank you.
All right, let's go ahead and do our next poll question. And while you're answering that poll question about utilities, let's go ahead and move on to our next presenter, which is going to be Mr. Pete Mestemaker with Trimble. He's our Trimble rep. Pete, are you on the line? I see Pete there. There he is.
Troy, so I am. Actually, Eric's going to go first and talk about the TSC5, and then I'll do the SX12 after.
Okay, so Eric, you're there as well, I assume?
I am. Can you hear me?
Yes. All right, let me just introduce you a little bit here, Eric, and then we'll find out who won our poll, okay? So Eric has been involved with product development, product management, marketing, and the portfolio management at Trimble for over 28 years. He served with TDS, Tripod Data Systems, and transitioned to Trimble in 1990 when TDS was acquired. His key products over the years have been Survey Pro, Survey Link, the original TDS Ranger, the TDS Recon, Spectra Epic receivers, and now the TSC5. So it's good to have you on on board, Eric. It brings back some memories. The TDS acquirement. I didn't realize it was so long ago.
No, it was 2000. So I don't know if I typed the date wrong on there or what, but yeah, it's 2000 is what the correct date is.
This was really misremembering that.
Yeah.
All right, Eric, I think you are. Oh, actually, Emily, do you have a winner for us?
You're rushing me, but yes, I have a winner, Keith Bigelow. Congratulations, you're the proud owner of a $50 gift card.
Nice job.
There's clapping and cheering on our end. You just
Yeah, we're freaking out over here, Keith.
If you'll send me where you'd like me to mail that to you, I'll get it going.
Awesome. Okay, Eric, I'll go ahead and turn that over to you. It's all yours, my friend.
Okay, I am sharing my slides. Hopefully everybody can see those okay. Yes?
Yep, I can see you good there.
Okay, just double checking. Never can tell. All right, so yeah, like you said, I'm Eric Hall. I'm here today to talk to you about this is a new update for you. Of course, it's no surprise because we've already talked about it quite a bit. Is the Trimble TSC5. This slide deck was what we used to introduce the product to the world, so to speak. And I worked with Connie Culligan here at Trimble to develop this product along with the entire team. So we're really, really proud today to be able to announce this new product, and I'm really thankful to Monsen for the opportunity to come and talk to you all about what we have to offer you. So there it is. That's the Trimble TSC5, and I'm going to go into some detail about it. But I kind of want to talk a little bit about how we got there, or how we got here to this current TSC5. So, some of you may remember, yeah, I do, but back in 1992, Trimble brought out the original TDC1, and that was really paired up with the Trimble 4000 RTK system. An RTK receiver system isn't a whole lot of good without a good controller to go with it. And so Survey Controller was the software, and we had the TDC1 that really drove that mobile RTK market. Then in 1995, the Husky FS2 came out, and Trimble rebranded that into the TDC2. A lot of you probably remember that. It's a fully aluminum magnesium case on it, full military ruggedness, and it really first introduced that hourglass shape hammerhead style device that we're also familiar with today. Then in 97, Trimble went back to manufacturing their own devices, and we created the TSC1. That's the first TSC unit ever to come out, and it had that iconic Trimble spider key, we call it, in the middle there, that allows for that directional control, and had all those extra enter buttons and such on it that made controlling the software from the keyboard really easy. You also notice the wide space keys, and then again that hourglass shape. And then in 2000, like we mentioned, Trimble purchased Tripod Data Systems, and that's when I came over to Trimble. And we had developed the original Ranger, we call it, and so Trimble turned that into the TSCE, and that's the first Windows CE Microsoft Windows OS data collector that was provided to the land survey market. It's also the first touchscreen that was ever developed for the land survey and the rugged market altogether. And then eventually we came out with a color screen with that device, which is another first. From there, we just refined the system, made it better. We came out with the TSC2 in 2005, and it reincorporated that Trimble spider key back into place on it. They had arrow keys on the TSCE, but not the spider key. And we added Bluetooth capability to the device at that point, making easier connections up to your devices without cables. Again, further refining the device, we came out with the much loved Trimble TSC3 in 2011. So we added the internal GSM modems capability to the device at that point. We added a bigger screen. We upgraded the OS, but we kept all of the other iconic things that we love so much about Trimble TSC units: the spider key, the hourglass shape, and the ruggedness that everybody loves. And in about 2016, we decided that we needed to take a big push. We needed to make a game changer in the data collection market. And we want to provide something extremely powerful. We knew we had sensors coming out that were going to require a large amount of computing capability. So we designed the TSC7. Matthias Rohring was the main product manager on that here at Trimble. And he did a great job of fighting through all the resistance to produce a very powerful device. The large 7-inch screen, big keyboard, plenty of battery capability. And the biggest thing is it has the processing power that you need. It's a fully Windows 10 Pro operating system. It is a PC walking around in the field with you. But we also understood when we made that there's a lot of TSC3 customers that like the size and the weight, and we realized that TSC7 may not be for those customers. So we decided, even as we were designing the TSC7, that we were going to need the TSC5. So that's where the TSC5 comes from. For those of you wondering, for the screens bigger than 7 inches, we'll typically go with Windows 10. And for screens smaller than 7 inches, we'll typically go with Android now. Android just fits better on the smaller screens, whereas the Windows 10 doesn't scale nearly as nicely. So what did we design into the Trimble TSC5? So we paid attention to certain things that were what we thought to be critical for the device, and the most important things. The first was the keyboard. And I'll go into some detail about all these things. Keyboard obviously is the primary reason for having the TSC, right? It's what makes it a TSC. Size and weight. We recognize that those are two critical factors for pretty much every surveyor. Needs to be able to do the job, but the lighter we can make it is always the best. Battery life is obviously critical, and then also ease in battery management, right? So nobody wants to be thinking about batteries all the time. So we wanted to do something that was simple and easy to use. Then obviously we wanted a screen that was viewable in all different types of conditions, with glare being a primary factor, but also being able to, obviously screen viewability is paramount. Reliability. When we do surveys of all you folks out there that use our products, and we ask you what's the most important factor of your survey controllers, reliability is always at or near the top of the list. So reliability is absolutely critical. So we have to make these things rugged. We have to make them survive out in the environment. And then also we did want to go to that modern OS. So this is our first survey controller that uses Android. So the modern OS gives us a lot of different advantages, and it gives you guys a lot of different advantages as well. So quick overview of a few components. Don't let all the numbers scare you too much. Don't try to read them all. It's in the quick start guide and the manual as well. But I just wanted to point out a couple of components I'm not going to talk much about the rest of the time. Down here, items 11. Those are just speaker holes. There's actually only one speaker with sound pipes to go to either side to give you nice loud speaker results. At the top here, we have 2 lanyard slots. So this is where you can tie your lanyard in for your stylus, which mounts here in this port here in the back. Here's the camera and the flash, which can be used as a flashlight on the back of the unit as well. There's 2 mount points for your pole bracket that go here and here. And there's a USB-C port down below, and I'll talk a little bit more about that USB-C port later on. So the keyboard is absolutely critical to making a good device. So we focused in on making large, well-spaced buttons. When we talked to you all about what you wanted in a keyboard, we have a lot of people that are still using the ABC style keyboards. And we talked to them about that. It's really, most people, it wasn't the layout of the ABC keys that they preferred. It was the bigger buttons with the wider spacing between the keys that they preferred compared to the QWERTY. Most people are very comfortable with the QWERTY keyboard now because of smartphones and all that. So we wanted to go with QWERTY for the layout, but we wanted those bigger buttons with the wider space keys. So that was a primary key for us for developing this keyboard. And then the tactile feel was really, really important for us as well. So when you press that button, you need to know you actually pressed it. So we have metal snap domes underneath this keyboard layers here. So when you push the button, you do feel a very solid snap. When you push it, you can tell that you've actually depressed the button all the way. You can even tell when you're wearing thick gloves that you've actually pressed the button all the way down and it bounced back, letting you know that it worked. You can even hear that clunk when you do it. But we also had to balance that about not making it too heavy, right? We didn't make that keyboard press so heavy that you're wobbling everything as you press the buttons. So I think we found a really nice balance there with that. We also use an international keyboard layout, which most of you aren't going to be interested in because you don't use those special letters and stuff. But the cool thing about that is they won't get in your way if you're just using English. We did add the Android navigation keys across the top. That's the back key, which is fairly obvious. It takes you back to the previous thing. The home key will open you up onto your main home page with all your icons on it. And then the overview key will open up a listing of all the programs you currently have open, and you can select through them. So those are normally found on your Android touchscreen. But since we don't want you having to touch the screen unless you really need to or want to, we added those actual physical buttons for Android. The keyboard is backlit, so it can be automatic. You can have the system manage it for you. It gets dim enough. The light sensor will pick that up and turn the backlight on for you, or you can manually set how bright you want it and so forth. So if you're working in dim conditions or you're working in mine or something like that, or a tunnel, you can go ahead and turn that backlight on. It makes it a lot easier to use. It does have the iconic Trimble spider key at the top. It's shaped a little bit differently than it was before, but it has the forward tab key, back tab key, the extra enter keys, and the arrow keys all built in. And so that's obviously designed to work with access and access with it, right? So it's all seamlessly working together. They're all 12 full function keys. You can see the first 6 up here next to the spider key, and the next batch is down here above the regular keyboard. And those are all programmable within access. So you can do things like add it to your camera, add a camera the camera activation to it, or measure codes function, or whatever function you want to be able to jump to, you can add those to those function keys. There's a ton of them. You can line this up with a ton of different features. I did want to mention the power key LED real quick. I don't know how often you guys have pushed a power button on a device like this and you waited, did it turn on or not? You don't really know. So you wait and you wait and you find, decide, I didn't turn on. So you push a button again and just then it comes on and you turn it right back off again. So we wanted to avoid that frustration with this. So even when this unit's in a full powered down state, when you push that power button, within a half second, you'll see that light come on every single time. And if the unit's just in sleep mode and you push that button, the light will come on immediately. So you know you've actually pushed that button, and that's just saves frustration. Size and weight. We always knew that size and weight was going to be critical on this device. We wanted to make sure we kept it light, and we did. We kept it actually lighter than the TSC3 with the standard batteries. So lighter is always easier to carry. It's easier on your shoulders. It reduces strain. It makes the day go easier. And so we really focused on trying to keep the weight off. So we were able to do that. We kept it below the TSC3 weight by 70 grams, which is not a huge amount, but still, it's lighter than the TSC3. We wanted to keep it smaller. Well, we're not completely smaller. It's a tad taller and it's a tad wider at the screen, but not nearly as much as you might think. And then it's quite a bit smaller down below. So we worked really hard on this thin neck on this device. We wanted to make it very grippable, very easy to hold, very easy for your thumb to reach the arrow keys and the function keys up there in that neck area. So we worked really hard on making that really narrow, which is a big change from what we previously had. So it's very grippable, very easy to hold, especially with that hand strap in place. It also is ergonomically grippable. I'll show it to you in a second, but on the back, it's contoured, so it's easy to hold on to. So here we have the back, and then here's the grips that I was talking about right here. It enables you just to grip it and cup it from behind. You can even grip it with two hands and do thumb typing if you want to type a whole lot of stuff, or you can just grip it like that from down below, and your thumb can still easily reach the spider keys and such. That is where the batteries are at. They're in these two molds right here. They are integrated batteries or sealed batteries inside the unit. They are not user removable in the field. They are service removable, of course. The good news about these batteries is that they will last 16 to 18 hours of production time for you. Now, what we're talking about here is just not on time and maybe punching a few buttons time. This is actually using the radios. So like the Empower module, EM120 radio for your robot. So using that robot radio continually for 16 hours is what this device can do. So it'll get you through more than a full day. And it'll be 18 hours using the RTK profile streaming corrections via your WAN module. After 2 years, these batteries will have a capacity of 80% still. So that gives you still more than a full day's worth of actual working time, even after 2 years with these batteries. We do have an optional removable battery coming, though. We wanted the best of both worlds for this device. So the sealed batteries allow us to keep the device lightweight and smaller while still packing in a lot of battery power. But then we also wanted to provide an optional removable battery for you. So the removable battery will double the usable time. So you go from 16 to 32 hours, for example, with this device with that internal battery. And we wanted to do that for a couple of reasons. The first was for confidence, right? You show up at the job site, I forgot to plug the device in last night, or I did plug it in and my kids unplugged it to plug in their gamepad of some sort or whatever. Right. So now your device is in charge. What am I going to do? Well, it's nice to have this removable battery to be able to plop into the device and go ahead and go. The second thing is for people working in extreme cold environments and that kind of thing. This extra battery will give you full day's worth of work, even in the most extreme cold temperatures. There's 4 screws. It's underneath this latch here. With those screws, you just pull that cover off, which is also where the SIM card is stored at. The bay for the SIM card is down there. You just pull those 4 screws off, plop the battery in, close it back up again, and it'll go. Like I said, the battery's coming out later this year. There's a lot of neat features with it too. It's a USB chargeable all by itself, or you can use the current Trimble dual bay chargers to go with it. So it's quite a flexible battery as well. It's really nice. We do have USB-C charging, and that's the port down here at the bottom. It's a very small port. If anybody of you have seen USB-C style ports, you should be seeing my video there, but it's the very small style USB connectors types. And it uses a standard called PD. And so PD charges very rapidly. We can do 50% charge in about an hour and a half. If you just plug this thing in during lunch, and you were a little bit low on power, you're going to, be able to easily make it through the rest of the day. If you're not stopping for lunch, you can actually plug in an off-the-shelf juice pack battery. Plug that into this device; it'll charge it as well. You can use it with standard USB-C charging systems. So the charging system from your phone, for example, you can plug in and charge it. If you have a USB port on your truck, you can plug into that and it'll charge it. It won't charge it as fast as the PD charger that comes with it, but it will still charge, right? And the PD charger that comes with it is a 35 watt, 30 watt charger. It requires a minimum of 30 watt charger and the PD style for that PD to work, but any one that you buy off the shelf will work. Okay, so the screen, I'll go through this fairly quickly. I'm not going to get into technical details here too much, but it is 20% larger than the TSC3 screen. It uses a modern aspect ratio and a high resolution screen, so we can just draw things more crisply for you on the screen. It's easier to recognize. It is a very bright screen. And it has a really cool anti-glare technology. It is a reflective type screen where it'll bounce the light back at you and make the screen brighter. But if you're working with the direct sunlight over your shoulder and it's hitting the screen, there will be glare, of course, but you'll still be able to read the screen. Where the TSC3, you're really going to struggle with that, especially in that glary kind of condition, where is now with the TSC5, it really, really shines, so to speak, in those kind of conditions, and you can still see the screen very nicely. It is capacitive multi-touch, so you can do the pinch to zoom thing and all that kind of stuff, and enables a bunch of cool features within Access with that touchscreen. We do include, of course, a screen protector with it. It is Gorilla Glass type technology for that screen protector, similar to the TSC7s in how it works. But once you get the thing installed, you can barely even tell it's there. And it works great, and it's actually even helps a lot in the in rain mode. So it makes the rain mode work better while it's still protecting your screen. So when you do go on these devices, make sure that you're using that screen protector with it. And here's just a picture of where the stylus holder is at on the device. All right, TSC5 connectivity. There's a lot of ways to connect to this device. The first is the WAN module. It's optional. We have two different models, but if you go with the WAN module, it is 4G LTE. It is AT&T and Verizon certified, and it uses a micro SIM card, which is available here. Well, I'm showing here, I should say. The nano one's the small one, the micro, and then the mini one. So the micro is the one we're looking for. If you get a mini, they'll have adapters that you can put in there. We had some trouble with the TSC7 with people trying to put nano cards in there. They get stuck. With the design we have for the TSC5, we've eliminated that particular problem. We do have class 1, quote unquote, long range Bluetooth in the device. It will work at longer ranges than class 3 device, which you normally would be using, which TSC3 was. But it's it's not going to give you robot ranges, obviously, right? Because you need one on both ends. But it'll certainly help with body blocking and other noisy devices on site. You should have enough power to get through and be able to communicate with your receivers better, especially. We do have Wi-Fi, which is both the 2.4 gigahertz and 5 gigahertz modes, and it's hotspot compatible, so you can set up a hotspot with the device. We do support the power modules. There's the single power module slot on the back. It does not require a cover. It's safe to use exactly as it is. It's weatherproof the way it is. So if you don't have the radio in place, don't worry about it. You don't need a cover. It does support that 2.4 gigahertz radio for your robot. That's primarily the device we would expect you guys to be using with it. And that's something that's sold separately. And we do support USB-C memory sticks and USB-C cable transfers via the serial port at the bottom, which is also the port you charge through. So you can plug the cable in, plug it directly into your PC, tell the device I want to connect to the PC, you'll connect up, just use your browser to go out and File Explorer to go out and browse the files on your device, really easy. Or you can transfer to the USB-C memory stick, just like this one. Slick and easy. The port is recessed on the device, so there's certain, especially older USB-C memory sticks that might be a little too thick and they won't fit all the way in. So that's something you want to check before getting these. I suggest you get one like this that's also a USB-A style, just like you're used to from before. It's flippable. You can use it USB-C on the TSC5, and you still have TSC3s, and you flip it over, same data, stick it in, it goes. You can also get a USB-C to USB-A converter or adapter and plug that in along with your current memory sticks or cables. So field reliability. So I'm probably going a little bit long, so I'm going to step it up here just a little bit for you guys. Sorry, but it is IP65 rated. It's sealed from high pressure water and dusts. So that is more than sufficient for any job site you might be on. You drop it in a mud puddle, pick it up, dust it off, it goes. Pouring rain doesn't matter. We see our guys down here testing it. That's our technician and mechanical engineer. And you can see the high pressure water spray that he's got going onto the device right here, coming from our water supply and the pump system. So it's like a fire hose going against this thing, and it stays sealed. And the thing importantly stays sealed after we drop it. All right, so we can drop it a bunch of different times. So we talked about here with our mill standards, 26 drops from 4 feet onto concrete. Then we'll drop a 50mm steel ball on the screen. Then we'll go back and test the seal all over again. So it's going to be reliable for it. It's designed to be used every day in the field. With the software and OS we have available, you can read up on these things in the text, the tech sheets that we have for our data sheet we have for you. Biggest thing is you're looking for Trimble Access version 2021. That will be the version that's supported on this device. It is Access, right? It's if you're familiar with it on the TSC3, do not be scared. You'll be able to use it here on the TSC5 just fine. There's a few cool new things that it can do, but it's still the same software. All right, the family of sensors we do support is pretty much the entire Trimble sensor line, with the exception of the SX10 and 12 and the X7 scanners, right? So we don't support those right now. That's more a function of the software than it is of the device. But you can see here the full list of other items that we do support. Real quickly, this is just the accessories that come with the device. Obviously, you get your charger with the cable, screen protector and the cleaners, your stylus, your hand strap, which is the same hand strap they use in the TSC7, a screwdriver for putting your power modules on and for taking that battery port off, and a really, really cool toolbox style carry case with extra pockets inside and outside, and a pocket on the outside you can keep your field notebook in, straps on the inside to hold the TSC5 down, with plenty of room for your power modules and extra batteries and all that kind of stuff. Okay, and the pole bracket, this design is similar to TSC7's. You can see the clips here and here. They're both spring loaded to keep it locked into place. And you can see how much abuse it can take and still stay on the pole. You can pound it down pretty darn hard and it's going to stay into place. It uses the same pole clamp assembly as the TSC7 does. We've added some additional holes here so you can move the device closer to the pole if you want to. And then we removed there used to be a slot in the middle. We removed that to stiffen it up a little bit. So if you do hit the ground hard by accident or something like that, it's going to stay in place. It's not going to wobble quite that much because of that slot being removed. But when the device falls over, if you do drop it or something like that, it should break away from the clamp and distribute the energy that way, so you don't break the data collector. All right, so here's my final slide, just real quick. All kinds of marketing materials out there for you guys to take a look at. The thing that's most important, you go trimble.com/TSC5 or geospatial.trimble.com and browse from there. There's a lot of cool videos you can watch. There's a data sheet, there's sales sheets, there's all the rest of the information you're going to need to get into the nitty-gritty details of this device, and then give Monsen a call and buy one. So I think we're going to wait for questions until Pete is done. Is that correct?
We can do that. You did awesome on your time there, Eric. So Emily, do we have enough giveaways to do another poll at this time? Is that what you were thinking?
Let's do it.
All right, let's go ahead and do another poll here, and then we'll go ahead and how about your questions, Emily? What kind of what have we been seeing on questions coming in?
Most of the questions that have come through the chat, Ryan and Mike were able to answer directly. So we don't have anything to address right now.
Okay. All right, everybody, you see the poll question there. Let's go ahead and introduce Pete Mestemaker. Pete, you are there, I assume?
Yeah, I am, Troy.
All right, Pete, let me just introduce you really quick. And I think that Pete's going to be talking to us about the SX12 and the X7, if I understand correctly. But I just got to say about the TSC5, we've been waiting for this for the TSC7 is awesome. I mean, we've sold a ton of them, but the TSC5 is truly, it feels like a coming. I was going to say the second coming. I don't know if it's that great, but It's we're very, very excited about this device and about how tough it is and about all the other attributes that Eric just barely got finished describing. So, all right, Mr. Mestemaker, Pete has worked as a surveyor for 9 years in Colorado prior to joining Trimble in 2005. His roles at Trimble have included training, working in the market acceptance testing team for the geospatial equipment, and now sells for the Western U.S. distribution partners. So Pete is our rep. He is married with 2 kids and lives in the Denver metro area. And before I let you start here, Pete, am I pushing you too quick to get a winner on that last poll, Em?
Yeah, I will announce it at the end.
Okay, sounds good.
Thank you.
All right, Pete, it's all yours, my friend.
Let's see, Troy, just got my PowerPoint up here. What do I need to do to share it again? You're muted, Troy.
Oh, sorry. Maybe Eric needs to relinquish control, possibly, or Emily, can you make Pete the co-presenter? Or Eric just needs to stop sharing. And Emily,
Yeah, I did stop sharing. There we go.
How about this?
There you go.
I got you, man. You got it.
Is that good? You can see my screen?
Yep, we just need to go into present mode.
Okay. All right, everybody. Appreciate, are you guys seeing this okay? It's the layout's a little bit weird on my screen.
It looks good here.
Pete.
Yeah, I think.
Okay, all right, great. Okay, great. So I'm going to be talking to you guys about the SX12. We just released the SX12 earlier this year. And I want to thank everybody for participating and thank Monsen for allowing us to come and show these solutions to you. So if there's one thing that you take away from me talking about the SX12 today, it's just that it is an everyday instrument, right? You know, the SX12 is a 1-second robot, but it also combines some innovative image capture and scanning capabilities as well. So here's what we're going to talk about today. The SX12 builds on the technology of the SX10, and what's new in the SX12, one is the laser pointer. You've also got an updated camera system in there. Talk to everybody on here just about SX12 configurations because we've got some different options there, and also just the ecosystem of the SX12. Okay, so the picture that you're seeing right here is a true picture from beta testing that we did. Monsen did have some customers that did some beta testing for us. That laser pointer is a green laser beam, and it is a focusable laser beam. So what that allows us to do, just like the SX10 when it was released with the 3D EDM, it has the smallest divergence on an EDM, and also with the laser pointer, we've got the smallest spot size and the most visible laser pointer on the market today. Okay, so what this laser pointer should allow you to do, and what we've done to open up some new workflows and opportunities for you, is maybe get into tunneling and mining space before. So the SX12 was always a great instrument to take down into these situations to go ahead and do some scanning. Plus, again, you could use it as a 1-second robot, but what it was missing previously was that laser pointer, right? For us to identify overbreak, underbreak situations, stake out blast holes, those types of scenarios. Okay, so here's just some info on that laser pointer. Again, it is focusable. So at 50 meters, that laser pointer is going to be about 3 mil in diameter. Okay, at 100 meters, it's 6 mil, and at 150 meters, it's going to be about 9 mil in diameter. Okay, so as you can guess from that, if we were going out to 200 meters, we would have a 12 mil spot size on that laser beam, right? So just over on the right-hand side there, you can see some comparison of some other instruments that have laser pointer. In the upper left, you've got the Trimble S7. Okay, in the lower right, you've got the Leica MS60. Okay, and in the upper right, you've got the Trimble SX12. So again, that's at 50 meters. You can see the difference in those laser beams, right? It is quite obvious. Besides the color, just the size of it. Again, it is autofocus will take place, so it's just like on the SX10. The navigational cameras on that are they autofocus for you. So what we're doing is we're pinging the EDM at a certain interval to go ahead and let us know the distances that we're looking at. That focuses the camera. That's also going to focus the laser pointer as well. Okay. Now you can do manual focus on that. As we've already stated, it is green and it's 520 nanometers. Okay. The laser class of that is 1M. We'll talk about that a little bit more here in a second. And it's got 3 different operating modes. So low light, just where we reduce the power to it, standard, and then extended range flash. So there we're going to supply a little bit higher power to the laser pointer, and it's going to flash to increase the visibility of it. Okay, so here's just some general information on laser classes. So, laser class 1 is considered always safe, right? Laser class 1M, which is what you have in the SX12, is considered safe as long as you don't look at it with an optical aid, something like binoculars, okay? The S series instruments, again, just like we saw in the previous slide, the S7, okay, that's going to be laser class 2. So again, as you get higher in the laser classes, they become less eye safe, all right? So you want to limit your exposure on a laser class 2. And then laser class 3, which is what the MS60 has, okay, there you're starting to push the limits. If my memory recalls, we used to have a high power laser pointer in the S series line. That's been discontinued, but I believe that was a 3R laser pointer as well. Okay, so the other update that we did to the SX12 from the SX10 is the camera system, all right? So basically what you're gonna get from this new camera system is just clearer, more detailed images, right? Better colors, you're gonna have less image noise, and then you can see a comparison chart, right? So we went from the SX10, it has a total of 5 cameras, but we use 3 of those for navigation, okay? We went from a 5 megapixel camera to an 8.1. Okay, you can see our field of view. Okay, the minimum field of view using the telecamera has changed. Okay, whereas the maximum field of view has not changed. So if you are any of you that are familiar with the SX10, if you were doing full dome scanning with panos, the number of images that you are going to collect there has not changed. Okay. With this updated camera system, we've also increased the zoom level. Okay, we'll have some pictures on the next slide that will display this quite nicely. I'm not much of a photographer, so the next line doesn't mean a whole lot to me, but the bottom, the size of 1 pixel at 50 meters, this is very important. So anyone out there that's an SX10 user, or is interested in purchasing an SX12 now that we've released that, it is important for you to know that, again, this is a totally video-driven instrument. So when we are taking things like DR measurements and things like that, it is important for you to realize that whichever camera you're on, whether it be the overview, which is the widest field of view, the primary camera, or the telecamera, which is going to give you the narrowest field of view, but the highest resolution, that can determine some of your accuracies, right? So especially when we're taking DR shots and things like that. Okay, so here we've just got some images of, the same environment, the same conditions from the cameras with the SX10 to the SX12. In the top one, we're using the overview camera, zoomed out as far as we can get. You can tell that the grass is a little bit different color. The clouds look a little bit more realistic. Okay, but what's really telling for me is once we get down to the tele camera. Okay, so here we're zoomed into the same zoom level, that's zoom level 7 on both images. And for one, you can see that, again, we've got a little bit higher zoom level, okay, on, you know, that sign is a little bit bigger, okay, as those two instruments were set up right next to each other, plus the fact that you can just simply read what's on that sign. So again, the clarity is better using the updated camera system. Okay, just wanted to throw this this slide in there for all the end users that are out there attending Monsen's Users Conference. To me, it's important because with the SX10, if you ordered an SX10, it was an SX10, right? You had no options that you could configure. However, with the SX12, and the laser pointer, you can now order an SX12 under the standard configuration. So what that's going to do is basically give you SX10 functionality with the updated cameras, okay? Or you could order it right from Monsen with the standard plus the laser pointer configuration. So again, that's going to give you the updated cameras plus the laser pointer. Now, if you do just the standard configuration on here, you can always add the laser pointer at a later date if you determine that you need that. Okay, as far as the ecosystem goes for the SX12, again, it's going to be run by in the field. It's going to be run by Trimble Access on Windows controllers. Okay, and that data you're going to be able to run it into Trimble Business Center or Trimble RealWorks. So for those of you maybe not familiar, TBC is our geodetic package, and Trimble RealWorks is going to be our scanning office software package. Okay, and then we've also got data exchange format that'll go between the two of those as well. Okay, so here are the Trimble controllers that you can run the SX12 with. Okay, in order to run the SX12, you would need to be running Trimble Access 2021. All right, but you've got TSC7, T100, the T7, the T10. Now, Trimble Access will also run on other Windows 10 devices. Okay, so if you are an end user, you've got a particular tablet that you like to use, you can go ahead and you can buy that tablet. You can buy a version of Trimble Access. You can install that on the tablet. Okay, but you know, the nice thing that we have with our controllers is, as Eric mentioned before, you've got the Empower modules, you've got integrated 2.4 gigahertz radios for long range communications and things like that. Now, one of the things that is important to note is that any of our Android controllers, the TDC 600, the TSC5 that Eric just talked about, will not run an SX10 or an SX12 at this point in time. Okay, so it's not that the TSC5 is underpowered or that it's not capable. It's just that we've got the scanning data engine that's developed over in Paris, and that's only developed right now for Windows devices. Okay, so let's just talk about a few of the changes here to Trimble Access. So with Trimble Access 2021, you can now do scan limits. Okay, so the SX10 and the SX12, as far as basically a scanning perspective go, they're going to have the same type of specs. But before, anytime that you were scanning, anything that was in range, in field of view in your scanning area, okay, you were going to capture that. Now you can set a minimum maximum distance. Now, the important thing to note there is that those points aren't stored, right? So in this example, if you go from 5 meters to 80 meters and you determine that you've got points outside at 85 meters that you wanted to collect, those points, you cannot recover those points, okay? We've always been able to take panorama images with the overview and the primary camera, but with Trimble Access 2021, now you can take panos with the tele camera. So again, that's going to give you the best resolution on those images, right? It's going to give you the most detail if you're doing some work back in the office. Okay, you just want to be careful because the tele camera gives you a very narrow field of view. Okay, so and it's got a fixed focus, right? So if you've got images or objects in your image that are considerably different. You may get some things that are out of focus in there. Okay. Also with the SX, and by the way, all those things would also work with the SX10. Okay, so it's not just limited to the new SX12. It's just functionality that we added in Access for the SX12. Now the dynamic joystick is something that we've added into Access that will also allow you to drive the instrument with the laser pointer on. So, if you can imagine, sometimes you may have the laser pointer on in some dark environments, right? So, and because the SX10 and SX12 are video driven, this is just a way for you to drive the instrument with the laser pointer on, all right, is what that is. So, because the SX10 does not have a laser pointer, this will not work with the SX10, okay? And you can also do some surface inspection where you can compare scans from the SX instruments to reference surfaces, and you can save and repeat scan frames, all right? So if you think about taking an SX10 or an SX12 out into a situation where you're maybe doing some monitoring, but you're not you're doing campaign monitoring, but you're not monitoring individual points, you may be monitoring a surface, right? A slope, something like that. See if you've got any slough going on. This is going to be a way for you to go back, set up on your same two control points, orient your instrument, and then you can go back and you can make sure that you are scanning the same area that you had previously scanned, and then you compare those. Okay, we've also added some functionality into TBC. So, as people on this call are aware, scanning makes data capture in the field very easy. But where it can get a little bit cumbersome is potentially back in the office, right? So to me, the holy grail for processing scan data is back in the office and automatic feature extraction, right? So with TBC 5.4, you can now do auto feature extraction of curb and gutter, okay? Or overhead lines like power lines, cables, things like that. That's what you're seeing here in the lower left and the upper right. And then in the middle, okay, that's virtual topo in the office. So again, any of you that are familiar with Access and that have used measure codes, okay, basically what you have is we've taken Trimble Access measure codes and brought it into TBC so that you can go in, identify single points in your scan cloud, in your point cloud, and identify those, right? Water valves, fire hydrants, trees, things of that nature, okay? So that's all I have for you today on the SX12. Do we have any questions out there?
Sorry, I'm gathering the question from the poll.
Thanks, Pete. Great job, as always.
Okay, so one of the questions from the chat is there a plan to offer an upgrade of the camera in the SX10?
No, there won't be.
And I think that that's all there was that came in. So,
okay, Troy, I didn't know if you guys wanted to do a poll or anything like that right now.
why don't I announce the winner of the last poll? That would be Gary Hancock. So we have another $50 gift card for you that I will get in the mail.
Good job, Gary. Pete, were you planning on something on the X7 as well?
I am, Troy. I'm just having a hard time switching from the SX12 presentation.
I'll go ahead and launch a poll for another giveaway while you get situated.
These are clever poll questions.
There you go. It's coming
Okay,
up.
Pete, looks like you got that up there.
Just got to go into present.
Yeah, just I've got a weird advanced sharing options up here, Troy. You say stop. Okay. Go.
At the very worst, Pete, you could just, there you go. Oh,
Okay, how we doing?
Presenter view.
Now you're in presenter mode there.
What's that? Is that any better?
Yep.
There you go.
Yep, you got it.
All right.
All right, we'll go
All
ahead and
right.
proceed with this with Pete on the X7, and then after that, we'll go ahead and do another poll before we launch into the next one. So, and then also.
All right. All right, folks. So here we're going to talk about the Trimble X7. There we go. Okay, so here's just a agenda. So just for everybody's background, the X7 was released. We announced it at the end of 2019. We really started shipping to customers early Q1 of 2020. And so we've done a couple updates here as well. So we'll roll through. I know I've only got 30 minutes for this one. So and I've got about 30 slides in the deck, so we'll try to get through as quickly as we can. So one of the important things that I want people to take away here is that you know, for the X7, right? We talked, and during the development, before, during, and after the development of the X7, we talked to a lot of customers, right? And it wasn't just customers that were Trimble customers, right? As you can see in the center here, you know, we reached out to Leica users as well. And we really tried to take their input, right? Here are some of the input that they gave us, right? They wanted, you know, performance and innovation. They wanted a smaller form factor, something that you could carry on an airplane, right? As far as, you know, not having to check it, but putting it in overhead. You know, efficiency, complexities with registration. So again, as Troy talked about me when he introduced me, right? I was a surveyor for 10 years, had never used a scanner until I went to work at Trimble. So honestly and admittedly, I will say that there are certain things about scanning that they're not second nature to me, right? You know, I believe that there's kind of a paradigm shift between surveying and scanning, right? Where with surveying, every point you collect is deliberate, but with scanning, you go out and you just collect masses of data, and then you have to sort through that, right? So, plus the way that registrations are done. So, you know, reducing that complexity, right, was a big thing. You know, good ROI and accessible to all users. So not just scanning professionals there, right? Okay, so the three words that we like to use with the X7 are simple, smart, and professional. Okay, we'll dig into each of those a little bit. So simple in the fact that, you know, workflows that were suitable for all users. One of the things that we did with the X7 is we created a field software called Perspective. Okay, so you can use an X7 with Perspective or without Perspective. We'll talk about that in a little bit. I would personally always use it with perspective because it gives me assurances when I leave the field. As with most Trimble optical instruments, we've got vision technology in there to do, you know, capture our scene. And again, compact and lightweight. Okay, so smart. When we built the X7, we really broke some barriers in the scanning market. And one of those was doing automatic calibrations in the field. Another one was doing, you know, in-field automatic registrations, right? We can also do refinement and reporting in the field. It's got survey grade level compensation, and then just flexibility of operation, right? So, and as far as professional goes, right? At Trimble, we always try to make instruments that you can take where your job site is, right? So again, it's got a great IP rating. This was something, I think it still stands today, but it's got a 2-year warranty on it. All other scanners only had a 1-year warranty on them. We'll talk about the EDM and some different settings that we've got there. Some data backup where you've got redundancy, and then this operating temperature, right? Again, this was really in the scanning world, you didn't really see numbers like that as far as the operating temperature went. Okay, so just some bullet points here on some overview of the tech within the X7. I won't read everything here to you. We've already talked about calibration. We'll dig into that. The registration assist, which is the in-field registration and perspective. This is an important one, right? The survey grade self-leveling to 3-second accuracy. That's, again, for a scanner at this price point, that's something that's unheard of. The measurement range is out to 80 meters. Over here on the left, you can see that we've got a couple different options, right? You can do, it can either be a 500,000 point per second scanner, or we can slow it down to capture more difficult surfaces, things that have always been hard in the scanning industry to capture. We'll talk about that in some more detail. Here's just some accuracy specs. As far as communications go, you've got dual band Wi-Fi, you've got 2.4 and 5 gigahertz. You can also use a USB cable. I do know that Monsen had a customer previously that bought an X7, and they were using it in some certain locations where Wi-Fi wasn't allowed. Okay, so we've actually got a way that we can disable that Wi-Fi. We can't take it out of the system, but we can actually disable it, which was made that customer very happy. As far as the scan duration, I've got a slide that'll detail that, right? But you can go from basically 1.5 minutes to up to a 15-minute scan. Here's just some point spacing which is going to be dependent upon those scan settings. The number of points, I've already talked about the point collection or the pulsing of the laser, right? We've already talked about some of these environmental specs. And as far as the vision system goes, it's got 3 integrated cameras that are coaxial, about 10 megapixels each. Okay, so here's just a system overview. When we sell the X7 currently, we don't sell just the X7 as a standalone unit, but we sell it as kit. You can either do a BYOD kit, or you can do a bring your own device kit, or you can order it with a T10. That's a tablet that we see right here. And you get all these things with it, right? So the intent from our standpoint was that the customer orders the kit. They didn't need to order anything else, right? You've got enough batteries for the scanner, for the tablet. You've got a hard case. You've got the backpack. You've really got everything that you need. Now, minus some field software, right? Okay, and also one of the great things about the X7 is it just uses the Trimble standard optical battery. Okay, so you've got some interchangeable options there. So let's dig into some of these key features, right? One of these things is the auto calibration. So again, this was revolutionary in the scanning market. Okay, it's a 25-second auto calibration. You don't have to use targets. It's a calibration that checks not only distance accuracy, because other manufacturers will talk that they auto calibrate as well, but they only calibrated to check that the EDM was measuring in spec. We've advanced that to the point where we do an angular check and a distance check on the EDM. Okay, plus we do it without any targets, without any weird routines that you have to do. It's going to do a calibration before every scan that you do. All right, so that's going to ensure your data accuracy. It's going to mean that this scanner doesn't have to go in for an annual calibration, which can save you weeks of production time and thousands of dollars cost annually. Again, that reduces maintenance costs, reduces ownership costs, and again, it enables us to give that that standard 2-year warranty, which again was revolutionary in the market. So again, Trimble perspective. This is the field software that we developed to run with the X7. Okay. Again, I myself being more of a scanning novice, right? The way most people would use scanners is they take it out, you plop it down, you hit scan, you wait a couple of minutes until it's done, you pick it up and you move to your next location. So you don't have any idea until you get back into the office if you're going to get scan 1 to register, to scan 2, to scan 3, to scan 4, right? And if you can't get your scans to register, your data is basically unusable, or you're going to have to go back out to the job site. So now you can use the X7 in that fashion, but Perspective gives you some assurances out in the field that, yes, the data that I have collected is going to, I can register it in the field, I can export it in the field, I can georeference it in the field, I can actually do some production out in the field, right? I can do annotations, labels, I can do measurements out in the field. These are all things that were never capable with any other scanners because you didn't have a registered point cloud in the field, right? So very, very important and very unique to the X7, okay? So that registration that we do, it is IMU based, so the X7 does have an IMU in it, okay? And again, it's not a, you know, it's not a partial registration. I would always recommend to people that you take your registered point cloud, because what Perspective is going to do, you know, again, we're running a tablet out in the field. Okay, we're not running a big workstation that can handle millions of points in a point cloud, right? So now the T10, I said millions. I'm thinking more in the billions range, right? But what Perspective is going to do is it's going to take every scan that you do, whether it's 100 million points or whether it's 5 million points, and it's only going to use 2 million of those points at a time, right? So that's how it's going to do its registration. So my recommendation to everybody would always be that you check your registration when you get back to the office. You could use TBC for that. You could use RealWorks for that. You could use some other point cloud package that you had if you wanted to. But what it does is it allows you to leave the field knowing that you've collected all the data that you need, right? As you can see here in the picture, you know, maybe our project site is the bridge. So, you know, I can visually see this point cloud, even though I'm not seeing all of the points within the point cloud, to know that I've covered my project site, that all my scans are going to register together, and you know, that can avoid having to get back out to the job site, you know, to do additional work or rework, right? For just things that you haven't seen. We can also do labels, annotations, and precision points. All right. So with the release of Perspective 2.0, when we first released this solution, we did not have georeferencing in the field, right? So now with the release of Perspective 2.0, you can do georeferencing in the field, you can do some reporting, you can do quite a few other things in there. But you know, and again, the way that scanning systems would typically work, you would take your scanner out, you would do all of your scans, and then you had to do your registration back in the field. So labels are ways for you to group certain scans together. So in this picture, you can see we've got a couple different floors of this building. Well, if you're doing a 4-story building, all of a sudden you can have a lot of data that is piled on top of each other, right? Because we look, you know, on our tablet screen at all of the data that we've collected. So if I'm labeling my scans, what I can do is I can turn off floor 1 and floor 2. I'm working on floor 3. I know the registrations are good on floor 1 and floor 2. So I can only look at floor 3, make sure that all my registrations are good. I can filter that data down. I can simplify what I'm looking at. Annotations are like sticky notes. Okay. So, you know, again, I talked about it earlier, how, you know, when we're surveying, every point that we collect is deliberate, and we collect it for a reason, right? If there was no reason for us to collect it, we wouldn't waste our time. We'd move on to something that we wanted to use. But when we're scanning, we're collecting everything that's within our scene, everything that's within the range of the scanner. So, you know, what you can do with annotations is you can go ahead and you can call out certain things in the field. So you can actually do some production in the field. So when we were beta testing this, we gave it to a company that did midstream oil production. And what they had to do was go out and do a lot of scanning at these midstream facilities. And as they were scanning these facilities, which weren't the largest facilities, but they were very detailed, they had a lot of pipes, they had a lot of infrastructure on it, they had to call out things like the type of valves that were there. Well, you can imagine that, you know, as a lot of scenarios, one individual goes out and collects the data, brings it into the office, gives it to a different individual who's maybe never seen the job site, and says, here, you know, here you go. So they had to do things called PNID codes, right, which was calling out the specific valve or the specific connectors on some of the piping that was at these facilities. They could actually do it out in the field. Again, something that the X7 in perspective as a system allowed them to do that you could never do with any other solution before that, right? And then the other thing we've got here is you can use the laser pointer to collect precise points if you've got targets up that have coordinates, things like that. Again, what that allows you to do is actually georeference your registered scan data, get it onto your project control, and then, you know, again, we'll talk about some exports here in a bit, but you know, that allows you to basically not have to take it into the office if that's the approach that you choose. All right. Again, that registered point cloud data allows us to do certain things like measurements, right? We can do different types of constrained and unconstrained measurements. Again, things that would not ever be possible with a traditional scanning system that doesn't have the capability to do the registration in the field, okay? But again, you can go out, if you're looking for a bridge clearance, you know, you can go out, you can scan that bridge, you can actually do, you know, a constrained vertical measurement. So, you know, you're getting from the bottom of the bridge deck to, you know, that low chord elevation down to the you know, surface of the asphalt or the concrete. And you're getting, you know, a true clearance elevation in that situation. Okay, so now we're talking about the EDM. So if you remember from that technical overview slide, you know, when people talk about scanners, they always want to talk about how many points per second, right? So in the standard mode of the X7, it's 500,000 points per second. Now, one of the other unique things about the X7 is that we have this high sensitivity mode. So anybody out there that, again, has done scanning or has some experience scanning black surfaces, really shiny, like highly polished aluminum surfaces, these are traditionally surfaces that are very hard or impossible to capture with traditional scanners. Okay, if we're out and we're scanning the inside of my house, for instance, using the standard mode, collecting 500,000 points a second is going to work just fine. If you go out to an oil production facility, or in the picture that we've got here, where you've got some shiny black cars, you know, a traditional scanner. So on the top of this is an actual picture of those cars. The bottom is the point cloud. Okay, so normally what you would see is you would see points on the asphalt, on the buildings, on the fence across the street, but these cars that are black would just be holes, right? They would be voided data because traditional scanners just typically can't capture on that type of surface. But when we go to the high sensitivity mode on the X7, what we do is we slow down the frequency of the pulse of the EDM, okay, and we increase the power of it a little bit. So we're not collecting as many points, but what we are doing is we're collecting points where you traditionally wouldn't have gotten any points before. So, you know, I've always said that getting some data is better than getting no data, right? And this is definitely one of those scenarios, okay? We will go through a slide next that kind of talks about the different scan durations and the different settings that we have. you can see here, 0.6 to 80 meters, again, talking about the accuracy and the range noise. And again, with those two different modes, standard and high sensitivity, allows us to capture data on dark, highly reflective and shiny surfaces. So this slide just details the different scan durations and the spacings, the file sizes that you're going to get. So over on the left side, you can see you've got scan duration options, 2 minutes, 4 minutes, 7 minutes, and 15 minutes. Okay, when we do a 2-minute scan, your only option is to collect it under the standard mode, so 500,000 points a second. Once you go to the 4-minute and the 7-minute scans, okay, you can collect your data at either the 500,000 points per second EDM pulse, or you can go ahead and you can do the high sensitivity mode, which again is going to slow down the pulse of the EDM, increase the power to it. Okay, so your point spacing is going to be different, even though the scan duration is the same. Okay, but again, if you are trying to do stockpile volumes on a pile of coal or something like that, again, that dark, that black coal is typically going to be very, very hard for a traditional scanner, right? So, this should allow you to capture some data there. So here you're seeing just spacing at 10 meters, 35 meters, and 50 meters based off of the different scan duration and the EDM setting. Here's your maximum number of points that you could collect with those scans and that file size. Okay, so this is another consideration that people always, people that do a lot of scanning, a lot of the times they just have external hard drives that are just laying around their office because they've got to back up their data. They've got to store all their data. And, it's not uncommon for people to get out and do scanning projects that are going to be, several hundred scans as far as that goes. Okay, so as far as the vision technology goes, again, the X7 uses 3 cameras that are 10 megapixels each. Okay, in this picture, the picture on the right-hand side, that's the actual image capture. Okay, this one on the left-hand side, that is actually a colorized point cloud. Okay, and the only way that I can tell that is just for the fact that you can't see the clouds in the sky. Okay, there was no data captured up there. So here we'll dig into those cameras a little bit. Again, 3 coaxial 10 megapixel cameras. You've got different settings that you can use. You can use fast, which is going to be 15 images at 6 positions around the horizontal 360. Okay, take you about a minute. You can do quality images. Okay, and so the image capture is the same, right? So don't get confused between fast and quality. It's still capturing the same images. It's just that it's capturing more images. And what quality is meant to do is to cut down on the amount of parallax that you can get. Okay. And then with the release of updates to the system, right? You've heard me talk about georeferencing, things of that nature. The precision point using the laser pointer, that type of thing. HDR images, that was added in with that kind of midpoint release, right? So that was, I think, just more towards the end of last year that we did that. We've also got some white balance settings there. So you've got, I believe, 2 indoor presets, 2 outdoor presets, and then you've just got an auto setting, okay? So we can also do different types of panorama creation, right? So the fast panorama creation, which is going to be this corresponding picture, the one on the upper right, is going to be what we're going to use in the field software. Okay, so it's going to just use a fixed distance. So you'll see when you do this that that you can get some mismatches, things like that in there. But once we go to export the data, when we go into do refinement of our scan registration, that type of thing, then it's actually going to use the point cloud to go ahead and fix those mismatches. So you can see that's the exact same image, but you can see here you don't have the offset in that support beam. You know, this whiteboard is looks normal, right? You do get a little mismatch in color, but you know, that's just kind of how the system is, right? There's nothing out there that's going to work perfectly as far as that goes. So those are just some different ways for you to create panos right there. The auto level compensation. So when we release the system, okay, and I think you've heard me say this already, but it will auto level back to 3 arc seconds. When we release the system, you had to be within 5 degrees, right, of being level in order for that survey grade accuracy of 3 arc seconds to work as far as the level compensation. What we've done now is we've increased that to plus or minus 10 degrees. Okay, so you'll notice here that in this picture of the X7, right, we don't mount it on a tri-brack. The way it comes in the system, this is a Gitzo tripod over here. So it's very light, it's very quick, it's very easy to use. This is a quick release for it so that you can pop the scanner on and off real quick without having to screw it on the threads. Although it does have a standard, you know, survey 5/8 threads there, right? So you could put it on a tri-brack if you wanted to. Yeah, it's, you know, 10 degrees is pretty, I would say relatively easy for a surveyor to set up an instrument or tripod, you know, at plus or minus 10 degrees so that the, you know, that compensator kicks into the 3 arc seconds. Obviously you can use it inverted, okay? You know, we've done that multiple times. Now, when you do that, auto registration gets kicked off. Okay, so you would have to manually register that data, which again, you can do in Perspective or you can do in the Office software. You know, doing things like floor flatness and things like that, that's, you know, critically important. So portable and compact. So when the X7 first came out, I traveled around with one quite a bit to the different dealers that I work with, the different distribution partners that I work with. And, you know, I know I've said already that in the kit for the X7, it comes with, you know, it ships in a hard case, but we've got this, this backpack right here, right, that will accommodate tablet, chargers, batteries, you know, the scanner itself. And one of the design considerations for the X7 itself was to be able to carry it on a plane, right? Anytime you've got an optical instrument, last thing I ever want to do is ship it, because I think if you put a fragile sticker on it, that just makes them treat it and abuse it more, or give it to baggage handlers, right? Because you've seen how they manhandle suitcases and things like that. Well, you know, a box with a fragile sticker on it, I don't think means anything to them. So, you know, I would check my luggage and I would take the X7, put it in the overhead. Now, it's not going to fit in every overhead, right? If you get on smaller regional flights, it's not going to fit in those overheads. But you get on typical planes, you know, they don't need to be 747s, but get on typical planes and the scanner itself, you're going to be able to keep it with you, keep it safe, know how it's been handled, and put it in the overhead. Okay, so as far as the, you know, the reliability goes, you heard Eric talk about this as far as the TSC5 went. You know, again, very good operating range, very good IP rating. The mirror, the rotating mirror, the deflection mirror in this scanner is actually covered, which protects it, which keeps it clean. And again, these are all things that have allowed us to have that 2-year warranty, which again was unheard of in the market. And then that instrument's just made over in Jena, Germany. Okay, so we've talked about some flexibility as well. You know, again, me being more of a scanning novice, I would say that I would always use the top option, right? Using the tablet connected to the X7 with Perspective. I want to do a scan. I want to do 2 scans. I want to see that they're going to register to each other. If they're not going to, I'm going to go back in, I'm going to split the difference, or I'm going to pick a, you know, strategic spot. I'm going to have scan 1 register to scan 3, and then scan 3 register to scan 2, which are all things that I can do in Perspective. This also gives you data redundancy as far as the X7 goes. Okay, there's another way that you could operate it, and that would just be by initiating the power button while it's connected to the tablet. That's going to give you data redundancy, and what the scanner is going to do is it is going to use the scan settings from the previous scan. okay? But you are not hitting, you are not using the tablet to control the scanner, okay? You're using the power button to control when the X7 scans. Or if you are a true scanning professional, somebody that's got a lot of experience, you can leave the tablet in the office if you want to. You can just go ahead and take the X7 out, scan your project, bring it back. Then you could either hook the tablet up to Perspective. It will download that data. It will register that data sequentially how you scanned. Or you could skip Perspective altogether and you could bring it into an office software package, right? Do that registration in the more traditional sense and then start to work with your data. So if we've got registered scans in Perspective, okay, these are all the export formats that we've got. E57 and LAS, that's not proprietary to any particular manufacturer, okay, those are industry standards. RCP is going to work with Autodesk products, all right. POD is going to be a Bentley format, and PTX is going to be a Leica format, okay. So again, if we're happy with the registration out in the field, we can just take that registered project, we can export it, we can refine it, we can report on it, and you know, without ever going into an office software package, we could go ahead and export that data to accommodate whatever office software that we want to take it into and start to do some production work. All right. As far as the Trimble office softwares go, TZF is our native file format for the TX6 and TX8 series, as well as the X7. And TDX is what we would use if we were exporting a registered product to bring it into either TVC or RealWorks. This is just a brief list of customer applications. I'm not going to sit here and read it to you, and by all means, it is not inclusive. But when we release the X7, these are a list of some top applications that we came up with. And with that, I will wrap up this presentation and see if we've got any questions out there.
We do have a few questions. The first one was, will there be a feature extraction feature for stripes on the street?
Well, so we actually have that right now in office software, where you can, you know, striping on roads is typically highly reflective. And so in TVC and RealWorks, so, you know, in TVC, we've got the scanning module, right? And basically what it is we've taken the registration, some of the registration things out of RealWorks, and we've ported it into TVC. So the scanning module in TVC is basically a stripped down version of RealWorks, I guess, if you will. But you can filter points based off of reflectivity. And I won't say that I'm real good at it, but I have seen guys that are much better manipulating scanning data than myself. And they can actually, based off of a slider bar in there, they can get that right to the right point, have it filter out, you know, based off of the return signal that we got from that highly reflective paint, that they can basically, you know, only get the striping, and then they can go out and kind of delineate the striping. So, you know, again, just like everything, right? Nothing is perfect. Some striping is more worn than other striping. So you're going to find scenarios where that's going to work really well. And then you would probably also find scenarios where that may not work so well.
Okay. The next question is, will the X7 need to be recalibrated by a certified technician if it takes a good bump, like falling off of a tripod?
My guess would be yes, but when you do the auto calibration will tell you whether the instrument is within spec or not. So, you know, I guess I can imagine a scenario where an X7 would take a spill, maybe onto a softer surface, something like grass that was maybe wet and not rock hard, like in Eric's video. And it could potentially survive that. It could also depend on where it's going to impact on the instrument. But, you know, from my days of surveying, if I had an instrument that took a spill, the first thing I'm going to do is I'm going to get it into Monsen, and I'm going to let them check it out and make sure it's within spec. But again, the X7 is doing an auto calibration before every single scan that it does. So If that auto calibration comes back and tells you that it's good, then it should be within spec.
Perfect. Okay, and one final question. How is the target demographic of the X7 different from the SX12?
Well, the SX12, again, if you think about the SX12, the most important selling feature to me of the SX12 is that the SX12 is a 1-second robot. Okay, so again, as I said on the first slide of the SX12 presentation, if you take nothing else away from today, or at least from the SX12 presentation, it should be an instrument that is not, if you own one, is not ever sitting on your shelf, right? You can take it out, you can do traditional topo like you would with a robot, you can do traditional stakeout like you would with a robot. It's got great imaging capabilities, and it's also got scanning capabilities, okay? But a full dome on the coarser setting of an SX12, scanning-wise, is going to take you, in line of 12 minutes. And then if you're going to do panos on top of it, that's going to make it about a 15-minute scan and image capture, okay? If we're talking about the X7, at its coarsest setting, okay, under standard, that's going to be 500,000 points a second. And you're going to be able to do a 1 minute and 34-second scan that's going to include the calibration, right? And capture images in like 2.5 minutes, okay? So, if you are trying to do real scanning work, then I would say that, the SX12 in that scenario, if you would give the SX12 to a person that has only done scanning, they're going to think that it's slow, okay? But if you give an SX12 to a person that's only ever taken single point observations, the scan data that you can collect with that instrument is amazing, right? And you can go out and you can traverse with it, you can do typical station setups, orientations, things like that. It's a great way for you to amend your single point observation data, okay, and make it so that you don't have to go back to the site to do rework, right? Because if I'm using an SX12, as I go out and I'm unloading my gear, the first thing I'm going to do is I'm going to set up the SX12. I'm going to do my station setup, and then I'm going to go ahead and do just a full dome scan, right, or a horizontal band scan of the area that I'm working in. That way, I've captured data for shots that maybe I would have missed doing single point observations. All right. But if I'm doing a big condo mapping project where, for instance, I'm trying to figure square footages of, individual condos for their owners, because that's, we used to do some of that in the job that I worked at prior to Trimble. If you take the SX12 there, that's not going to be an ideal application for the SX12, okay? But that would be an ideal application for the X7, because I can go out, I can do 1.5 minute scans in every room that I'm in, I can get them registered together. I don't need to take images because I'm really looking for square footage. And, different applications for different instruments, okay? If you're somebody that has never done scanning before, SX12 is a great way to get your feet wet.
Any other questions?
I hope that answers your question. I know that was probably a long rambling answer, but I hope that answers your question.
I think that was great. Thanks. That was the last question, Troy.
Okay, we do have a winner from the last poll that I will announce now. This is from the SX12 poll, Gregory Rivero. So hopefully, Gregory, you're still on the line, and please message Emily through the chat and how she can get those cards to you. Next up, we do want to do a quick poll on the X7 presentation that Pete just barely went over. And we'll give you a moment to go ahead and answer that poll. While you're answering that poll, let's go ahead and first of all, let me just thank Eric and Pete for their great presentations, their great product knowledge, and being such great reps to us. They're always super helpful, and especially with these new products as they come out.
Yeah, more than welcome. Happy to be here.
Yeah. Yep. Pleasure, Troy. And congratulations to you guys for having to put this event on for 25 years. That's
that's awesome.
That says a lot about the Monsen institution.
Thank you.
Thanks, all.
Okay, while you guys are answering this, let's go ahead and introduce our next presenter, Matt Gillins. Matt Gillins is an engineer with JUB here in Utah. JUB is a fairly traditional civil engineering and land surveying firm. Let me just introduce Matt to you. He is a professional, he's a PLS licensed in Utah who has been involved in a variety of different surveying projects over his career, ranging from cadastral surveys from his time at the BLM to bridge inspections using UAVs at Oregon State University, to most recently land development, property, and municipal surveys at JUB Engineers. Matt attended the U of U, where he received his bachelor's degree in civil engineering, and also Oregon State, where he received his master's of science in geomatics. So Matt loves flying UAVs as a Part 107 drone operator and using the data to solve engineering problems. So it's great to have Matt present to us, and I think I see him there. Before we turn it over to Matt, I think we already have a winner from the X7 poll that we just barely did. And so I'm just going to go ahead and announce that now. Hopefully I don't mispronounce this last name, Neil. I apologize if I do. Neil Bandettini. Neil Bandettini. Hope I got that right. Neil, you're the winner of our $50 gift card. Okay, once again, just message Emily. Let's go ahead and Matt's got an awesome story about the Emerson Hovermap technology and how JUB utilized that for some pretty unique surveying applications here very recently. And very grateful to have Matt here and JUB. And so with that, I'll go ahead and turn it over to you, Matt.
All right, cool. Let's see if I can get this screen share going. Let's see. Start this. And then here, we're going to share this screen. Then, all right, does that look correct?
That's the presenter view, Matt.
Okay, I'll swap it. How about that?
There you go. Perfect.
All right, thanks for the intro. And today we're going to talk about kind of how we ran into a problem when we were contracted to do some survey work for a wastewater reclamation facility. And so we're going to walk through that a little bit. I don't have a whole lot of technical details, but more of what the problem was that we ran into and how we went about solving it. So we got contracted with Brown and Caldwell. They're doing a whole bunch of re-engineering of the Central Valley water reclamation facility. And they asked us to do some survey for them to get 74 manhole structures, which included meters and other diversion structures. And they were really after the pipe size and the invert location, X, Y, and Z on all of these structures, as well as images. And when we went into it and agreed to it, we were thinking we were going to be looking at stuff like that down sewer manholes, which is pretty simple to deal with pipe mics to get pipe sizes and the traditional methods with just GPS shots. But we ran into manholes that were running very full to where you could barely see any pipes, or you couldn't see the pipes at all because the structures were so large and recessed, and you couldn't even get in them safely and get to measure them because there was nowhere to even stand, even using the normal safety precautions that we would go to, being very old manholes without ladders and that. So we started identifying, well, this isn't nearly as easy as we thought, because we needed the location. A lot of the manholes are running so swiftly, we would worry our dip and stick for taking measures would actually break off inside the manholes because they were running so swiftly. And it just wasn't safe to go down in them and get out of sight, for obvious reasons. And you don't really want to get in sewer manholes at all to begin with. So we thought, well, maybe we can scan them. So we called up Troy and Monsen Engineering to see what sort of small scanners they had that maybe we could scan each structure and get the information without having to actually physically be inside of each manhole. So that led us to the Hovermap, and this is from Emerson's website. And it's a very small unit that is meant to actually attach to drones and be a new mobile scanner with the idea that you could put it on a drone or a backpack and walk around. Something very small, lightweight. It still works in the same way as other mobile LiDAR units in that it has IMU, INS stuff. It's got your inertial sensors, your gyroscopes, your GPS unit on board for adjusting for drift in those sensors. But it's a much smaller package with smaller sensors, something easy that you could pop out of your truck and put down inside of a manhole. So that's where we began our adventure using it. Here is our setup at one of the manhole locations in Salt Lake City. And immediately after taking the picture, we put out some more cones and more PPE for safety. So I didn't take a lot of pictures because I didn't realize we were doing the presentation at the time we started this. Troy asked us to do it midway through our process, but this kind of shows the setup. We set up some ground control points at each of the locations, which we shot with our GPS units. A note that we found it much easier to locate the targets if they were 3D shapes instead of just like a sticker on the ground. We set up the safety equipment, and then we also took a lot of extra check shots in the area, stuff what we thought we would be able to see in each scan to make sure that our georeferencing in the future would be correct and we could trust that our orientation and all that was good stuff. So the process was simple as turning the machine on by clicking a button and waiting for it to spin up, run through its initialization process. We hooked it onto our safety tripod that we use for when we lower people down into them and lowered it in slowly. Some of these manholes were 15 feet down. There were lots of very low spots that we had to get down. So lowering it down on just a stick wouldn't work. We had to have the harness situation with the winch and the cables. And then something that you need to make sure to do, immediately transfer the data off the scanner when you're done scanning so you don't forget. That would be a major mistake. So that was kind of the steps while we were doing scanning. You just make sure that you set out a minimum of 4 targets and then take additional confidence shots. You could theoretically get away with 3, but as surveyors, we know more is better, so you can check yourself. And then this leads us to actually processing the data. I took this screen grab after I had already returned the equipment, so I no longer had the license dongle. But this is kind of the screen when you open up Emerson's software to process your data, obviously without the licensing error. In there, they have the ability to configure what you want. You can filter out by distance from your scan location. So that way you can get rid of, you can see on the previous, I don't know how well but you can see that there's a metal cage around the scanner to protect it when it was dangling by the cable. But it would filter that out, and you can set that up in your configuration, as well as you can shrink the area you're looking at, because you don't really need, when we're scanning such a small area, we don't need 100 feet around us by any means. So you can greatly reduce the size of your files and the data that you're collecting by once you export it out of here, that is. So that's kind of the processing step. It consists of just dragging the folder that it creates when you run the data and transfer it off right up to the top there where it says drag and drop. It's real simple. Then it automatically goes through and runs it. Didn't take very long at all, just a few minutes for each scan. And then it outputs you can choose what sort of file output you could. I couldn't remember all of them. That's a good question that David from, I believe, Emerson is going to be able to answer any technical questions about the scanner itself. But you can choose different. I know LAS and LAZ were options. I use both of those while processing the data, which is kind of the standard, as we've mentioned in other presentations today. Then the data is not georeferenced coming out of there, so you need to be able to georeference the scans, and we didn't have any software but Trimble to do it, and that Trimble works great for this, for georeferencing the scans. On your ribbons in the top left, you're able to choose to georeference the scan. This is one of the ones we did. From the overhead view, it's kind of hard to see what you're looking at, but you're able to choose the points that are your your ground control points, and choose what point it is within your scan. These images you can see are targets that we laid out with the 3D objects, so they're easy to locate within our scan. And you select each one, and it's as easy as click georeference, and then check your points, your check shots against the point cloud to see how well they line up. On the bottom right of this screen, it'll actually give you the residuals, how well your ground control points are matching with the scan. So you can get an idea of how well your not registration, but georeference. This being a mobile unit, there isn't any registration that I needed to do for these, as it was a very small scan site that was only going for a few minutes. It wasn't large swaths of like aerial data or any means by that where you can have misalignment in different swaths, but this is just a small little manhole area. So from here, we would go to, now this is the step that I took. There's a lot of different ways that you can go. I preferred to export the data, as the client showed interest in having a georeferenced point cloud as well. So you can export it right out of TBC here, and you can see there's many different file types that are supported. I just did the LAS, so because that's kind of the standard, and most programs can handle that. And that way I could use a program I was a little more comfortable with in manipulating the data. I went to Cloud Compare. It's a free open source software that allows, I'm just more used to it in terms of view boxes and parsing out the data. I know Trimble and TBC has the ability to do this as well, but this is what I was more comfortable doing it in. As when you import it into Cloud Compare, you just need to make sure to say, yeah, it's okay to transfer it to a different, what's the word I'm looking for? Not datum, but like coordinate system. Just do a translation here, because it still keeps track of the real world coordinates that we were dealing with, but it has a really hard time displaying the points when you get large coordinate values like NAD 83 coordinates. When you get state plane coordinates, it won't display them properly, and you get no density of points. So you got to make sure to do this. It actually will still keep track of the translation within it when you come to picking out what points you want to export. So it's not the end of the world, that you're not losing any data. It's just for visualization purposes. Bringing it into Cloud Compare, the points are very hard to see normally. So you definitely want to switch to high contrast instead of grayscale for intensity values. It shows up a lot better. Maybe some people prefer it. This is a preference thing, but I definitely prefer to work with the high contrast. This scan wasn't processed to shrink down the area very much, so I had to locate where it was, but from using the cross-section tool, I was able to isolate down each structure after we had dipped it down in. And you can use the cross-section tool, which I didn't highlight it the way I meant to, but it's the one on the top looks like it's got 3 planes, gray, red, gray, 3 different planes. That's the one I use to chop it down and export it into new smaller clouds, so we don't have all that extra data. From there, you could then extract the amount of data that you needed. In our case, we wanted to be able to see each pipe. And then from there, we could click points, make measurements. And again, there's a million ways that you could do this. You could run different ransack algorithms if you want. When we were just trying to get point data, it felt like it was a lot quicker just to do a cross section of each pipe, take a measurement of how wide each pipe was, locate the top of the pipe and measure down, because the water was still flowing. And that's where I believe what these noisy points are from primarily, is that there was water flowing down in each structure, sewage water. So for there, you can see it gives you 2 different coordinates, your translated coordinates, as well as the actual coordinates that you were dealing with, to a ridiculous number of precision, which of course we don't want to report. And we did that for each one of the ones we scanned that were not possible to do in a more conventional way. And I believe it was nearly 37 scans that we were able to run through, which there was definitely some trial and error that we ran into, not knowing exactly how the software worked to begin with, or how the scanner would behave. The recommendations I would give if you were going to consider doing something similar to this is definitely use 3D targets. You've seen the spherical ones. Those ones are hard to shoot with GPS. You can set them up over it and get your measure downs if you want to do it that way. I found it easier to use like a brick, or we had some wooden, I don't even know exactly where we got them from. Those were purchased by another surveyor at our firm, but they showed up real nice in the scan, and we were able to shoot a corner of them to get a definite corner location for our isolating the ground control points. If you do decide to use the Hovermap, definitely bring a laptop with you while scanning, because we did have 2 misscans while we were doing it where they did not align properly. There may have been a way to salvage them, but we found it faster just to rescan them, because it was only a couple minutes to rescan. So if you bring a laptop, it only takes a couple minutes to do the initial run through where it corrects for time, drift, location, movement. If you don't have the laptop there, you're working on faith, which is not too fun to do. I much prefer to know the data that is there, so you don't have to visit the site more than one time and set up. And the other thing, make sure to lower it deep enough. One of our scans, there were multiple access ports to this manhole. It was a structure that had a port down to it. and portal hole. And one of the scan times we did it, we didn't get quite deep enough, so we didn't get any pipe information. So that was disheartening and having to do it again, but not to the end of the world. It just make sure to get it in there. Now I been going pretty quick in my talking, so I know I started a little later, but I am now ready for questions if there are any for our processing and how we did it.
Hey Matt, you had a slide a few back where it showed not that one, but there was, I think it was one before you took it out of TBC where you actually could see. There you go, the one up on the top left. I just thought that was it kind of painted the picture of the cabinets that you used on top of the ground to isolate the control, and then you could see the vault down below.
Yep. And you could see how we definitely couldn't see where the pipe was from above. And this was a very big pipe that was taking up the bottom of the structure where you had no room to maneuver or put someone down in it safely. So it worked out pretty slickly for us. So we were happy with that.
And so the picture on the right, is that a picture of some spheres or something that you're using for ground control?
Yeah, so that's the little triangular piece. This is when we were using stickers on top of them to use the ground control points. You can see it's like an iron cross situation there. And there were two balls we set alongside them these scans weren't done by me specifically, but by another group of surveyors at our firm. They thought it would just make it stand out easier, and it did. It worked. It was something we just introduced to the area while we worked, so it really popped in the scene. And even though I wasn't there when we did the scanning, I did the processing, and I was able to locate the targets with relative ease. So that helped us out a lot.
Yeah, on this picture up on the top left, you can actually see some of the RTK vectors and some of the control points that you shot above ground, and then you can also see the tripod there where it was picked up in the scan along with these objects, and then lower down into the vault, so you can geo-reference the whole thing.
Yep, exactly.
All right, Emily, is there any questions for Matt then?
Yeah, no questions from over here.
It was pretty simple application, but it made our lives a lot easier, and it made the project quite a bit safer. So we were thrilled that it worked out so well.
Yeah, there was that other slide too, Matt. If you can still, I think you couldn't hear me very well before, but if you back up a couple more slides, that was the big picture. You could see the cage that the Hovermap was in. It just the one previous to that. Can you back up one more slide? Oh, it looks like we might have lost Matt. Okay. Looks like we lost Matt. Okay. Well, we have one other, just a comment from Mikey Melancon in our office. We're supposed to have a representative from Emerson here. It looks like he was not able to make it, but Mikey, would you like to, is there something that you wanted to offer relative to the Emerson presentation?
Yeah, thank you, Troy. Can you hear me this time? I know y'all been having trouble hearing me throughout the presentation.
I can hear you good.
Yeah. Okay, so yeah, I'm just going to share a little bit of spec information. Thank you, Matt, for sharing that. I think the real beauty of this Emerson Hovermap is its versatility, and the way that Matt and JUB used it was very unique. It's something that I don't even think the guys at Emerson have seen. So they actually showed capabilities that our partners over at Emerson weren't aware of. So I appreciate that and them pushing the envelope. Let me share my screen real quick, and I'll just get a few specs up on the screen and try and answer any questions that some of our customers might have. And yeah, we'll go from there.
Yeah, Matt mentioned typically you see this unit on the bottom of a M210 or an M300 DJI drone. So its capabilities in terms of channeling point cloud information into the navigation system of the DJI itself is where it's really on the bleeding edge of technology, being able to fly indoors and down tunnels and in areas where just people cannot go, which is why we thought this was a perfect example with the JUB sewer vault survey. Go ahead, Mike.
Sure, yeah, so I was just gonna show, we have 20 ways that you can use Hovermap to kind of show its versatility. A lot of these were collected as a drone mounted scan. Some of these were collected handheld. You can mount the scanner onto a vehicle or a Polaris. I don't want to be brand specific, maybe John Deere, either way. But it has been used to collect information on telecommunication towers using drones to keep a safe distance. It does scan up to 100 meters away. The scanner itself is collecting 300,000 points a second. All of these point clouds we're about to show are displayed in Cloud Compare. It is a free software, really for viewing data. You can georeference in there. You can, save portions of your scan in Cloud Compare. But I believe a lot of our customers will be taking this into TBC or RealWorks. So the four formats that you can export data to are LAS, LAZ, PLY, and DXF. So those are all compatible with Trimble software. I know we've had success using LAZs over here since we've been scanning ourselves. I know the guys over at Kennecott are using that as well. Let's see, transmission towers. You can see you pick up data from something as small as power lines. And that brings up one point of collision avoidance for safety. If you are drone mounting this scanner and flying it, there is collision avoidance built into the point cloud that can detect something as small as like a 1 millimeter wire hanging down. So it's a very safe unit to fly. I know it's a lot of money to put in the air, but it is protected and there are a lot of fail safes built in. Here's an example of something like what JUB just did, the type of data you're going to return on vertical shafts. Here's an outdoor industrial plant. Also, we have the option to fully colorize a point cloud as well. You can mount a GoPro and basically a time algorithm will line up the time of your GoPro video with the time of your scan and then give you a fully colorized point cloud to be able to extract targets a lot easier, distinguish between features. There's a lot of benefit behind that as well. So I'm just going to scroll through a few more of these and kind of open it up for questions. If there are any, and if not, I appreciate you guys listening to me. And if you do have questions, you can reach out to me directly. So here's some examples for bridge inspections as well. Piers and ports.
Yeah, it looks like most of these were taken from a drone, is what it appears.
Yeah, and I've seen in the building and construction, using it as a handheld and walking around floor plans, you can collect floor plan information very quickly. And it won't be multiple setups, it's done on a single setup. So like I said, the versatility and the time that you save is huge on that. I did have a question earlier on cost. There are 3 different programs for cost. There are 3 levels of autonomy that you can pay for. Let's start with the first one. It's an AL0 autonomy level. It's basically, you can mount this on a drone, but use DJI specific software. You can walk the scanner or car mount it.
The scanner itself would start at roughly $60,000 with attachments, and ranges up to AL1 at around 90,000 to AL2 and full autonomy at about 120 to 130,000, depending on which drone you want to.
You got faint there, Mikey.
What's that?
You just were going faint.
Oh, okay. I was just talking pricing. So like I said, the 3 levels of autonomy for pricing, AL0 using DJI specific software to fly the scanner. That one starts at around $60,000, and then you add attachments such as the drone, which can run up to about $10,000. So anywhere from 60 to 75,000 for AL1 operations with collision avoidance built into your scanner, but not fully autonomous. That one ranges up to $90,000. And then if you wanted to go fully autonomous in AL2 mode, that could cost you up to anywhere from 120 to 130,000, depending on which drone you mount it to. Other questions? Okay, so we got a question. How does the Hovermap scan data compare to the X7 and SX12? Being that it is a SLAM-based scanner, you can expect it to not be quite as dense of a point cloud as, say, an X7 or an SX12 would be. The one benefit to using the Innocent scanner compared to those two would be the time saved collecting data, the amount of data you can collect in a short amount of time. Also, the areas that you can reach that you wouldn't be able to with an X7 or an SX12. You can get into areas that are hard to reach, hard to map, and hard to measure. Another question.
In terms of precision, though, they're roughly the same, though, right, Mikey?
Yeah, and it's going to be a very dense point cloud, very dense and rich, and it's very, very similar output that you'll see in either Cloud Compare and TBC. Yeah, good experiences. I know the panoramic pictures of the X7 is something that you won't get from the Hovermap scan. You won't get the rich colorized point cloud like you would with the X7, but data will be there. I think that was it for questions, right, Ryan? Yeah.
Okay, well, that actually brings us to the end of our presentations and really to the end of our day.
We have one final poll for the grand prize winner that I'll launch now.
Okay. As you guys are answering that last question, as we're compiling the attendees for the grand prize giveaway, and Em, I don't know if you have a picture of that transit, if you could, or maybe even make Marty the presenter possibly, so we could get a picture of that.
I do have a picture. Let me pull it up.
I'm back. My computer decided to restart itself. Sorry about that.
That's okay. We were just saying thanks continuously ever since we lost you there. Was there anything else that you wanted to share though, Matt?
That was basically it. I mean, it was a pretty annoying problem we ran into that was made a lot easier. So it wasn't too complicated what we did by any means, but it made it so our data was much easier to collect.
Right. Yeah, when I lost you there, I was just pointing out that cage. It was in that picture and people probably noticed it, but it's pretty much bulletproof in that cage. And so even as you guys were lowering it down there, it protects the scanner well. And so there's accessories like that work with that scanner. Okay, well, while we're compiling this, were you going to show a picture of the transit? There we go. There she is. Hopefully everybody can see that okay. So that will be our grand prize giveaway. And I think we're compiling those now. So while we are, let me just give a final thank you to everybody that helped participate and produce this virtual conference today. It was something that we've never done before, so we definitely had some nervousness about the technology and about how well received it was going to be. And we've been, so far, I think we've been very enthused with the number of attendees that we had and with hopefully the content. Sometimes these can be a little bit like an infomercial. There's always that aspect to it when you're talking about new technology. And so, but hopefully you were able to see what is available out there, what the technology has done over the past year, and the hope that also that because it was presented by some of our end users, that it wasn't so biased towards manufacturer and the type of equipment. So I just want to thank Chad and Sean for coming on, and also all of our other presenters, Brad, Riley, Trent, Kent, Ben Slater, Ben Scogan, Pete Mestemaker, and Eric Hall, and of course, Matt Gillins for taking their time to not only be here with us today, but also create these presentations and share them with us today. So I just want to thank everybody for making this happen. We'll see how this goes, whether we do another one of these next year. There's definitely pluses and minuses both ways. So, all right. Anything that I am forgetting before we announce the grand prize winner, Emily?
I just wanted to say thank you to Troy and everybody at Monsen who helped put this together. Like Troy said, it was kind of a curveball for all of us to do it virtually, but I'm really happy with how it turned out, and hopefully all the attendees feel the same.
Marty, is there something that you, thank you, Emily, I appreciate that. Marty, is there something you wanted to share about this transit that you refurbished?
It's, at least pre-1920, it's probably from around 1910. It's kind of a cool unit. It shows really well on a straight leg tripod like that. It's a convertible level. It looks like a Y level, but you take it out and you turn it 90 degrees and put the axles in some V blocks, and then it makes it a transit. So, but I've got one just like it in our showroom that I won't let go. And I came across another one and thought it'd be a great giveaway. And it'll be calibrated. It'll be calibrated when we ship it.
All right. So actually, the optics still work in this sucker. You can still use it as a transit and as a level.
Yes.
All right. I actually do have the winner here. Anything else before I make this announcement?
I think you're good to go.
All right. I'd like to announce the grand prize winner of the transit, Darren Williams. Darren Williams, Wall Consultants. Yes, Darren's probably falling over right now. Just
we can only imagine.
Is so giddy with delight. And so it is very cool. I know Darren well. I know Darren will appreciate this. He's young enough that he probably doesn't have a lot of instruments like this on display. And so this will be hopefully something that he will treasure. So, and Darren, you're welcome to chat in there and just say, I mean, wipe away the tears first before you start typing, but your thoughts. So, all right, guys, that is everything. Thanks again. I appreciate this opportunity, and I think it's been a successful users group. And please contact us if you have any comments or questions, and we will definitely be in touch with our email with the link to this recording, so you can watch or listen to any of these presentations, and also so you can get your continuing ed certificates. So thank you once again for everybody's participation and for being here today with us. And with that, we will sign off.